For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Ladies and gentlemen, thrilled to have you here for another epic debate. I'm your host, James Coons, and welcome to Modern Day Debate. This is going to be a fun one, folks. So we have two seasoned debaters with us, two very clever and quick on their feet type debaters. This is going to be a lot of fun, folks. So want to let you know, if it's your first time here, consider hitting that subscribe button, as we've got a lot more debates coming up. We are very excited. In fact, I got to show you just a few of these because they're going to be epic. So first, RN Ra will be facing off with Dr. McElroy. That's going to be a big one, and that's going to be in person. So we're actually going to be streaming that, live streaming it from Dallas on our little, you could say, mini debate tour. So that's going to be a big one. Then, also want to mention, Nathan Thompson and Team Skeptic will finally cross swords. So they are going to be debating a flat earth debate. That's going to be a lot of fun. That will also be in Dallas. Whew. Hopefully, things don't get too crazy. It might, who knows? I don't know. You know, it's going to be, we hope it's not a fist fight. You know, we'll be all right. We're going to make it, folks. Next up, I want to mention, if you haven't seen this, where have you been? Have you been living in a cave under a rock? Michael Jones from Inspiring Philosophy and Matt Dillahunty will be facing off during our Texas debate tour as well. So, folks, I am pumped for that. It's going to be a lot of fun. That will be streamed live and in person as well. So, want to let you know, for today's epic debate, both of our speakers have their links in the description. So if you're listening and you're like, I like that, I want more, well, you can get more just by, it's like that little description box down there. You can find more right there. So, with that, dear goodness, I just realized, remind me, the format, if I remember, oh, that's right, I do remember now, thanks. It's a 10-minute flexible opening. So that means, like, we'll give them, like, a little leniency, but, like, once it gets up to 12, I will be so happy to cut Standing for Truth's mic. I mean, I will. It's going to feel terrific. So, I told him, I said, don't go over 12. Don't even think about it. So after that, we're going to jump right into open discussion, which I think most people, it's like a lot of fun there, followed by Q&A. So if you have a question, fire it into the live chat. I will pull those questions out of the live chat, and super chats go to the top of the list, and also allow you to make a comment during the question and answer if you'd like to do that. So with that, very excited, folks. We're going to jump right into this. And so thank you very much, Erica and Standing for Truth, for being here, first of all.
Well, do we get to comment on that? I'm excited to be here. I'm ready to have a good time on this potential eve of World War III that Twitter's been going on and on about. So there's nowhere I'd rather be than here.
Glad you are here.
And that goes for me as well, James. I'm really looking forward to it. Love this channel. Everybody, please like and subscribe. Hopefully, Erica and I can help make people's night a little bit better after the yes, like Erica said, the World War III scare. Hopefully not.
Yes, we hope everything is safe with that. And so it's been sort of a wild day, and we are glad to be here with you together. It kind of gives you the big picture. We've talked about this before. It's like we debate. Sometimes we even get a little snippy with each other. But at the end of the day, we agree on the big things, like hopefully making the world a better place, stuff like that. So with that, very excited to get the ball rolling. And if I remember right, Standing for Truth, are you getting the ball rolling, or?
Ooh, I think it might be me.
Erica, sorry about that, you guys.
Yes.
Long day.
Yes.
Fair enough.
No, please, don't worry about it. I think it's because I'm the affirmative, but I'm not positive.
Deal. And I'm going to set the timer for, like I said, 10 minutes. I'll just let you know once you get up to 12 if you get there. And Erica, the floor is yours. Thanks for being here.
Okay, cool. So my name is Erica. I go by Gutsick Gibbon on YouTube, do a lot of videos on anthropology and bioanthropology and primates because, God, I love primates. I got a BSA in animal science, picked up a minor in biology and one in anthropology along the way, and I'm currently getting my master's degree, a master's of research in primatology, hence why I love the primates so much. So, human evolution, an undeniably wonderful journey. Now, from my standpoint, there is indeed so much support for human evolution across numerous fields that cramming it into a 10-ish minute opening statement is going to be kind of tough, but I am going to try to do it. Now, as I mentioned last time in my conversation with Kent Hovind, even Carlos Linnaeus, who was a creationist, admitted that humans are indeed primates because he recognized that we were eukaryotes, animals, chordates, vertebrates, mammals, eutherians, and so on and so forth down the line. And he also realized that similar to how this rhesus macaque here has its nostrils opening downward and how it has the dental formula of 2123 and shares 93% of our genetic similarity, we are both catarrhines. So the same reason that you would classify this rhesus macaque as a catarrhine, you would use to say, oh, well, I guess humans fit into that category as well. And I happen to find that very inspiring and cool. So we don't have to just use morphology, though. We can also have a conversation about paleontology, which happens to be a favorite of mine, because evolution can indeed make a prediction. If evolutionary theory is accurate and humans did indeed evolve from an ape-like ancestor, which we would currently in the field consider Sahelanthropus chadensis, then we can say that if we share a common ancestor with chimpanzees, we should see the emergence of human morphology through geologic time. And paleontology displaced this gradient from our ape-like common ancestor with chimpanzees, Sahelanthropus chadensis, to modern humans. So essentially what we're saying here is if this is indeed the case, we should see slowly through time the appearance of novel human traits. And with this comes the macroevolutionary concept of speciation. So while B may not be able to interbreed with E, B may have been able to interbreed with C. And through this concept of small, novel microevolutionary changes, if you like, we do indeed see evolution occur. But of course, that is only the case if we are seeing this massive change occur through geologic time. And that is indeed the question. I just threw this one. Forgot I had this one in here. I love Australopithecus africanus almost as much as I love Afarensis, which would be Lucy. But as I asked Kent in the last debate, if you were to pick one of these, he likes to do they have a 5-year-old come up and tell us which one is the difference in order to differentiate biblical kinds. If you were to do that here, you'd be kicking the chimpanzee out and you'd be keeping Australopithecus africanus right up here in the mix. And of course, it has a myriad of lovely mosaic traits from the semi-parabolic palate, that is to say the shape of the upper palate, ventral frame and magnum that allowed it to stand indeed bipedally, which I do hope we have that conversation today because I think it's quite a good one. Sort of some retained neoteny that's continuing, and a pelvis that is, of course, looking very human-like. But like I said, can we prove that all these organisms, according to the evolutionary model, did indeed live at slightly staggered different times over the course of millions of years and not all at the same time and then perished in a global flood? Yes, we can indeed do so, thanks to the radioactive decay law. Now, the radioactive decay law is essentially this process of spontaneous transformation, essentially decay, rather, of a parent isotope into daughter isotopes. And when we look at these minerals that we find fossils in, we can get what's called an absolute date by looking at this ratio. Now, the radiometric decay law, radioactive decay law, is indeed a firm law in physics. It additionally covers the nature of decay constants and half-lives and indicates that to our current knowledge, decay cannot change in any meaningful ways in nature. Because frequently, what creationists tend to do is they say, oh, well, maybe it worked differently in the past, or maybe the flood accelerated this radioactive decay and gave us these dates that seem to say millions of years. But there's a problem with that. And that problem is when things decay, they release a ton of heat. Now, we're going to talk about that in just a second. But the RAPE group, which is a Young Earth Creationism group, they were discontinued back in 2005. They spent a ton of time trying to prove that you could indeed accelerate this without problems, but they couldn't. And this is a quote essentially from that report. They admitted that a young Earth position cannot be reconciled with the scientific data without assuming exotic solutions will be discovered in the future. No known thermodynamic process could account for the required rate of heat removal, nor is there any known way to protect organisms from the radiation damage. And interestingly enough, a Tufts geologist went ahead and decided, all right, let's see what happens if we try to cram all the heat that results from accelerated decay from a 4.8 billion year old Earth to a 6,000-year-old one. And it's not a good situation, folks. He essentially found that at the time of Adam and Eve, if you're cramming all of that heat release into a 6,000-year time scale, the surface of the Earth is going to be 70,000 degrees Celsius for every square kilometer. And at the time of Jesus' birth, assuming a generous geothermal gradient, we're going to see around 400 degrees Celsius for every square kilometer. There's a link at the bottom there, and I could give to James if you'd like. But essentially, As far as we know, radiometric dating works because there's no reason that it shouldn't. There's no empirical question that has essentially been raised to say, well, what if it did work differently? It's rather firm. But of course, genetics are some of the more interesting and novel supports for human evolution that have popped up recently, because when you align our genomes side by side with the members of genus Pan, that would be the chimpanzees and the bonobos, you get a 98.8% similarity when you're coding for, or when you're comparing coding base pairs, which is fascinating and very cool, because when you compare their genome to the rest of the apes, you find that they are actually our closest living relatives just as much as we are theirs. They share more in common genetically with us than they do with a lowland gorilla, which is really cool. Now, I said this to Kenta as well, but essentially that genomic comparison I just mentioned is just a souped up version of a paternity test. So the key thing to take home here is that if relatedness is determined by genetics in humans, why isn't it the same across species? But we can also look to the chromosome 2 fusion. So human chromosome 2 is a fusion of 2 chromosomes found in the other great apes. How do we know this? Well, this is a little picture of a chromosome, and it's tipped with telomeres. Now, the cool thing about that is telomeres have a very specific identifying sequence, which is TTAGGG, and its reverse, which would be AATCCC. They also have centromeres in the middle. So essentially, if you are accepting of evolution, you're going to make a prediction that human chromosome 2 is a fusion of these 2 hominoid chromosomes, 2A and 2B, sometimes 12 and 13 is what they're referred to as. So we should find telomeres in the middle of human chromosome 2, because if they're fusing, right, they should fit together like that, and you should find endpoints in the center of our chromosome, with the upper portions of that chromosome being nearly identical to those separate chromosomes in the apes. So is that what we find? Yes, it is. It's very cool. So the banding in human chromosome 2 matches almost precisely to the banding in the chimpanzee chromosomes 12 and 13, 2A and 2B, like I mentioned earlier. And then you have this inactive centromere in the center. Interestingly enough, and I do hope we get to talk about this as well, but this centromere is known to be a centromere, even if it may have a functioning gene on top of it, because it does indeed contain that TTAGGG sequence that I just mentioned. So this is a prediction that evolutionists made that did indeed come true back in 1991. This is the title of the paper. It's a good paper, a little lengthy. So we could also talk about the gulo breakage. So the gulo is essentially a broken gene that in most mammals allows them to synthesize ascorbic acid so that they can make vitamin C and they don't have to eat it, whereas we have to eat our vitamin C. Essentially, this would have broken around 61 million years ago with the omomyids and the adapids, which are little almost tarsier and shrew and lemur-like guys. This means that, like I said, we can't synthesize our own vitamin C. But the interesting thing is this breakage is in the same location in every single primate that is a haplorhine and onward. And furthermore, while gulo breaks also occur in other mammals, it's only in the primates that we get the CAMP gene expression by vitamin D. So what creationists need to invoke here is a separate occurrence of this breakage in every single primate lineage, as well as a separate CAMP alteration. That's a hard sell for me. We could also talk about the trouble with tools. So I didn't bring this up last time, but I think it's quite an interesting one. So essentially, there's trillions of tools strewn all across the African continent. They're typically these napped tools that we see, like Oldowan and Oldowan style tools that you get by taking 2 rocks and kind of chipping them together in like the classic caveman sequence. And there's no natural way that these tools can form. You can look at a cool picture of them. You're not going to get this by rolling a rock down the hill. But we have 15 to 150 trillion with the T of these guys laying all across the African continent, based off of an estimation of 250,000 stone tools found in approximately, per square kilometer in Libya, which is a whole lot of tools. So yes, it's a bit extrapolated, but let's see, 250,000, that's quite a few in and of itself. So the question is, how do creationists deal with all these tools? Because under an evolutionary lens, right, we've got several million years for organisms like Kenyanthropus platyops or Homo habilis to make all these tools and leave them all around as they migrate across the continent. So it's basically a numbers game, because the Young Earth Creationists kind of hold, generally speaking, at least Answers in Genesis does, where I got this lovely timeline, that there's a Stone Age that occurred approximately 500 years maximum. Yeah. And this would be essentially when everybody left the Tower of Babel. So you've got 500 years, you've got 25 years per generation with a replacement rate for the population, 10,000 artifacts produced by each person in their lifetime. and an average population size of about 100,000. Can you get all these tools with those population rates given by Answers in Genesis? And the answer is no, you can't. It's very problematic. So Young Earth Creationists essentially have to have a small band of people leave the Tower of Babel in 2250 BCE, migrate to Africa, forget all of the technology they once had in Mesopotamia, learn how to fashion rocks into tools, which is a technology in and of itself, and extract 40 million pyramids worth of rocks from all over Africa, fashion them into 15 trillion, and that is the lower end of stone tools before placing them all across Africa in approximately 150 to 500 years. To steal from Kent here, that's imagination stuff. It's not going to happen. So essentially, to prove human evolution wrong in this context here, you're going to have to invalidate genetics by relatedness and genetic similarities in human genus Pan across their genomes, the human chromosome 2, and the Gulo break. We're also going to have to produce a mechanism for accelerated decay that solves the heat problem, which I think is going to be somewhat difficult. We're also going to have to introduce morphologic means of separating the humans from the rest of the apes. And we're going to have to produce a mechanism for those tools to form naturally, or a proper population growth that is going to account for all of them in such a small time frame. So I'm going to cede the rest of my time because I'd like to get to the discussion.
Thank you very much, Erica. Next, we will go over to Standing for Truth for his opening statement. And Standing for Truth, I have got the clock set, and the floor is yours. Thanks for being here. Bet you have yourself on mute. Whoa, wait a minute. I think. Oh, no, okay, full screen. Okay.
There it is.
I thought I lost you. Okay.
Let me move this to the side. Okay, let me start my timer as well, just so I know. Let's see here. I got it set max 12 minutes. Okay, let's go. Okay, thanks so much for your opening there, Erica. I'm going to try and cover as much as I can. I've got my opening here. I'll address a few things that she talked about earlier. For the decay rate, according to catastrophic plate tectonics, if rocks were exposed to heat and pressure, this could speed it up. Heat from below the crust coming up to the ocean, then to continents, of course. So volcanic activity hitting rocks worldwide. She talked about human chromosome 2 fusion. Well, that purported fusion site's actually a functional DNA element in a human gene, so that's been overturned. When it comes to the human-ape similarity, they say it's about 99%, maybe 98%. New incoming data suggests that it's more like 88% similar. That's 400 million DNA differences that separate apes and humans. Also, the chimp genome is 12% larger than humans, so that helps separate us from chimps. They ignore things like copy number variations, and of course, there's huge gaps on human and chimp DNA. So let's get into it here. Debate human evolution. Looking forward to this one. Let me see. Okay, can you see my slides?
You can see them.
So she talked a lot about nested hierarchies as well. I'll get into that. There exists, though, an unstoppable crisis for those that believe apes, humans, and banana plants are related through common ancestry. Now, this crisis is that of genomic degeneration. The evidence is absolutely overwhelming that mutations are accumulating. I'd like to ask Erica to provide us with a type of selection or mechanism that can rid the population of so many deleterious mutations that are mostly unselectable and invisible to selection. So unfortunately for human evolution, which is the topic of this debate, both ape and human genomes are degenerating due to this mutation accumulation. This evidence is extremely strong. This strongly indicates that neither ape nor man could have evolved. They both must degenerate. In fact, many of the hominin fossils here that Erica uses to prove ape to man evolution clearly display anomalous pathologies that indicate that in the past, several isolated and inbred human populations have experienced reductive evolution. This goes for Homo neanderthal, Homo erectus, Homo naledi, the hobbits, of course. There is no progression. This type of reductive evolution has resulted in genetic pathologies, reduced body size, reduced brain size, and as a consequence, tribal extinction. This is expected given a biblical-based model of post-Babel conditions and post-Babel dispersion. Genetic degeneration is a very real phenomenon occurring in living populations. If what we observe today in the present is reverse evolution and not forward evolution, the same thing would have happened in the past. And it is very well documented that what we truly observe in the hominin fossil record is genetic degeneration. For example, numerous of the bones of the alleged Homo species like Hobbit, Erectus, Naledi, Neanderthal, the ones that she used here in her opening, appear to demonstrate testimony of severe inbreeding and genetic decline. Therefore, many of the troubling human fossils that Erica used in her opening presentation are much better understood to be devolution rather than evolution. The so-called primitive features that Erica here points to as a progression from ape to man is actually genetic degeneration. They weren't pre-human tribes. More accurately, they were human tribes that were persistently inbred and were in genetic decline. We can see here a paper actually that the claimed primitive humans are inbred subpopulations. This was a paper by Eric Trinkos. You can see it here. He's a paleo expert, and he noted that a total of 75 documented developmental abnormalities from 66 individuals spanning the Pleistocene. The author also explains that the remarkably high frequency of skeletal pathologies could not possibly be due to chance. This is exactly what we'd expect based on a post-Babel dispersion of isolation and subsequent inbreeding. The author suggests that these populations were almost certainly undergoing genetic degeneration due to inbreeding, as is expected in any small and isolated population. So these human variants, they all lived in isolation, and given the situations associated with each variant, the specific settings would lead to these founder effects, isolation and inbreeding. And what's funny is the author obviously doesn't conclude the biblical base model, but these findings and more strongly support the biblical base model of degeneration of small subpopulations, which is exactly what our model talks about. We got here just recently, I believe it was in 2017. This negates all her dating methods because we've got fossil footprints, anatomically modern human-looking footprints that debunks human evolution in the same layers or lower than the Australopithecines. So anatomically modern human-looking footprints have been discovered here in Crete. I believe it's in Greece. They date approximately to 5.7 million years old. So these findings here are clear evidence that Lucy, Ardipithecus, Australopithecus sediba, Homo habilis, etc., they're not our evolutionary ancestors, as Erica promotes here. And the reason is because these footprints indicate that creatures with human feet lived much earlier than these so-called human ancestors. So Erica's going to have to answer this question if she wants to look to rocks. It's genetics, genes, traits. These are what are inherited sperm and egg, not a rock, not geology, not geography, but genetics. So she's going to have to explain these anomalies to her evolutionary theory. I think this article here on Evolution News puts it perfectly. They say, when the oldest known evidence for hominin feet predates the alleged African ancestors such as Ardi and Lucy, but already shows relatively modern human footprints, what is more congruent with this new evidence when looked at without bias? A gradual Darwinian evolution, or rather a saltational origin that requires intelligent design? Just a few points here. Evidence from paleontology, archaeology, and modern genetics all irrefutably confirm that Neanderthals were in every way fully human. Erectus, for example, was able to sail, which clearly speaks of human intelligence. Homo floresiensis, which Erica helped me say in the pre-show, thank you so much, was also very clearly human, as indicated by their impressive cultural inventory, ability to sail, endocast scans that reveal a modern human brain, an anatomy that is modern human looking. Reduced brain sizes, for example, can be beneficial in certain conditions, such as starvation. This explains the smaller brain sizes that we do see in some of the hominins. This is because brains are energetically costly. This is all evolution in reverse, and these pathologies and variants can occur quickly in isolated populations. This is all expected and predicted in the biblical model post-Babel and post-flood. Nested hierarchies she spent some time on. before we even had DNA sequencing technology, it's quite obvious at the physiological level, humans and the great apes had a lot in common in terms of appearance, basic body structure. Both mammals have binocular vision, etc. There's some major differences, of course, though. Just look at the feet of the great apes and the shape of their feet. They have feet that look like hands. They use these for grasping purposes, of course, swinging from trees, etc. Now, humans have feet, on the other hand, that are built for upright walking. We are similar in these areas, and therefore we should have similarities genetically as well. This should not surprise anybody, and this is in no way, shape, or form proof that humans, apes, and pine trees are related. Now, of course, evolutionists like to look at these similarities and imagine that all life forms are related, but this is not empirical. This is actually in the realm of fairy tale. The bigger question we are trying to answer is, why are humans and great apes so similar? It doesn't matter whether we look at the anatomy, the physiology, the genetics. They all tell us that we are a lot more closer to each other than pine trees and dogs. Now, evolutionists will say the similarity genetically is the high 90s, like Erica was saying. It's just false. It's more like 88%. But regardless, we are pretty close. What does this tell us about our origins? The evolutionist seems to think to themselves that if we really are made in the image of God, shouldn't we as humans be distinct from the rest of biology? Well, maybe in a way, yes, but in another way, no. The Bible doesn't imply in any way that we have biological life and then human, which has absolutely no similarity to any other species out there. There was no reason for us to believe that based on a biblical model, there should be no type of hierarchy in the biological world. There's no reason to believe that we shouldn't be more similar to one species, for example, the apes, than to another species, for example, a wolf. Naturally, we as humans have designed things with groups within groups patterns. If you were to look at the types of vehicles or modes of transportation humans have created, they naturally form groups within groups patterns. A sedan has a tremendous amount of similarities with other sedans. Now, a semi-tractor trailer is obviously much different than a sedan or a car, but these two modes of transportation are similar enough to each other that it sets them apart from airplanes. This is the groups within groups patterns that emerges when we look at all the modes of vehicles or transportation that humans have designed. This is an empirical observation, and this is something we naturally do. It appears that God created kinds in the beginning that are different from us as humans, as well as kinds of creatures that are more similar to us. This is a reason why Aaron Ra's phylogeny challenge is fallacious. We too predict nested hierarchies, morphology, anatomically, and genetically. Evolutionists miss the bigger picture. Yes, we can find hierarchies in all of biological life, including humans and apes, but apes don't build airplanes, apes don't write books, apes don't compose symphonies. Chimpanzees and other animals don't do any of these things. Mankind has built the space shuttle and has accomplished wonders. So yes, there are groups within groups patterns in all of life, but this is simply a hallmark of design. The fact that there exist these natural and nested hierarchies is exactly what we'd expect if God created the world. We can see here, even if we got into transitional forms, we create things that blend the features of two different types of vehicles, amphibious assault vehicles, for example. We can see here that all the evidence regarding mitochondrial DNA, Y chromosome, the low genetic diversity that we see all points to Adam and Eve. Evolutionists need to ask themselves, if they have an open mind and they were to look for evidence for Adam and Eve, what would they expect to find? Because all human beings are profoundly similar genetically, and this points directly to creation. I'd like to talk to Erica here about the evolutionary out of Africa bottleneck and how that may be feasible.
1 minute.
I've got 1 minute here. Therefore, going into the discussion, a few questions that I would like to ask her are: the out of Africa scenario, due to the resulting inbreeding of a population bottleneck of 10,000, how is this even remotely feasible? I'd like to ask her about the Y chromosome of apes and man and how they're so dissimilar, less than 70%. The Y chromosome should be the most similar. So I want to ask her that question, as well as genetic degeneration. These near neutral deleterious mutations are accumulating. What type of selection can stop this genomic degeneration? I've got a lot more here, but for the sake of time, we'll save some of that for the discussion. Thanks so much.
You got it. Thank you very much, Standing for Truth. We will now shift back to the dialogue boxes and let her rip. So, thanks for your questions so far, folks. A lot of great questions. Excited to ask those. And now we'll go into open discussion. So the floor is yours.
Okay, well, there's definitely a lot to talk about. First, I would like to quickly say they have actually tried time and time again to speed up or to accelerate decay with heat and pressure. And the most that they were able to do was 1.5%, which I believe it was I think it was Woodmarap, who's a Young Earth Creationist, commented on it and said, "Yeah, that's nowhere near good enough. We're going to have to, invoke some exotic solutions here." So, I mean, it's easy to say, yeah, we could just have a lot of heat and a lot of pressure, but that's never been demonstrated in the slightest to be good enough to get it anywhere close to what you need, especially because that 1.5% increase of decay wasn't even in a geologically relevant element. But more specifically, I would like
Well,
to talk about.
if I could just respond to that real quick.
Yeah, sorry, go ahead.
No problem, no problem. I do think that the entire, radioisotope dating, the methods, for example, they do have unprovable and unknowable assumptions, right? For example, are the initial conditions of the rocks known? Clearly they aren't. So geologists, they weren't there when the rocks form. So at the end of the day, they don't know, right? For example, how do they know how many uranium atoms, if they had no lead atoms, for example? But I think it comes down to the fact that we do find now these anatomically modern looking human footprints in layers, either with the Australopithecines or lower. Therefore, how can there be modern human looking footprints in layers with our so-called Australopithecine ancestors? So
Yes, so I would love to talk about that Crete footprint because I have looked quite extensively into this. I had this question asked of me about a year and a half ago on the Debate Evolution subreddit. But to quickly kind of take a step back and make kind of a comment on that, on the radiometric decay thing. Yeah, we kind of do know the starting ratio because we do have rocks that do indeed form today. I see no reason why, since we've literally never observed a rock forming that didn't have a complete, parent favored ratio of isotopes, why we should expect that back then it was different, especially because, and of course, I'm sure we can have a conversation about mutation rates. There are reasons why we do say, well, some rates are constant and some are not, but there is, of the hundreds upon hundreds of thousands of times that we've radiometrically dated things and observed new rocks form, we've never been given any reason to suggest that ratio wouldn't be in favor of the parent, and the physics inform that. But again, I probably shouldn't have included that stuff in because this is a conversation about human evolution. It's kind of my bad. I guess I was a little.
well, no problem, no problem. I definitely don't like to leave anything hanging because you did
Yeah,
bring
yeah,
up the
sure,
heat
sure.
again. I just want to say, for argument's sake, I mean, I do stand behind the fact that it's genetics, it's traits, it's our genes that are inherited sperm and egg, not a fossil, not a rock. So, I think we should definitely look to genetics, morphology, anatomy in
Sure.
regards to human evolution. But because of the heat, I do want to say, based on our model of catastrophic plate tectonics, right? Subduction, friction, for example, with the continent, will make heat and make the rock more plastic. So indeed, this subduction can happen rapidly. This is actually called runaway subduction, or speed up the subduction, which can explain the necessary speeding up of the decay rate. But in regards to the hominins, which I do want to focus on, I'll let you comment on the footprints in Crete as well. But as far as I know, the dating methods commonly used to date the hominins, they do yield extremely inconsistent ages. Therefore, the paleoanthropologists seem to only use the dates that fit their story, right? So the dates that conflict with the proposed ape to man timeline are routinely rejected. Like, I'm guessing that these anatomically modern looking human footprints, the dates are probably going to have to be changed now, right? Because they've done it so many times before. These unacceptable dates are routinely assumed to be corrupted by sample contamination or whatever reason that they have, even if they have no evidence for said contamination. So it just seems like selective use of data. And you mentioned the genetics and the mutation rates. Well, I mean, we have a molecular clock regarding the Y
Sure.
chromosome and the mitochondrial DNA, which actually brings us back to 6,000 years. So, I mean, if you want to talk about dating, we can look at traits, genes, and genetics. That
Yes,
gives us a
I
date of 6,000 years. Go ahead,
well,
Erica.
I'm totally with you, but that, I guess I kind of opened Pandora's box there because that was a lot of points. So I would very quickly, I'm going to make a comment on Crete, on that Crete footprint. Have you seen a picture of it? Because I have. Did you look up a picture of it?
Yes.
Yeah, it's not very footprint-esque, especially considering what trackways tend to produce, especially given the sediment that it's kind of placed in. It's very unlikely, at least amongst the professionals that I have spoken with, that is actually a footprint at all, specifically because it's a single print. It's not, there's only one print that's being proposed. It's not a trackway like the Laetoli footprints where you've got, dozens of footprints with where you can actually take a plaster cast and get the balls of the feet and the toes and the heel, and you can actually see how the individuals that made those tracks bear their weight. You can't do that with the one in Crete. And
Right.
I tend to think, if you go out and you pour a bunch of water in the mud and then you walk through it, you're not going to get one footprint. So I actually, everything I have seen on the Crete print suggests that it is not a print at all. And at least, and moreover too, one print, let's say you could prove that it was a print of something, right? That wouldn't overturn the entire timeline that we have now, particularly because we know for a fact that Europe used to have a booming population of primates. It would indeed be entirely possible that you would have apes living in sort of the Oligocene and the Eocene.
Isn't it true that these footprints were found outside of Africa? And are you saying there was only one set of footprints that were found? And because from the article that I had posted in the opening presentation, the headline does say ancient footprints in Crete challenges theory of evolution, but what actually made them? I've looked at the source material as well, and I didn't find any data suggesting that they weren't actually footprints. I saw some paleoanthropologists or some scientists in the field claiming that maybe it was some type of extinct gorilla that had a footprint very similar to modern humans. But I didn't see anything about what you're claiming. So I'll definitely look into that. But if they are footprints, especially if they're outside of Africa, I think they're near Greece.
Yeah, they are.
That could challenge the theory.
It would add a lot of nuance to it if they were indeed footprints. But again, I would heavily suggest looking into it because I read the paper and then I looked for commentary on the paper, and then I also asked a past professor of mine kind of what his thoughts were. And everything that I've read is suggesting, one, it's very likely not not prints, because all I could find was, as far as pictures go, was a single kind of imprintation in the sediment that does, first of all, it doesn't particularly look like it would be in the shape of what you're kind of proposing as an anatomically modern human print anyways.
Are you saying that it looks totally...
Hold on. Oh, forgive me.
Sorry.
Just to be sure that because there's a lot of info going back and forth, I want to be sure that she gets plenty of time to respond.
Of course. Go ahead, Erica. Take your time.
Yeah, sure.
One last thing about the footprints when you're done.
Yeah. I mean, my point is that it's not, even if it were a footprint, which there's very, very few people standing up and saying that it is. And even if it were a footprint, there's even fewer. I don't know of anybody saying this is a hominid, or rather, a hominid. It's the wrong shape if you're trying to propose that this is anatomically modern. That's all I wanted to say about that. I don't find it very compelling.
If you're done, I definitely want to see. I'd want to see the paper or the source that says that they're not really footprints, because I've looked into it thoroughly and I never seen anything of that. So I'll definitely reserve judgment until I see that paper. But you did mention Mary Leakey, which about 25 years ago discovered some footprints, which are in all the source material that I looked into and everything that the paleoanthropologists described it as being indistinguishable from modern human footprints. So
100%. I have got to get it on this, because I had a conversation. I used to get coffee with a Young Earth Creationist friend of mine who was a coworker, and we had a very lengthy conversation about the Laetoli footprint. So I am on top of this.
Well, before you explain it,
sorry. Go ahead.
Okay, so you would agree that they do look exactly like modern human footprints, and they were these discovered or dated at about 3.5 million years ago in actually, where were they discovered?
Tanzania. They were found in Tanzania. They're the Laetoli footprints. So
the Laetoli footprints.
Yes. So as far as them being indistinguishable from humans, I'm going to tell you about a very cool study that you should look into, because I found it fascinating. Yes, they do look very similar to an organism that has an inline big toe. Now, if you look at the very, this is the difference between these and the Crete tracks, because you can see the individual toes on some of these prints are incredible. You'll see that, no, the toe isn't completely in line. It's just very, very close to being in line. So what the researchers of that project, of this paper that I'm about to tell you about, did was they were like, all right, well, let's take casts of it, and then let's see if we can figure out how whatever was making these prints bore its weight. Because essentially, as I'm sure you know, the biomechanics behind walking on 2 feet are very, very specific. It's, there you have to have, proper weight bearing on the knees, and you have to have a specific arch in the foot, which is great because you can tell from prints how something bore its weight. So what they did was they had a bunch of hunter-gatherer individuals from Africa. Someone similar to like the Hadzabe. They had a couple dozen of them walk in soft sediment, and then they took a cast. Then they had some chimpanzees walk across soft sediment, and then they took a cast. And then they took the Laetoli footprints. And did you know that the individual that made the Laetoli footprints bore its weight in a perfectly intermediate fashion between the two? And the researchers who published this paper said it is absolutely certain that whatever made these tracks was not a human and it was not a chimpanzee. And they're not even certain, I believe, that it was afarensis. It could have been a.
Well, did Mary Leakey? I'm sorry. Because I'm trying to follow you. Mary Leakey, the one that discovered these footprints 25 years ago, and she admitted that they look nearly identical to modern human footprints. I understand you're saying that there's a few differences that suggest otherwise. Did she conclude that it was from some type of hominin, or did she conclude that it's from some type of Australopithecine? Like, what was her conclusion on it?
She concluded that they were from afarensis because they have afarensis feet, and the toe is close to being as in line as an anatomically modern human.
I thought that was Donald Johanson that concluded that, because I know that he concluded that all these different bones were.
Well,
just to be sure that in case she wasn't finished.
Yeah, sure. Well, thank you, James. But I'm sorry. I do tend to go on monologues, so feel free to jump in if I kind of get going. I just get really excited about this stuff.
I definitely like to see, the data on that. It's my understanding that Mary Leakey did disagree with Donald Johanson and him concluding that all, the footprints, all the different bones that were discovered in both her area and his area were actually one species. I do want to, because we were talking about the trackways for a while, I did want to ask you though, regarding, because if we're going to talk about human evolution, right? I understand that you would believe in, would you believe in the out of Africa theory, or would you hold to more the multi-regional theory in regards to Homo erectus?
I think it's kind of important that we wrap up that past conversation, because yes, Mary Leakey and Johanson had different opinions, but the species, as if I remember correctly, and as far as the people go, I can get kind of hazy. There are a lot of people involved in the community, but at least as far as I remember, the dispute was not between whether it was afarensis or a modern human, but whether it was Australopithecus afarensis or Australopithecus anamensis, who was also in the location and has also been at least purported to have. I don't think we have the feet of anamensis in the same. We have a lot better representation of Africanus and afarensis than we do anamensis. But essentially, the dispute was not. I feel like that's a bit of a mischaracterization, right? Because it's not like Leakey was saying, "Oh, they're so close to human; they're definitely human." She was just noting how incredible it was, because the dispute that was going on at the time in the anthropological community was whether or not our ancestors, at least according to evolutionary theory, got big brains first or started walking on 2 feet first, because this would very much be indicative of a bipedality first stance. That's why she noted that they were so human-like, because it was a big find.
Right. So I do understand and agree with what you're saying, that there were disagreements. I was under the impression, I believe, that she definitely didn't at least, designate it to Donald Johanson's Australopithecus afarensis. And I know that there were some disputes whether or not all those bones, the footprints, did they belong to one species or was it multiple species? But at the end of the day, if the evolutionist does have some type of explanation regarding the modern human footprints found in Laetoli or found in Crete, I just find it funny, because evolutionists are always asking you, where's the evidence that Homo existed in these layers with our so-called ancestors? And if we point them to, say, footprints or some bones that are indistinguishable from, say, the Homo genus, then usually there's a circular argument that has to explain it away, instead of just admitting, okay, there is something that looks like Homo existed during this time. So it just seems like there's a circular argument, because the evolutionists can't admit that, yeah, these are human-looking footprints, because they don't believe that humans lived during this time. So it just seems like a circular argument. I'm not sure if it's something that just needs to be agreed to disagree upon regarding the footprints, but I definitely like to see the paper that you talked about regarding and if it was indeed not a footprint, because I haven't seen that, and then also the information on Leakey and what she concluded.
let me send you after this conversation. I will send you. I've got some awesome papers just like on the back burner that I can kind of just send to you so you can look through them yourself. But
Awesome.
it's not so much. You mentioned that it's like show me the evidence, and then we find what a potential footprint in Crete, and then human-like footprints in Laetoli. Well, no one ever thought that those were human footprints. I would challenge you to find anything by Mary Leakey saying, yes, they are certainly human footprints, or I think that they're human. Not, wow, they look really human, because they look very human, aligned with one of the primary hypotheses at the time, and it turned out to be the prevailing one. That's what we abide by today. When we look at the hominids, we see all the traits for bipedality show up way before the brain cases start exploding in size. So I don't think that it's people ignoring the evidence. This is just the natural progression of things. The Crete thing, yeah, I can send you what I got on that for sure. Because I gotta say, if your evidence that there are hominids living in Europe, and that one of them made the Crete footprint, if your evidence for that is something that may be a footprint and may not be, is all you got, considering how well things fossilize all the time elsewhere, which isn't to say they fossilize very easily. I'm just saying, to find no trace of any hominid there, rather any Australopithecine and back hominid, I don't find that particularly convincing.
Right. It just seems based on findings all the time there is. I mean, even now they agree that there's more of a bush instead of a tree regarding the, ape to human evolutionary ancestry. And then regarding certain things like fossil footprints or Crete, from what I read in the primary, source data, they are concluding that they are footprints, but, who actually made them. So I think it just comes down to the fact that I'll have to look at, the paper, the material that you're suggesting. That maybe they're not human footprints, but I think even moving away from that topic though, because I am really genuinely curious if there is any validity to human evolution. I think it's reasonable that, especially if you're in the affirmative, I've always struggled with the evolutionary out of Africa theory, because it sounds like it really does involve an extended near extinction event, but that extinction event would be associated with severe inbreeding. So for one, do you hold to the out of Africa scenario or the multi-regional scenario, and kind of go from there and maybe give an explanation as to how that might be feasible regarding Homo erectus and then Homo sapiens?
Well, generally speaking, at least as far as I know, the current consensus on things, because as far as what I think, I try to go off of my impressions of the current literature. And the literature changes, because you're right, that is the nature of science. Like the time scale has been swapped around several times in light of new information, which is kind of how science should work, at least in my opinion. You always want to be closest to the truth. But things have been changing less and less all the time. Now it's slight tweaks here and there. And as far as I know,
Right.
the general trend of the gradient of hominids has gotten pretty solid. I don't think there's been a large change in that in quite some time, other than the finding Homo sapiens quite a bit older. I think it went from 200,000 to 300,000, which is very neat. But I digress. As far as the out of Africa theory and multi-regional, I think what's currently going on, and that's not my specialty. In fact, I found that part slightly less interesting than the hominids and the morphology itself when I was taking human evolution. But I think the current consensus is that there were, I think, 3 kind of bursts where you had erectus leave, right, and diversify into Floresiensis and Denisovans somewhat far away.
Yeah, right. I believe even and sorry to interrupt, I believe in the out of Africa scenario, there was 2 out of Africas. So maybe a couple million years ago, after Homo erectus evolved, Homo erectus left the continent of Africa, and then independently on the other continents evolved into, for example, exactly what you just said, right? The hobbits.
Right. Are you certain though that? Are you certain, though, that it wasn't Heidelbergensis that diversified into Neanderthalensis outside of Africa, into Neanderthalensis? Because at least what I am aware of is that we share a common ancestor with Neanderthalensis in Heidelbergensis, not Erectus.
Well, so right, then you got Homo heidelbergensis, Homo.
Right. So then it would stand that there would be 3, right? There would be one where Erectus leaves and you get Floresiensis and Denisovans, and then there would be one when Heidelbergensis leaves and you get Neanderthalensis, and then Sapiens leaves as Sapiens, from Heidelbergensis, but staying in the African continent.
So as all these hominins are evolving, right? So Heidelbergensis, Homo neanderthalensis, the hobbits, Naledi, obviously the Denisovans, for example, and then you've got Homo sapiens that are in Africa that evolve out of Homo erectus. They, according to what I've read in the primary literature, they would have had their migration, but that was also after the fact that they had a near extinction event, because we know that every single human being on this planet is no less than 99.9% similar, right? We have low genetic diversity.
Totally.
From my understanding, I'm almost done. From my understanding, the evolutionists were kind of caught off guard regarding that. So that's why they resorted to a population bottleneck roughly 70,000 years ago that would have reduced homogeneity, right? But my question to you is, how could such a tiny, nearly extinct, obviously, Erica, they'd be genetically compromised due to inbreeding, prolonged inbreeding, suddenly explode into all parts of the planet like you talked about, and then seizing dominion over the world, whether they assimilated with all these other hominins, you know, Heidelbergensis, hobbits, Naledi, for example, which obviously hobbits and Naledi, I conclude are just humans that are genetically compromised due to inbreeding and isolation post-Babel. But if there's any validity or feasibility to human evolution, how do you explain those humans diverging from Africa, even though they should be so genetically compromised they should have gone extinct? Go ahead.
Well, no, not necessarily at all, actually, because the bottleneck that humans are thought to have experienced due to the Toba eruption.
Right.
Hold on.
Yeah.
Just to be sure that. Okay. Go ahead.
Yeah, so the humans experienced, right, a bottleneck due to the Toba eruption. Now, do we know of any other organisms that have experienced an extreme population bottleneck? Yes, we do. Everyone loves cheetahs.
Right,
cheetahs are essentially genetic. All of them are very close to being genetic twins to one another, which is indeed the two of them are much closer to one another, take any two random individuals than any two random humans. So I would say, yeah, it looks like they did an A-OK job recovering from an extreme bottleneck that was much worse than that of humans. My question to you would be, in response to that, because my point being, I don't think it's any problem having a population bottleneck. I'm fairly certain that the population wasn't even that. It was pretty small, but it wasn't that small.
How small would you say? I'm sorry to interrupt.
Before we go out on that rabbit trail, just to be sure that that last point is wrapped up.
Could she just say, is it 2,000 or is it 10,000? I've heard some evolutionists say 2,000 people, other evolutionists say 10,000. I mean, what do you hold to?
I don't know. I don't know the literature on that. I know about the Toba extinction, but that's not, like I said, out of Africa and that particular bottleneck aren't my specialty. I could talk about morphology all day.
Hold on, Stanford, just to be sure that with that before we move on to in case you didn't finish that last point, Erica.
Go ahead, Erica. Thank you, James. I was just going to say I don't know for certain, and that my kind of reverse question to you would be, if you're pointing to the bottleneck as being a result of kind of the flood, my question would be, all right, why don't all species have such a severe bottleneck? And why do the cheetahs also have a bottleneck? Why is it humans and cheetahs? You know, what's the model for that?
Okay, very good questions. I'll answer those questions. I want to kind of object to what you said. I find it funny every time I ask this question to evolutionists, I do find that they fail in answering it, because they always bring up the 10,000 cheetahs that we see in the world today. We know that conservationists, do feel the cheetah is already showing serious signs of inbreeding and genetic decline. I mean, there's just not enough of them. And it's a fact that genetic diversity in these cheetahs has eroded. And what they're seeing now is the expression of many destructive mutations. So all the answers that I get and that I find in the primary literature regarding this out of Africa are not credible, because small bottleneck populations have extreme problems. And the thing is, this bottleneck would have been prolonged, due to the inbreeding, due to the genetic compromised population of 2,000 or 10,000, they would not have been able to seize dominion over the world. That's a fact.
So why though?
Okay, unless you want me to answer. So was your question, how do we?
Oh, sorry. Right. Go ahead. Yeah. Go ahead. You can. Yeah, but go ahead. That's fine.
Okay, so why is there not, actually, if you can rephrase your question. So is there a problem with our bottleneck after the flood is what you're saying, like due to inbreeding or?
Well, I'm saying if you've got if you have a single pair of multiple individuals, you should have every single organism that resulted from those kinds essentially looking like the cheetah right now. Much worse, actually, if you're going from a single breeding pair. I mean, we consider that functionally extinct in ecology today. I mean, it happened with the northern white rhino. That is an unrecoverable loss of genetic diversity. Because you're right, genetic diversity absolutely matters. The cheetahs are experiencing trouble, but I don't know that I would phrase it as that they're experiencing, a higher rate of mutation. The problem is that their lack. I mean, maybe I don't know enough about genetics to say, but as far as I know, I thought the primary problem was that they're all so identical that if there's a single disease that hits them, they have no defense because there's no kind of variety, which is really important. But yeah, that was my question.
Yeah, and I think it all comes down to the fact of where does genetic diversity come from? Because the big difference between my view and then say your view, Erica, was that I explained the vast majority of DNA differences, right? For example, nuclear DNA differences, not by mutation. And that's what evolutionists explain them by, right? All the millions and millions of DNA differences they say are the result of mutation. But according to our model, we explain them by pre-existing or created DNA diversity. And that one genetic difference between your model and my model has massive implications for the timing as to the origin of species, for example. So if we have these differences from the start and therefore no mutation accumulation by the time we reach the flood and the population bottlenecks, for one, very little heterozygosity regarding the original created heterozygosity wouldn't have been lost. There wouldn't be any bottleneck problem. We wouldn't expect to see the same thing that we see with the cheetahs. But regarding your model, you guys do explain the vast majority, if not all, the DNA differences as the result of mutation over time. So mutation accumulation and the results of inbreeding pretty well makes your out of Africa scenario impossible. And
well, I don't see why though.
Reasoning, but nothing really that's feasible or valid. So that I'm destroys the model. Go ahead. Take it.
Sure. Sorry. Yeah. I was just going to say, I struggle to see why you're having a problem with that. I mean, cheetahs aren't doing the best that they could, but they are certainly not doomed to extinction, and they have a much tighter population bottleneck than that the ancient humans are proposed to have had. So I don't understand why you're saying, I mean, the cheetahs did it and they're still doing it, and the humans' problem was less. So I don't see kind of like, I feel like you're kind of saying, oh, it's a problem, but then it's like, why is it a problem? You're not providing a reason other than saying, well, it's bad, there'd be inbreeding. Well, there might have been, but it clearly wasn't too much of an issue. I mean, that's kind of like,
well, exactly why you say it must not have been an issue, because you have to hold to that primary assumption that ape to man evolution actually occurred. But the reason why is because that evolutionary bottleneck hypothesis, like I said, it involves an extended, that's the problem. It's extended. It's not one generation like our bottleneck. It also involves a lengthy near extinction event. So that is a fairy tale, because that hypothesis is associated with severe inbreeding is not even remotely feasible. What you said about the cheetahs, yeah, conservationists are trying to keep them alive due to the recessive mutations that are being fixated in the populations. I mean, their sperm is degenerate. They probably will go extinct. They would have gone extinct if it wasn't for conservationists. But this,
not at all.
2 to 10,000, well, this 2 to 10,000 population of Homo sapiens that came out of Homo erectus would not have been able to seize dominion over the entire planet. Plus, there's evidence that all of these populations you're talking about, right? I liked your analogy on your last debate about Middle Earth, because I love Lord of the Rings. Yeah, it was kind of like that. You got Neanderthals, hobbits, Naledi, Heidelbergensis. You've got the Denisovans. You've got them all living at the exact same time.
So I guess we can just kind of leave it at agree to disagree. I don't particularly see a problem being, with such a bottleneck, considering that we've seen others. I would like to, if it's okay, since I would like to maybe take a turn picking a topic, I would like to talk about chromosome 2, because you brought that up in kind of a, well, it's been overturned. I would say not in the slightest. Let me fix this here. My thing fell.
I just want to ask the moderator because, yeah, obviously I want to talk about chromosome 2 fusion. I know we had a 30-minute discussion. I want to know how much time we do have to talk about chromosome 2. James?
I've got flexibility with time if you guys do, but that's...
Yeah, I could go all night. I'm good.
So I think we've got enough time to go, like, we go for another 45 minutes, including Q&A, like, which would be like 25 minutes at the end, maybe even 30. So I would say if we go maybe for discussion-wise, maybe another like 15 minutes, and then go into the Q&A.
Sure.
Sounds
Perfect.
good. Yep. Okay. So
Okay,
what would
so-
be, yep. Okay. Go ahead with the chromosome 2 fusion. What would be your objection, I guess, to the claim that I made overturning it?
Okay, so, well, this would be kind of it, because Jeffrey Tompkins is known for being the guy when it comes to debating the human similarities with chimpanzees, which I did look into that 88% claim, and it is somewhat, I hate to be kind of sassy, but it's very abysmal. First of all, he used an extremely buggy version of BLAST when he got that first 70% number, and no one can seem to get that 88-ish% number when they're running BLAST how it's run in every single other species. It was kind of, as far as I know, it was revealed that he was essentially saying, all right, if you have a strand of DNA and there's a single base pair difference in the middle, that goes from being 100% identical to being 50% identical, which is very interesting that he's choosing to run it that way with humans, considering we don't run it that way with any other species. But with regard to human chromosome 2, essentially Tompkins argues mainly that it's not a fusion site because there is a functional pseudogene at that site. Now, first of all, it would be functional in that it is indeed expressed. It's barely expressed, first of all. I mean, it's barely interpretable from noise in the background. But yes, it is there. But there's also a promoter.
Okay, wait a minute before you go on too long, because I just want to touch on that part that you just said.
Sure.
Because you're right. We do look to that reputed fusion site, and we're saying that it's overlapped by a functional gene, okay?
Yeah.
So that so-called fusion site is, we're arguing that it's not actually a fusion site at all. It's indeed a functional component of that DDX11L2 gene. But are you aware that that so-called fusion site does lie within the first intron of that gene, and that it also is an active promoter for the transcription of an alternative transcript, Erica? It also binds at least 12 transcription factors, and it initiates RNA transcription, which begins with its own sequence, and it has a chromatin profile that further supports its active promoter status. So why do you say that there's barely any function and barely any activity there, when these are the facts that we understand?
Well, you say all those things as if they're this grand and vastly vital process. But if that were indeed the case, and I'm not a geneticist, so I don't know this for certain, I would imagine that it would show up as more than just noise in the background. I mean, you had to scrutinize that this portion of the genome to essentially even find that there was a pseudogene there. And furthermore, are you aware, Standing, that there are the calling card for telomeres right at that fusion site, constantly and consistently repeated, this both the forward, which is TTAGGG, and of course the reverse, which is CCCTAA, and they're flip-flopped just like they would be on the two opposite ends of a telomere. So I don't, and as for there being a functional gene, it's also been.
Are you talking? Hold on, one second. Let's just.
It's just because genetics.
Hold on, okay. I know. Just to be sure that we get plenty of time, we'll let her wrap up. If you can wrap up this point, Erica, and then we'll kick it back.
Yeah. Sorry. Yeah, I was just going to say. Furthermore, there just being a pseudogene there that is indeed functional. We see functional pseudogenes on fusion sites in other animals that have been accepted to have had telomere chromosomal fusion, even by creationists. This is a paper that was done on equids, where it does indeed happen. So and I can provide that paper for you too if you'd like. But essentially, as far as the conventional science goes, there is like actual empirical evidence that promoters can cause pseudogenes to essentially relocate onto a fusion site. So I don't understand, essentially everything rests on this being a functional gene, but that's not problematic. It's been shown in other animals to be A-okay.
Well, I don't think it's just because of that, because you did talk about the telomeres, right? The ends of chromosomes. And yes. I'm sure you would agree that telomeres, they are served in our genome as end caps that actually protect the DNA. And one of their jobs in protection is to prevent fusion to begin with. So why were they even involved in this so-called reputed fusion if one of their jobs is to actually prevent it? And from my understanding, this apparent hypothetical fusion, which obviously we can't observe happening, two questions. Why can't we reenact it in a lab today? We don't have any DNA from fossils to see, how it happened, if it actually happened. And lastly, it's not really evidence for ape to man ancestry anyways, because even if I conceded that there was a chromosomal 2 fusion, as you know, we've got the chimp and human ancestor who split. And then in the human line is when this supposed chromosomal 2 fusion occurred. So either way, it's indirect evidence for ape to human evolution. So that's no help to you. And secondly, we have all these discrepancies showing that possibly it isn't even a chromosomal 2 fusion site to begin with. So it's kind of like 0 for 2 for the evolution.
Well, but the problem for that is there aren't refutations. Like I said, this is a known phenomenon. I mean, this paper was in 2013. We've known this for 6 years, that this fusion sites can indeed hold functional pseudogenes on top of them too. Why it's important is because creationists for the longest time were like, well, there's a chromosome difference. They can't be related. Well, yeah, they can, because what if the chromosomes fused? And look, they did. And this was a prediction that was made and, met. And the only as far as what you've said here and what I've seen from Tompkins, the only essential refute isn't even a refute. It's basically a guy saying, well, I have a problem because sometimes pseudogenes are functional and there is indeed one on top of the fusion site. But then here it is, not problematic in equids. And oh, sorry, go ahead.
Is this specific telomere to telomere fusion? Is this of its kind? I know there's been other chromosomal fusions, but this specific one that they're purporting, is that the first documented type ever seen in nature?
I wouldn't imagine so, since it happened in the equids.
Right, but the one in the equids, I believe, and I don't have it with me, the paper, I believe it was a totally different chromosomal fusion than the one that's being purported here, right? This telomere to telomere fusion. You didn't really answer my question regarding telomeres anyways, how they're used to protect the DNA, and one of their main jobs is to prevent fusion. So why should we believe that they were involved in a fusion? But this is a hypothetical fusion too.
Yeah, sure.
We can see these chromosomal fusions happen in nature that I believe aren't the same as this reputed one. But why are we to believe, just like the out of Africa scenario, which I don't believe you answered as well, which kind of destroys human evolution, why are we to believe that actually occurred? Because it's all theoretical, hypothetical.
The human too? Well, here, I'll let you pick. Would you rather me answer out of Africa, which I thought I did, but maybe I didn't. I might not have, genuinely, I can't remember. Or would you rather continue with human chromosome 2? You picked the path.
Yeah, you did answer the out of Africa, but kind of like you accused Holden of answering your question, but then you said that, he didn't really answer it sufficiently. That's what I'm saying about the out of Africa, because there really is no feasible way for this 10,000 Homo sapiens to seize dominion over the entire world after a prolonged bottleneck of severe inbreeding, the accumulation of mutations. I mean, it's just not feasible. It's fairy tale. When it comes to the chromosomal 2 fusion, yeah, I just want you to answer the question. If telomeres, one of their jobs as being the end cap of chromosomes, is to prevent fusion, why are us to believe that somewhere down the line, millions of years ago, after the split between chimps and humans, this purported fusion actually occurred, and that it's unlike anything we've actually seen in nature regarding fusions? I mean,
okay, hold on. Just so we got to wrap up this point, standing for truth, just so we can kind of keep it going back and forth. Yeah, sure.
Standing, you want to finish that, or you want me to go ahead?
No. If you just want to, I guess, answer that question regarding the telomeres.
Yes. Yeah. So with telomeres, why are there mutations at all? I mean, our DNA, when it's actually replicating, there are checks and balances that are supposed to prevent mutations from happening that fail all the time. That is the nature of genetics. So yeah, telomeres are supposed to protect from that, but it obviously doesn't do it all the time. Now, as far as this not being the same kind of telomeric fusion, I'm not sure. I'm pretty sure it is when I kind of eyeballed the abstract, but I can't say for certain. Genetics is not my forefront. But I would like to talk about out of Africa, because I do know enough about genetics to say that we have a real-time example. I keep bringing up the cheetahs because I'm not understanding like why it's problematic for humans, but
I don't want to interrupt, Erica.
Hold on.
And I want to go back to the
one sec. Just to be sure.
Okay,
Hold on one sec. Standing for truth. Just to be sure that because I want to be sure that she's got plenty of time to respond because I think there were two questions.
Yeah. I'm just trying to answer.
Oh, right. You're right. You know what? I apologize. I did ask the out of Africa one again. So
yeah. I'm just trying to get them both in.
Chromosome 2.
Yeah. I'll quickly just rehash out of Africa, and then that's kind of why I was like, let's pick one, but we can try to juggle both. That's fine with me. With out of Africa, right? I mean, so I'm gonna really just like make my point as kind of concise as I can. Humans have a bottleneck. Cheetahs have a bottleneck. The cheetah bottleneck was much worse than the human one. And you don't have to be there to know that because all cheetahs are more closely related to one another than all humans are today. So know that they're less genetically diverse because of a bottleneck. Okay, great. Cheetahs did very well for themselves until humans started hunting them and destroying their habitat, which are the main reasons why there are less of them today than there used to be, not because of these new genetic mutations popping up. As far as I know, anyways, I'm not a cheetah geneticist, although that would be a cool job. With humans, it shouldn't be any more of a problem. I mean, essentially, cheetahs had a worse situation and did just fine until something completely unrelated hit their numbers hard. So with the humans, and also, mind you, the Toba extinction or the Toba eruption was indeed a volcanic eruption in nature. So while, yeah, I think that the estimates are around 10,000 individuals, that isn't certainly the case that there weren't other bands of humans out and about. Now, granted, it probably wouldn't change that number very much because, as you know, genetically, that number is genetically kind of constrained for a reason. But you're essentially saying it's impossible, at least this is what I'm gathering. You're essentially saying what my ears are picking up, that humans had a bad bottleneck, thus they shouldn't have been able to spread out and essentially diversify across the planet. Except cheetahs had a worse one and they diversified across Africa. So that's my answer to out of Africa. I don't see it as an issue. I don't think really anybody does. I've actually never heard that argument before. And I look at a lot of creationist arguments. Anyways, that's my answers. Those are my answers.
Awesome. Okay, if I could just say a few things. So the cheetahs, for example, are being looked at from conservationists today. Inbreeding is the issue. We know inbreeding exposes the genetic mistakes within the genome. And I always say regarding genetic entropy, inbreeding is like a sneak preview of where we are going genetically as a species. I mean, we accumulate 100 new mutations per person per generation, most of them being nearly neutral. What we now know about the function of the genome, that means we're degenerating faster than we ever thought. Now, this population bottleneck in the out of Africa scenario was conjured up by evolutionists once they realized that human diversity is very, very low, indicating that we must have come from a very small population. That small population, according to my belief, obviously is Adam and Eve. That makes sense. God created Adam and Eve. What do we see today? Low genetic diversity. Me and some man over in Asia, no more than 99 or no less than 99.9% similar. That makes sense. Evolutionists has always had to come up with a rescue device. Yeah, there must have been some kind of genetic bottleneck, 2,000 to 10,000 Homo sapiens, say 70,000 years ago. The thing is, this was a prolonged bottleneck involving severe genetic damage due to inbreeding. Because when you get small populations like that breeding together, not for one generation, not for 10 generations, but many generations, as the out of Africa scenario would suggest, that population would have been so genetically compromised that there's no feasible way that they could have seized dominion over the entire world. So I'll let you comment on that if you want. But the chromosome 2 fusion, I just want to mention with the chromosome 2 fusion, you were talking about the telomeres, and we should see remnant telomeres. But from my understanding, there's, for one, a struggle to find these. That area is very, very degenerate. Why aren't there any more sequences? I think it's not just the fact that the purported fusion site is actually a functional DNA element in a human gene. There's other discrepancies that go along with it. So not only that, not only the telomeres, but also the fact that remnant centromeres are also difficult to find. So it's not just the fact that a gene has been found and it spans the fusion site. It's a number of things. But like I said, it's still indirect evidence because this supposed chromosomal 2 fusion occurred in the human line, which means we could easily explain it based on either pre-flood or post-flood, especially because we believe in a population bottleneck anyways. It would have been passed on to everybody we see on the planet. So it's just not very good, convincing evidence anyways for ape to man evolution. I just think you're going to need something better. The pseudogenes you talk about, we know that they have very important functional roles in immune response. They're necessary to sustain healthy life processes. So go ahead.
Yeah, sure.
Actually, take as much time as you want, Eric. I talked a lot there.
Yeah. Well, I'll introduce something quite interesting in a second that you've heard before. But one, the reason we do find remnant telomeres, this is actually Tompkins's research here. So those are the remnant telomeres that you're looking for in that central part of the chromosome. With regard to, kind of pushing an extinction event, we know the Toba extinction event happened, I'm fairly certain, because there are ash beds. There are enormous ash beds. And that's how we know that it was a really bad extinction event, or really bad eruption, sorry. And really bad eruptions tend to not be super good for the things that are indeed around them. We know that from all the volcanic eruptions that we see today. That would be my sort of answers to that, but to kind of take a swerve, and feel free to answer those if you want. I mean, I think we're just chasing our tail with that. We're just going to disagree. But I'll ask you the same, you brought up my question to Kent, so I'll ask you kind of the same question. If we use genetics, right, to determine relatedness within the human population, why can't we do it between populations? Because I find that quite compelling. You don't find that as genetic evidence very compelling. I was mostly using it as a refutation, because creationists often say, oh, well, there's a chromosomal difference. Okay, well, it's a fusion. But the fact remains that that's not really the point. And it's also not just the fact that there's a fusion, but that the tops and bottoms of that chromosome are very, very, very similar to 12 and 13 in genus Pan. So where do you draw the line? I asked Kent. I didn't really get an answer from him. So where do you draw the line?
So where do we draw the line on common ancestry?
No, where do you draw the line between humans and chimps? Why is it okay to use me and my mother's genome to confer a common ancestry between the two of us, but not between me and a chimp?
Right. So if we're looking at, for one, we'd have to look at DNA differences. It also comes down to the fact that humans, okay, for all of recorded history, have produced humans. And we can use mitochondrial DNA, or we can use the Y chromosome DNA, and we can test whether or not, or we're related to our father. We can actually prove that the entire, all of humans, the entire human species are related. This is verified through independent corroborating evidence. Okay, but now you want to extrapolate that to pretty well suggest that humans and chimps are also related, even though there's so many discrepancies. Because I always say there's no point in arguing over evidence that's kind of agnostic to the debate. And what I mean by that is genetic similarities, whether it's nested hierarchies in DNA on a molecular level, mitochondrial DNA, for example, nuclear DNA, or nested hierarchies regarding anatomy, morphology, physiology. This can either be explained by common design or common ancestor. We need to look for evidence that can differentiate between the two. And I believe there's plenty of lines of evidence that can differentiate between the two. For example, the Y, just one sec,
yeah,
the Y chromosome. Okay, so this is going to be my follow-up question to what you said. Let's look at the Y chromosome, okay? Evolutionists were shocked. The Y chromosome is the most stable chromosome in the human genome because it doesn't exchange its genetic content with anything else. It doesn't experience recombination. Yes, gene conversion, of course, amongst itself, but this should be the most similar chromosome in the entire genome regarding apes and humans. Why is it less than 70% similar?
Am I good to go?
Yes, take your time.
Okay. So I feel like that's a little bit of as Kent would put it, like a hit and run, right? A slap and run, because that didn't really answer the question. I mean, you basically said humans produce humans, therefore it's reasonable that genomic comparison between me and my mom would be common ancestry. Okay, well, what if you had an individual, an orphan? You don't know where they came from. You didn't witness their birth, but they certainly have a similar genome with the mailman. You didn't see it. You don't know for a fact that that is indeed the father or the mother of this child, but their genome is very similar. So similar, in fact, that it mimics that of mother and offspring or father and offspring in other groups. So I think you would indeed point to that and say, okay, well, common ancestry. And that's what creationists do within their kind groups when they're formulating their kind groups. My argument with this isn't necessarily to say, whatever, pine trees and elephants are related, but to point out that there's no way of getting around lumping humans with the apes, because we use in a court of law genetics as a means of relatedness. I mean, you're basically saying we should draw an arbitrary line because we have never seen a human produce a non-human, which even if they did, that would violate the law of monophily. But yeah, because recorded history has been around for 10,000 years, less. And even then, it's barely been recorded. I wouldn't suspect no one under an evolutionary lens would suspect that you would. So I feel like that's somewhat of a non-answer. You showed the transitional designs earlier. Okay, well, where's the plane with wings that can't let it fly, or with half of an engine that performs a different function? I mean,
okay, here, let me respond to that real quick. I think you went.
Yeah, sorry, I did dodge around. around.
Yeah, no problem. So here's my answer. That's not quite as technical as what I said regarding genomics and genetic data that
Sure.
can differentiate between the two. For one, as I've stated, we would expect nested hierarchies, whether it's anatomical, morphological, physiological, or genetic related hierarchies. But regarding your question of where do we draw the line, why can't we conclude that apes and chimps are related, but we can conclude that me and my grandmother is related? Well, the thing is, we need independent corroborating evidence. Okay, so not something that also doesn't rely heavily on assumptions and inference. That's what I'm saying. There's an extrapolation fallacy there. So here's one example before you go. We have DNA testing, like you're talking about, that confirms, okay? There's no argument. Nobody argues, I hope not, that all humans are related, okay? Also mother, father, grandmother, we can see this based on maternity tests, paternity tests, but these various testimonies are completely distinct from DNA, okay? There's also corroborating, because we validated this test over and over and over again in humans. Like you've said, all of recorded history, humans have produced humans. But unfortunately for the evolutionists, okay, now you want to extrapolate that to mean humans and chimps are related. Well, we can't go ask the chimpanzee, we can't go ask animals from millions of years ago, or even animals from today, for their testimony regarding the DNA testing of them and their offspring like we do with humans. So there's just no way for us, Erica, to have independent corroborating evidence here regarding your question. But we do have independent corroborating evidence when it comes to all humans being related. You're committing an extrapolation fallacy.
Just to keep it short and pithy, standing for truth.
Yeah, 100% agree. We do know that all humans are related. Why do we know that? Because our genetics are so similar. So, why do we know that humans and Neanderthals are related? Well, because their genetics are so similar. You can take that back down the line, but creationists can't come up with anything empirical to draw the line. You say, well, we don't see it. We can't ask a chimpanzee. Okay, well, we can't see the inside, or rather how a black hole functions in real time, but we can make accurate predictions about how light's going to react around it because of the data that we do have. So there is no reason why you can't extrapolate it backwards, any more than there isn't a reason why 23andMe can take your DNA and take your DNA and extrapolate backwards and say, guess what? You're 63% Norse. Well, why couldn't they? I mean, you're essentially kind of saying that this is impossible because no one was there. It's an appeal to observational science, which I'm not a very big fan of. And then you say, where's the corroborating evidence? Well, it's all the other stuff I showed. It's the fact that humans are morphologically nearly identical in so many ways to all of the other apes. It's the fact that we have this smooth gradient, and creationists can't come up with a meaningful way, at least in my opinion, to say that we can have this accelerated decay that completely throws 4.8 billion years out the window. It's the archaeology, the fact that no one can explain why there's so many dang tools all across the surface of Africa. All of that points in one direction, and it isn't to 6,000 years. So it's kind of like parsimony, right? What's the most parsimonious explanation? Because I'm not going to sit here and tell you that we know for sure exactly how things went, because we don't. And I don't think we ever will. I would love that. That would be awesome.
Okay, can I respond to a few things that you said?
Yeah,
Okay.
sorry, I'll wax poetic. I thought I'm guilty of the same thing.
No, I think we might be both guilty regarding that. So I'm not saying that it's only an extrapolation fallacy that we can look at similarities in our genetics. Like I said earlier, every single human being on this planet is 99.9% similar, which says we have low genetic diversity, indicating we came from a small population. Okay, this is a good thing for us. Now, you want to extrapolate that to mean we also have similarity with chimpanzees, for example, and then we also have similarities with monkeys, we have similarities with dogs, whales, fish, all the way down the line to a bacteria, the nested hierarchy of life. I'm saying we too predict nested hierarchies. Therefore, it's difficult to draw that line since we both predict the exact same thing. We need something that's going to differentiate between the two lines of evidence that both models can explain. That's why I pointed to something, because you talk about similarities. The Y chromosome, for example, and this time hopefully you can answer it. But the thing is, the low level of recombination and sequence diversity on the Y chromosome that I'm talking about should make the Y chromosome the most similar between humans and chimps. But the problem is that the human and chimp Y chromosomes are actually incredibly dissimilar when they should be the most stable, because they are immune for the most part to recombination. So how do you explain the fact that the Y chromosome is less than 70% similar between chimps and humans?
Well, first of all, I would, as I've continued to kind of begrudgingly admit throughout the course of this conversation, that genetics really isn't kind of my field. I can talk to you a lot about, other stuff, but genetics isn't it. So I'm not kind of adept enough to really answer your question in a way that I feel that you would find sufficient. I don't know. I would ask you out of curiosity, if by chance that 70% number comes from Tompkins, considering Tompkins.
Nope. I've had good question. I have the paper where it came from.
Do you know who the author is?
Source data, because they were shocked by it. But from my understanding, talking to scientists, right, I've debated Dr. Stefan Frello, for example, their explanation would be gene conversion, because it can exchange genetic material within itself, right? It's like recombinations, like shuffling a deck of cards, but the Y chromosome doesn't have a counterpart to do that too. Therefore, they should be the most stable. It's the best chromosome to look at. My question would be to the evolutionists like Dr. Stefan Frello or whoever, Herman Mays, that wants to look to that as a rescue device, what testable prediction can you make and bring forth regarding change on gene conversion in the Y chromosome? Because and it's okay that you don't have the answer to it, but that would be a differentiating line of evidence that can tell us, are chimps and humans actually related? There's no way they can be, based on the dissimilarity of the Y chromosome. Less than 70%. Evolutionists were shocked, Erica. Shocked.
But here's the problem with that. That's kind of essentially hinging it all on the fact that I don't have an answer for the Y chromosome. Now, what I do know about genetics would be, even if the Y chromosome were 70% dissimilar, well, there are some proteins between humans and chimpanzees that are like 50% similar. And the reason that they're 50% similar is, as we know the mechanisms of genetics can kind of swap things around. But the fact remains that we are still the closest related to chimps with regard to that single protein, even if you're just comparing that single protein across, the animal kingdom where that protein has been kind of examined, would still be the closest to the chimpanzee. It might be only 50%, but you're not going to get any closer. You're not going to find another animal. If you could find a rabbit with a greater similarity, well, then you might have something to kind of go on, unless it was, say, like a remnant that had been turned. If you'd been able to kind of show that it was a de novo type situation, but the fact would remain, I bet. And I don't know this, but I would put a small amount of money on it, because I'm not very wealthy, that the Y chromosome, even though it's 70% similar only, that's still the closest member of the animal kingdom to humans. And it may simply be, as you know, there are areas on the genome that are kind of hotspots for mutation.
Mutational hotspots, yeah.
Yeah, sure, yeah. And they just kind of undergo it quicker for whatever reason. I'm not a geneticist. I wish I could tell you. I wish I knew the answer. But my answer would be, how do we know that something similar is not going on the Y chromosome? Can you show me an animal that's closer than that would kind of violate it? Because as far as what I know about all of this stuff, that's still not enough to say humans aren't apes, aren't a member of the ape kind. Would you be the type of creationist like that would say, no, humans aren't primates? Because I know Evolution News admits humans are primates, and I know creation.com admits humans are primates. Even if they don't like common ancestry, they admit that morphologically and genetically, we should be classified as primates. AIG, they don't like it. But where do you stand on that? Where do you stand on that? Do you think humans are primates? And, if not, why not?
Okay, so first of all, with the proteins and Y chromosome comparisons, before I answer the question, just to address
Sure.
things.
I went on for a while.
No, and that's okay. The whole point of looking at the Y chromosome, say, versus the proteins anyways, is because the Y chromosome is known scientifically to be the most stable of chromosomes. So that would make sense to look at that to see, how close the similarities really are between humans and chimps. But I don't want to beat a dead horse regarding your question regarding ancestry anyways to begin with.
And then forgive me, sorry to interrupt. Not you saying for you didn't do anything wrong. I just forgot to mention
for once
we will go to Q&A pretty quick. So if you're both able,
don't we have a quick closing just to wrap things up?
Forgive me if I forgot that from the email. Was that in the email?
I'm okay without a closing.
Oh, deal.
Even just a few minute closing just to wrap things up.
Sure, you betcha.
I guess to answer your question, so are we just going to kind of wrap this part up here and then jump into closing and then Q&A you were saying, Jay?
Well, I suppose what we could do is, if it's something you can fit into your closing, we go into closings. But if it's something that you're like, oh, this is just kind of really relevant to this point right now, like, we can do it.
Okay.
Just short.
Actually, that's good. Yeah, I can
50.
wrap it up in 30 seconds, and then if she wants to have the last word, then we can jump into the closing. So I think Erica, it all goes back to the question anyways, as to how we identify common ancestry. Okay, so if we both predict nested hierarchies, then we need to look at something that can differentiate between the two models. Now, we explain anyways the majority of DNA differences based on our model, which does lead to testable predictions that are future and novel as pre-existing functional DNA differences. Now, we only know very little of the DNA language. We speak less than 1% of the DNA language as far as I'm concerned. And all you got to do, Erica, is look at the history of genetics. I mean, in the 40s, there was one gene, one protein, one function. Science changes nearly every single day. I mean, we see massive amounts of literature giving us unexpected functions of RNA. And we've only functionally tested less than 1% of the genome because the gold standard of genome testing is gene knockout test anyway. So my technical answer, and to end it quick, I know we're going into concluding statements here, is genome function, because evolution would say the majority of DNA differences, if not all of them, are the result of mutation. Therefore, we're looking at a lot of neutrality. We're looking at a lot of genomic fossils, right? Pseudogenes, for example, endogenous retroviruses, ALUs. Us, on the other hand, our model's based on pre-existing functional DNA differences. Therefore, we make a very specific prediction that the vast majority of DNA elements, DNA sequences, DNA differences are functional. This is a head-to-head prediction that we can test in the lab and see what is true, common ancestry or common design. That's my answer. Go ahead. You can have the last word, Erica.
Yeah, sure. I'm going to make my last word my closing. It's not so much does genome equate to function, it's genome does equate to relatedness, and there's no reason why that line can or should, rather, without empirical evidence, be drawn. I mean, essentially my whole point of this was that you have several lines of evidence that in and of themselves are convincing, but they stand alone. It could all be a coincidence, but together is when you reach a parsimonious conclusion. It's the combination of the fact that we can't accelerate decay. It's the combination, with in turn with the decay thing, in that we have this beautiful gradient of skulls that appear based off of the previous premise to have existed at different times. It's the morphology, it's the genetics, and it's to be kind of sassy, the fact that no one can answer that question for me. No creationist seems to be able to answer the question without kind of reverting to, I know you like this word, rescue devices. So that's kind of all I got to say. I mean, I'd love to have another conversation with regard to whatever genetic entropy or the age of the Earth,
Yeah,
because
of course.
as I said to Kent, a lot of it hinges on the fact that I believe the Earth is very old and you believe the Earth is very young. Because obviously, if it's old, the skulls make sense, and if it's young, then it makes sense for your worldview. But it makes sense based on what we kind of think. So I wasn't convinced, Standing. You didn't convince me, unfortunately, and I'm sure I didn't convince you either. So, but that's okay. I still had fun.
Having fun is the most important part. You're right. You didn't convince me, but you're right. It was a good back and forth. We could probably do this all day. I appreciate your responses. I appreciate your arguments and objections to my position. I guess going into, so if that was your conclusion, James, I just want to set my timer here. How long do I have? Just a few minutes, or I don't want to go over?
A few minutes. I'd say roughly the same as what Erica did. So I think it's
okay.
like, what, 2-3 minutes?
I'll be really quick because I just wrote. So in my opening, I tried to address nearly everything she talked about in her opening. I just got a few things hanging that I didn't get to address. I'm definitely a stickler for that. So I'm going to address the couple things here. So DNA analyses anyways confirm that the supposed Homo species now all coexisted, intermingled, and interbred like we were discussing earlier. This is confirmation that they are all fully human. A few other things here that she discussed. Let me see here. Even at habilis, sediba, there's so much evidence now. Even some paleo experts are agreeing that these are classic examples of what happens when you piece together a so-called species based on a jumble of mixed bones. So what some evolutionists like Erica here are saying are your perfect transitional fossil from ape to man, it's actually a mixture of human and non-human bones. And they're simply an artificial species, a ghost taxa. That's why sediba, for example, Australopithecus sediba, is described as anatomical, with anatomical contradictions. For example, upper limb and shoulder anatomy, just like arboreal dwelling orangutans. And then you've got hands indistinguishable from modern humans. And this isn't the first time this has happened. This has all happened before. For example, one that comes to mind regarding the mixing of human and ape bones has occurred in Piltdown Man. So, which was just what they did. It was an ape jaw that was force fitted to a human skull. But unlike habilis and sediba, of course, I'm not saying habilis and sediba are a conspiracy by any means, but this was done intentionally, while habilis and sediba, not so much. For example, the evidence she brought in genetics, the similarity, I touched that. It's only 88%. Similar 400 million DNA differences exist between the two species. Pseudogenes have been overturned. Hierarchies, like we discussed, relative hierarchies, as I explained in the beginning, is just characteristics of designs. And then the Australopithecines, my last point. And then I think I covered everything. They share most of their features with living apes today. They're around 3 or 4 feet tall with long arms and short legs, ape hands and feet with long curved fingers and toes, opposable thumb-like toes, ape size and ape-shaped skulls, funnel-shaped rib cages with high-placed shoulders for suspensory behavior. And yes, they do have some uniqueness. I'll give Erica that in, say, morphology and anatomy, which is why the best conclusion is that these were apes and nothing more than just an extinct ape genus. And Erica probably knows the fact that a baboon bone was incorrectly assigned to Lucy for over 40 years. That doesn't really give me much confidence regarding the evolutionists and their many other conclusions on human origins. And I explained all the different species, Naledi, Neanderthal, Erectus, the hobbits, for example. These are all inbred subpopulations, explains all the degenerate features. Homo naledi, for example, explains the curved fingers. This is all expected after Babel, post-Babel, post-flood, isolation and inbreeding. Everybody disperses. A few unfortunate subpopulations migrate, remain isolated. We see this clearly with the hobbits.
You got 5 seconds.
Dwarfism, for example. So I believe I've made a strong case that human evolution is impossible and fits perfectly within a biblical model. Thanks so much, James.
Thanks
you.
So much, Erica. Thank you. Time. So very excited, folks. We will go into the Q&A. So thanks so much for all of your questions. It's been a wild one. Really enjoyable. I really like having both of our guests on. And with that, thanks so much for your patience, folks. I know you're eager. So I am as well. First up, Brian Stevens. Thanks so much for your Patreon question. They said, does Standing for Truth think that Kent Hovind actually has 3 PhDs? Also, where is his Kent Hovind's CV, or basically, for those of you new to a CV, it's like a academic resume.
I'm more concerned with the arguments one has. Actually, Tija made that point once, and I respected it. We're more interested in the arguments than, for one, ad hominems, and looking at what people's so-called education may be, because some people with a lot of education may not have the best arguments, especially if they have nothing more than textbook answers. So I'm not really interested in responding directly to that. I'm just interested in the arguments that my opponent would have.
Gotcha. Thanks so much. Next up, we're going to try to speed through these folks. So if I'm going fast, forgive me. It's just because we want to squeeze as many in. Steven Steen, thanks for your super chat. He said, good to see Alpha Daddy, a.k.a. James, tonight. Gosh, you're sick. Nasty guy. You got to look out for him. Just, Next up, Michael Dresden, thanks for your super chat. He said, evolution is a myth, a fairy tale for grown-ups. A little trollish. Erica, if you want to respond, you can. You don't have to. It's up to you.
I won't give it the dignity.
Gotcha.
Okay.
Next up, Steven.
Good answer.
Michael Dresden. Oh, we got that one. Terry James, thanks for your super chat. They said, does different design mean different creator?
Does different design mean different creator? No, I mean, Honda, Volkswagen, for example, Chrysler, I mean, they have many different designs. You can look at the Volkswagen Jetta, which is a sedan. You can look at the Volkswagen Tiguan, or you can look at, for example, if you want to look at Chrysler, you can look at the Chrysler 300, the Chrysler minivan. I mean, there's different designs for the same creator. And of course, if God wanted to, for example, DNA, deoxyribonucleic acid is the universal code for all of life. And evolutionists say, this is proof that we're all related: pine trees, whales, banana plants, and apes, apparently. But of course, God is going to use a common code for his common design. If he used different codes, that would suggest a possible form of polytheism. Maybe there is multiple gods, like the Greeks or something. But one common genetic code makes the most sense given a biblical based God. So that's my answer.
Gotcha. Thanks so much. Jay Shy, thanks for your super chat. They said, standing for truth, genetic entropy is a lie by John Sanford. He misquoted Moto Kimura's their study where Kimura left out beneficial mutations on purpose to focus on neutral mutations by genetic drift, not selective mutations.
I feel like I've had this debate so many times. That argument is a rabbit trail. There's never been any rescue device or argument that has debunked genomic degeneration. All serious population geneticists admit and agree that man is presently degenerating. That's why they come up with rescue mechanisms, synergistic epistasis, mutation count mechanism. When I debate these evolutionists, they use the most weak standard blog related arguments. I mean, at least bring forth things like synergistic epistasis and these mechanisms that these population geneticists are invoking. Let's discuss the data. No more of these ad hominems. John Sanford shows a larger zone of no selection than Kimura because Kimura's analysis of the problem was oversimplified. I debated someone a few days ago who's very familiar and very exceptional in genetics, and we discussed this very issue for an hour and a half. So no, these new near neutral, low impact deleterious mutations, they are accumulating. But natural selection can only amplify the best beneficial mutations. It can only get rid of the worst detrimental mutations. Can't do anything against the near neutral mutations. They're accumulating in our genome, and beneficial mutations are no help. They are no help, and the vast majority of them are unselectable as well. So there's my answer.
You got it. Thank you very much. And thanks so much for your super chat, Terry James.
Thank you.
They said, if DNA similarity can be explained away by similar appearance, then why is the, correct me if I get this wrong, thylacine more genetically similar to the numbat than the wolf?
Is that question for me?
I feel like it is.
I think so.
It has to do with genetics and morphology. I thought it was for him. Is it for him or is it for me?
I thought it started off for you. So now, if you can ask it again, I'll answer it.
I think it's for standing for truth. I'll read it.
Ask it again.
Yes.
If DNA similarity can be explained away by similar appearance, then why is the thylacine more genetically similar to the numbat than the wolf?
I think, as I explained earlier, we're going to have to, if you're looking at just mere similarity and anatomy, morphology, for example, we need to look on a DNA level. And we speak so little of the DNA language. I am going to look to, like I explained to Erica, DNA function. And this has been proven true over and over again. Endogenous retroviruses, ALUs, pseudogenes, they're all very important in our genome. I mean, they're important to sustain healthy life processes in the cell. And I can go on and on about the numerous functions that have been discovered based on our hypothesis. But that example, I would, if it's that similar genetically speaking, I would look to some form of function. I don't know if there's an answer yet to it, or if it's something that we need to discover in the future based on more genomic analyses and more genomic testing.
Gotcha. Thanks so much. Shannon Q says, Team Erica, in all caps. You've got a fan out there, Erica.
Shannon, I love ya.
Brian Stevens, thanks for your super chat. He said, Standing for Truth's sources for footprints is, quote unquote, the conversation.
No, I've got plenty of sources. Actually, too many sources on that one. Like I said, I looked heavily into that footprint. I'm looking forward to the source that Erica explained and is going to provide to me, because what I found in the source data in the primary literature, they all agree that these footprints are modern, anatomically modern looking human footprints, and they're trying to explain it away with some form of possible extinct gorilla, or I mean, there's a lot of, I guess, data out there. So like I said, I'm looking forward to Erica's sources, but I've got a ton of sources. I can certainly provide them to anybody who is interested.
Gotcha. Thanks so much. Next up, Stephen Steen, thanks for your super chat. He said, my wisdom teeth fit in my jaw. Am I the missing link?
Hey, I had all four of my wisdom teeth too. Wisdom teeth are an interesting little facet because they're kind of on their way out, but not quite. Some people have no problem with them at all. I had problems with mine, and that was a wild after surgery experience. So I'll put it this way. You are the missing link. There's no other explanation.
Gotcha. Thanks so much. Next up, appreciate your question. Brian Stevens says, why do you ask Erica to use scientific... So this is for Standing for Truth. Why do you ask Erica to use scientific sources to disprove your blog from, quote-unquote, the conversation by a, quote-unquote, political analyst?
There's plenty of sources. I actually have innumerable quotes from all types of paleoanthropologists that agree with what I've been saying. I provided a paper in my opening regarding my hypothesis that these so-called human ancestors are nothing more than inbred subpopulations that experience rapid genetic entropy due to the accumulation of mutations. And we've got an evolutionist here who's written a paper recently pretty well confirming the exact same thing. Of course, he still holds to evolution, and he admits that there's something odd with the data, but I've got a ton of things that support me, quotes, sources. So if Brian Stevens is serious about it, I'll provide those to him after the debate.
Gotcha. Thanks so much. Next up, Terry James, thanks for your super chat. They said, Standing for Truth complains that Aaron interrupts, but it's okay for him to interrupt. How do you like them apples?
You know what? I think this was a good debate because Erica and I both, I think, like to talk a lot and talk about a lot of different subjects. But anytime there is interruption going on, James, being the best moderator on YouTube, stopped it right away. And thanks for that, James. So if Aaron, Ra, and I get in on this, hopefully we're not just talking over each other the whole time, because James is going to make sure that doesn't happen. So
that's nice.
Is that a planned debate? I'm interested.
Yes, it is. In fact, this is an excuse for me to show the thumbnail again, because I'm excited. This is going to be an epic one. So basically, Aaron Ra and Dr. Mick Leroy, I mispronounced it earlier, sorry about that. Dr. Mick Leroy and Aaron Ra will be debating on creation versus evolution, which best explains the evidence. And that's coming up in Dallas. It'll be in person. So we've actually... Team Skeptic.
That is so exciting.
It is. Team Skeptic, I have to give a big thanks. So if anybody out there, if you know Team Skeptic, give him a big thanks because he was so kind. He's got a channel called Team Skeptic Debunks, or I should say, to be neutral. Well, I mean, you can say debunks arguments without necessarily meaning that a view is true. He challenges the flat Earth position, and he's a very good debater. And he's also very kind because he helped us get the venue for this debate with Aaron Ra and Dr. Mick Leroy. So that's honestly going to be a blast. I'm pumped for it. But yes. Erica, do you live in Texas? You have to go.
I don't. I know. I think being in the UK for most of the year means I'm a little bit out of that range. But I would love to come. Hey James, come to the UK. Let's do a debate there.
Let's do a debate tour in the UK.
I'm actually, no joke. There's I was thinking about it earlier today of whether or not they could actually happen. And it's not.
Oh, that would be so cool.
It's not impossible. So it's definitely a possibility.
Hey, if you do that, I'll take you out and get you a drink at one of my favorite pubs.
That's nice of you. I appreciate that. And someone just asked in the audience, are there tickets? We don't have tickets. It's going to be a free first come first serve. It's actually going to be in a tattoo parlor. So we're kind of doing almost like the Bible and Beer Consortium. They go to pubs. We will do it in this tattoo parlor, and it's going to be a lot of fun. So I'll let you know the exact address as we get closer. And but yeah, so hopefully we can fit everybody in there because I think there's going to be a lot of people. So it'll be a lot of fun. And next up, thanks for your super chat, Athena, goddess of wisdom and warfare. They said, standing for truth is an all right guy. He's just wrong. What do you think of that, standing for truth? You like
Listen,
that?
There were some really, really good play on words regarding SFT. So, whoever can give the best play on words for SFT, I think what was one of them? Standing for lies is a good one, but it's $25. No, I'm just kidding. But yeah, Athena, good guy. I've done a lot of discussions on his channel. I got nothing bad to say about him. I would say he's a nice guy and he's wrong as well.
Gotcha, thanks for that. I'm so sorry about the sound. I played the boom button because when I read that super chat, I was like, oh, good jab. And I played the boom button and it was the most frightening, terrifying scream ever. And everybody's like, dear gosh, what was that? So thanks for your patience, guys. All right, stupid whore energy, as she likes to be called. Thanks for your super chat. She says, standing for truth, how do you explain the small population of Sumatran orangutans exhibiting high genetic diversity but thriving?
To be honest with you, I'd have to see the source and the paper on that one, but I'd bet some money that there's a pretty decent explanation for it because it sounds like he's probably grasping at straws. But yeah, if he wants to send that, I'll give an answer afterwards. Never heard of it.
Gotcha. Appreciate that. And thanks so much for your super chat, Translator Carmium. Sorry, that's embarrassing. Okay, they say, standing for truth, how can you complain about a bottleneck of a few thousand if you believe in the post-flood Noatian bottleneck, which was much smaller still?
Good question. Good question. That's usually the question I get after I bring up the fact that their so-called population bottleneck is not even remotely feasible. But ours is very easy to explain. I mean, based on our model, okay, I'll take it slow for them, use really small words. We start with just two people, okay, constituting a very extreme yet benign population bottleneck, okay? Then, and you can just read this in the Bible, 10 generations later, a second single generation bottleneck of just what? Whoever knows their Bible, just 8 people occurred at the time of Noah. Both bottlenecks were very brief, just one generation, and then followed by explosive growth. These cases, there would be almost no previously accumulated mutations, especially if we explain the vast majority of DNA differences as functional created DNA differences, therefore no inbreeding effects. That's why the limited human genetic diversity we see is good for us, but a huge problem for evolutionary theory. And as you can see from the evolutionist explanations, it leads to unrestrained storytelling. So that's my answer.
Gotcha. Thank you very much. Next up, trying to move through fast, Stupid Whore Energy, thanks for your super chat. She says, if mutations are degradative, why do viruses often evolve complex structures like HIV has evolved complex gated ion channels?
So he is he talking about virus? So the HIV one, is he also referring to like endogenous retroviruses, like viruses in general?
I'm not sure if she only mentioned HIV.
You know what? I'd have to see, because I know the explanation for the function found in endogenous retroviruses is that these functions are co-opted, just like pseudogenes, for example, they're co-opted. But the thing is, that's just theoretical, right? We didn't actually observe these functions being co-opted, so I'd have to see if that's the same thing going on with the what's going on with the HIV as well.
Gotcha. Thank you very much. We appreciate that. And next up, Stupid or Energy again, coming at you. She says it's been
He's busy.
That's right. She says it's been confirmed that that telomeres in nearby DNA undergo lots of mutations. So of course you'd expect this kind of DNA to be divergent and degenerate.
So she's talking about the telomeres. I guess she's admitting that the sequences that we should be seeing, if there was a chromosomal 2 fusion, right, we should see these remnant telomeres, and there's a struggle to find these because they're degenerate. So I guess she's admitting that they're degenerate, at least, which is kind of helps my case. But I would just ask, why were the telomeres even involved in the fusion to begin with? Their job is to prevent the fusion. So as far as I know, the telomeres don't occur in the middle of genes. Genes are not around telomeres. So I mean, there's so many discrepancies to the argument, to the story of the chromosomal 2 fusion. So
Gotcha. Thank you very much. And then Erica, if you'd like to respond, I know Standing for Truth gets a lot of these, so if you want to like add something on some of these, like feel free.
I mean, I would just say on that we do have the remnants, and they're in Tompkins' own paper. So that's why I kind of like sassy pointed up at this. I was like, hey, there they are right there. That's all I have to say.
Gotcha. And we do have a question.
Hold on. If you have a question for Erica, perfect, because I got to run upstairs real quick.
We do have one.
Taking a 1 minute break.
Gotcha. Thank you very much. And so, Mitchell, thanks for your super chat. They said, question for Erica, if creation and evolution both include nested hierarchies, what mechanism naturally created your quote-unquote magic cell via abiogenesis?
Well, I think that's really a great question. I mean, basically the field of abiogenesis is booming. I think it's kind of interesting that they asked that in a human evolution kind of chat, given that abiogenesis is entirely unique. But it all starts with chemicals, right? I mean, chemical reactions, they appear to have no real rhyme or reason to them. But as far as I know, it was amino acids that kind of began to clump together and sort of form these proto strands of like RNA at some point, if you subscribe to the RNA world. That's on my field. I wish I could give you a better answer. Ask Jackson Wheat. He knows his stuff.
You got it. Thank you very much. And I assume that Standing for Truth is still occupied, so I'm going to just quick mention a couple of things. First, stoked to have you here, folks. We rarely talk about the philosophy of the channel, but I think it's worth mentioning that we are basically trying to provide a nonpartisan platform, so we don't take any stances on the issues. We don't have after shows where we say who won or lost or anything like that. We are trying to be fully neutral, and despite being imperfect, that's our goal, and we want you to feel welcome, whether you be Christian, atheist, Muslim, one of the many strange creatures in between all these different worldviews. We're glad you're here, and it sounds like, Standing, are you back?
I am back, my friend.
He's
all
back.
That tea and water will get to you after a couple hours.
Nasty. Thank you. So, very good. I appreciate that, and we do have a question.
No problem.
Don't worry, Stupid Whore Energy, nasty. So
she's putting your kids through college there, James, with all those super chats.
She does do a lot, and she says, how much for James's snot-filled rag I will pay. Nasty woman, very just disgraceful.
A lot of nastiness going on.
You've got some good questions.
Unfortunately, Steven Steen already offered $20. That's hard to beat. I mean, he's a nasty guy.
You're missing the big money here, my dude. You got to start capitalizing on these asks.
The snot rag. That's funny. Oh boy. Subtracted. Thanks for your super chat. They said, hey, Standing for Truth, why is the FOXP2 gene expressed in the chimpanzee genome as a mutation?
What I know about the P2 gene it's the gene associated with language, but it does far more things than just that. So the fact that it's broken doesn't, give evidence that if it worked, they would. I'm not sure if I'm answering the question properly. Can you?
Yes, let me pull it up 1 second. And I've got to undo this. Hey, Standing for Truth, why is the FOXP2 gene expressed in the chimpanzee genome as a mutation?
Okay, so it as a mutation. So if it was originally functional, like I said, it's associated with language, and if it does far more things than that, and now it's expressed as a mutation, I mean, that would just be evidence of genetic entropy after the fall. I mean, some functional genes can be the result of mutation if that occurs.
Gotcha.
Okay, if I jump in real fast on that one, James, just
You
like
bet.
a little quick anecdote. Since Stan is getting all the questions, why is no one asking me any questions? I'm bitter about it. But yeah, I think that's an interesting question. I'm not positive that the FOXP2 gene is language because I don't really know that gene particularly well. But if it is, the interesting thing is that chimpanzees have some like 86 or so unique gestures that they can combine to get across messages, and human infants display 46 of those between the ages of 1 and 2. So they do indeed have a sort of proto-language, and that can be extended to geladas, whose chittering follows Menzerath's law, or vervet monkeys, who have their own vocabulary for predators. So it is very interesting that we actually see a gradient of language, very proto-language, in living primates.
Gotcha.
Yeah, I think because just real quick, super quick. I promise.
Okay.
Just like I said at the beginning, I just wanted to make sure I was answering it right.
Go on.
It can be associated with more things, more functions. For example, and I'll compare that to protein moonlighting, which back in the 40s, one gene, one protein, one function was the thinking. Now we know of protein moonlighting. These proteins are doing unimaginable things. It's like a multifunctional tool. So some of these genes have more than just one function. So it being a broken gene or a mutation is not, I don't think is going to convince me of ape human evolution.
Gotcha. Thank you very much. Next up, got one from Subtracted. Thanks for your super chat. He said, hey, Standing. Oh, we got that one. That's embarrassing. Okay. Stupid Horror Energy. Thanks for your super chat. She says, are you aware that two proteins don't need to have the same amino acid sequence to perform the same function?
Is she referring to third position redundancy?
Let's see here. I'm not exactly sure.
Say it again.
Yeah, and you know what? A lot of those degenerate codons, for example, are also now, there's massive literature suggesting function. Because you can look to somebody like Dr. Herman Mays, who also looks at DNA level hierarchies, and he'll look at neutral variation, third position, degenerate codons. But now, even those are proving to be functional. They work to slow and speed processes in the cell. So it all falls in line with pre-existing heterozygosity. So yes, I am aware of that.
She followed that up with a quick one where she said, gene duplication is a very old concept. And she also said, I love Nickelback. I don't know why I made that last part up.
I mean, the evolutionists will often look to gene duplication as a way to add novel information to the genome. But I mean, if I give you a copy of a book that you already own, and then I start introducing typographical errors into the second copy of the book you already own, now you just have a more messed up copy of the original book. So it's just more evidence for genetic degeneration. It comes down to net gain versus net loss. So that ain't going to help.
Gotcha.
Quick add on that, though. What about natural selection? Ooh. That's
right. Natural selection, though, the problem is it can't act upon those near neutral mutations that are unselectable. Those are the ones that build up. Sure, it's going to amplify the best beneficials and get rid of the worst detrimentals. It's the near neutral mutations that accumulate and degenerate our information system. So that'll have to be the problem you'll have to address, Erica.
We should have a conversation about genetic entropy. I've heard you speak to like CRISPR and stuff like that before, and I would be very interested to have that chat. I'm not very well versed, as I've said for like the 20th time. I'm not very well versed in genetics, but still, it would be an interesting chat.
Yeah, I think that'd be a blast. You've been fun to talk to. We can definitely set that up.
Sure. Sorry, James. We started talking again.
Oh, James, you still there?
No problemo. So I appreciate that. And I think that's a great idea. You guys ought to. And the next one comes from Stupid Horror Energy again. She's persistent. She says, how do you explain the fact that ERVs, or dead viruses, are in the same exact places in humans and chimps, but not other species?
So good question. Regarding ERVs, it comes down to the fact that are they really the result of ancient viruses? Because now we know that the evidence suggests that these endogenous retroviruses and these retrotransposons, for example, they're indeed functional, and not just functional, not just low levels of function, but these endogenous retroviruses, they have crucial functions. They help regulate genes and even determine cell types. So like I said earlier, the evolutionist now has to claim that they were co-opted, but that is just more fancy storytelling. So these are important DNA elements, just as we'd predict based on created genetic diversity.
Gotcha. Thanks so much. Next up, got one from Cy Gart. Thanks, Dr. Gart, for your question and super chat. He says, inbreeding requires a much smaller population than 2,000. Chromosomes are different between species because most of the genes on Y are not essential.
Yeah, I don't really think that matters because if they're different or not, I mean, the fact is, if we're talking about human evolution, chimps and humans do have a Y chromosome that's very, very dissimilar. And if you want to look at the Y chromosome, well, they can be traced back, proving one paternal line. And some of these degenerate chromosomes regarding the Y chromosome is just more proof of genetic entropy, the crumbling genome. That includes the Y chromosome as well.
Gotcha. Let's see.
Hey, I'm very flattered that Cy watched this conversation, though. Cy, you're awesome. Love your stuff.
I like Cy. I hope you enjoyed it, Cy.
Yeah.
Gotcha. Thanks so much. And by the way, so we are trying to, I'll mention that 99% of you all here are honestly so terrific, friendly, and you like to debate, but you're not like, like being like abusive, which is great. You're just superb.
Terrific.
And there's maybe like 1% that sometimes is a little bit like more fighty and a little bit more aggressive. And so in that case, just want to ask if you would be so kind. We're trying to like change the ever-changing culture, trying to mold it into like, yeah, we're going to try to only ban hate speech. But we do want to have the mods hopefully just say like, hey, like if somebody's being abusive, like, hey, can you do us a favor and not call somebody an idiot, something like that. So we're still going to try to like not regulate people. We don't want to like control people, but at the same time, we want to like kind of naturally, organically, like through your own free will, foster that kind of spirit of like kind of like warmth or friendliness. You know what I mean? Does that make sense? So
James, that's so diplomatic. That was such a diplomatic way of saying, cut that out now.
That's funny. My hope is that hopefully it'll just be, and like I said, 99% of the people, very kind, like it never are abusive. Once in a while, though, it's kind of like, kind of. But
yeah.
So with that, next up, we're going to try to fly through as many. We just got through the super chats. So thanks so much for those, folks. And we are going to jump into the other questions. I will try to do this as fast as possible. We're not going to get through all of them. I'm really sorry about that, everybody. There's a lot. And I want to respect the debaters' time. We've already...
I just have to jump in, James. To be honest with you, I've only got about 2 more minutes. So if I'm guessing most of the questions are for me, so you can go through him as much as possible. But
yeah, I know what you mean. I know what you mean. We've gone over your time, and I'm sorry about that, you guys.
I'm sorry.
No, it's been a blast.
Don't worry about it.
And
all
so,
good.
Love your channel, James. You put on the best debates.
We usually try to do like an hour and a half, 2 hours tonight, but didn't quite do that tonight.
I lied.
So
hopefully it was one to remember.
Yeah, absolutely.
Honestly, it really was. People, honestly, there's just a lot of positive feedback. People have really been enjoying this and engaged, and so I've definitely enjoyed it. And we'll try to fly through just maybe 1 or 2 of these. Actually, what we'll do is maybe like 1 or 2 for standing, and then we'll do 1 or 2 for Erica, because that way standing you can go. And so 1 for standing, we will do this one from Rayward. This came in early. They said, I already know standing for truth will evade. Can you describe exactly what a transitional form between apes and humans would look like if you were to be convinced evolution was true?
Yeah, no, I'm not the one. If you'll actually hear me rarely even bring up transitional forms, because when it comes to transitional forms, I'm not difficult with it. I think a transitional form would be the blending of two separate creatures. I mean, if you look at something like maybe Australopithecus sediba or habilis, or even the Piltdown man back in the day, you know, these so-called human ape ancestors that are clear evidence of the mixing of Homo and ape bones. I mean, those would be the probably close to the perfect transition. But as I've explained many times, when it comes to transitional forms, our model too predicts the mosaic, the transitional form. For example, I point to products of human design that seem to span two categories, just like you can find certain animals. Remember, the majority proves the rule. They can point to some, say, reptile mammal transitions, or they can point to tiktaalik, for example. It's going to need to be the rule, these so-called mosaics. But an amphibious assault vehicle, to the evolutionist, would be the perfect transitional form. So it would have to be a blending or a combination of two categories, right? A really good combination of human features and a really good combination of ape features.
Gotcha.
James, would it be okay if I said something super quick?
Yes.
Just like mega quick.
Correct.
I would compare that to being like, okay, so we have Archaeopteryx, and then the human, comparison to that would be an airplane with wings that doesn't fly and rolls around like a car exclusively, which we don't see. So, transitional forms are kind of indicative of kind of rigging existing structures. It would be all I would say about that.
Gotcha. Let's see. We will, standing for truth, we can cut you loose. We know you got to go, so we appreciate you being here, and thanks again for your patience. I know we went over the time that we promised.
I was wrong. I'm
Sorry,
sorry.
it was a blast.
It was all a mistake.
Really enjoyed this debate. Good questions from the audience too.
Yeah, absolutely. Thanks for chatting with me, Standing. I had a great time.
And
Thanks so much, Erica. Hopefully we can do it again soon.
Yeah, absolutely.
It was a lot of fun.
Sure.
Quick.
We'll email. We can talk about it when I send you all those Crete papers.
Sounds good. I'm looking forward to it. Thanks.
All right. Great.
Thanks for doing it, Erica, and James, thanks for setting it up.
Thanks, Standing. Take care.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button, because we are just getting started.
Ladies and gentlemen, thrilled to have you here for another epic debate, as today we have Erica and Standing for Truth joining us for round 2. It's going to be an epic one, folks, and want to say, if it's your first time here, consider hitting that subscribe button, as we've got a lot more debates coming up. In fact, you'll see at the bottom right of your screen, Endgame, the final chapter between Mark Drysdale and Kent Hovind, will be this coming Tuesday. So our last debate between those two gentlemen, as it's always been fun to watch them, and so that's one you don't want to miss. You can set a reminder. So with that, want to let you know we are very thankful to have our guests here. In fact, not only that, but we're also giving a special thanks to Erica. She's a night owl, but nonetheless, it's impressive. She's over in London. Is it London right now, right?
Yeah. You can see my change of scenery. I'm in my normal living quarters. This is my flat, so I've got all the decorations up. Anybody who's subscribes to my channel, this is a familiar scene. So got the whales right here. It's gonna be great. I'm ready.
Epic, very exciting. So it's going to be a fun one tonight, folks. We are really looking forward to it. I want to let you know what we are going to do for format. I'm going to pull up on email because I'm trying to remember, unless one of you remembers. But
yeah, we're doing 5 and 5 short intros and then open discussion. Yeah, Standing.
Very good memory, Erica.
Hey, that's what I do.
Gotcha. Perfect. So it'll be, if I understand right, 5 rounds of 5 minutes. Is that what you're saying?
I mean,
No,
I thought
no,
it was
no.
openers and then open discussion.
Right. Yeah, no, it's
Oh, gotcha.
5-minute
I remember.
introductions and then just open discussion and then
Yeah.
Q&A, I'm guessing.
Thanks so
Yeah.
much. Appreciate it. Long day
That's
already.
the fun way to do it anyways.
You
That's
betcha.
what we're here for, James.
Stoked for it. Thanks for that refresher. And want to let you know, folks, if you have any questions, fire them into the old live chat. I will pull those questions out of the live chat, and we'll ask as many as we can at the end of that open discussion section when we get into Q&A. If you want to do super chat, that's an option as well, in which case it'll push your question to the top of the list for the Q&A, and it allows you to make a comment toward one of the speakers. Of course, they'd get to respond to it, and we ask you to be your regular friendly selves for that. And so with that, very excited, folks, I am going to set the timer for 5 minutes. And my presumption, because usually it's just the habit, we always have the creation person go first. Standing for truth, do you want to go first, or did you already decided that, did you guys already decide together that Erica would go first?
No,
I don't think we didn't have a choice, but I don't care.
Yeah, it doesn't matter to me. I mean, to be fair to Erica, she started first last time, so I don't mind starting first this time, but ultimately it's up to you.
Deal. Yeah, sure. You can start. Yeah, I always start. You start.
You bet.
Only fair.
Okay, let's timer set. Standing for truth.
Awesome. Well, thanks so much. Thanks so much for doing this, Erica. The first debate was a blast, so I'm really excited for this one.
And
James, as always, brother, thanks for setting it up. So before we get started, we all must realize that it's genetics. It's in our DNA where the question regarding ancestry is answered. Genes, traits, genetics is what's inherited sperm and egg. Sperm and egg don't pass on a fossil or a bone. They don't pass on geography or a rock. They pass on genetics and traits. And so if we want to find out the history of humanity, this is where we must look. We have clocks in our DNA, for example, that go back just 6,000 years to Adam and Eve. Let's discuss some reasons why, based on genetic data, the Bible's account of human history is true. When we focus on the variation, for example, in the Y chromosome in the world today, we see that Y chromosomes have very little variation. This indicates that we came from a common ancestor in the not so distant past. Interestingly, the Y chromosomes are geographically specific. There exists African Y chromosomes, British Y chromosomes, Chinese Y chromosomes. Why is this? This is because mutations have occurred in the lines after Babel, since God divided the nations based on their Y chromosome. The family lines are based on the male ancestry. These nations were divided across the planet. Is there good evidence for limited ancestry? Or does the evidence tell us that humans did not go back to Adam and Eve, but are actually related to apes, dogs, and banana plants? Well, the evidence for the existence of Adam and Eve and limited ancestry is you and me and the genetics of the people in the world today. The genetic structure in humans today speaks to us of a literal Adam and Eve. We have a small DNA compartment called the mitochondrial DNA that we only inherit from our mothers. Everybody on this planet got their mitochondrial DNA from a single woman, who is exactly what we would expect from a biblical Eve. She is quite literally the mother of us all. In a nutshell, we have nearly identical mitochondrial DNA, and the very few mutations that differ from Eve's sequence are exactly what would be expected if Eve arose just several thousands of years ago. As I briefly touched on earlier, the same thing goes for the male side. Science tells us that all men have similar Y chromosomes, which is passed down from their fathers. And all of male humanity traces back to a single man. This single male ancestor of humanity has all the qualities expected if the Bible were true. The main argument offered, though, by the evolutionist community, especially biologos, against a literal Adam and Eve and ultimately limited ancestry has to do with genetic diversity. They will say there exists no real scientific way for two people to generate all the genetic diversity we see in humans today. This main argument is easily refuted and actually reflects a poor understanding of even basic genetics. A man and a woman today could have thousands, even millions of children, and no two children would be 100% identical. This is because they are heterozygous. There exists built-in diversity in millions of sites within the genome of the average person. In the limited time that I have here, the best way I can explain it is if God created Adam and Eve to be heterozygous, which in fact would be optimal design, you could have as much human diversity and more than we have today in their first family. Time is not required for the diversity today because diversity can be designed and built into Adam and Eve. This argument is not even scientifically reasonable. One more line of evidence I do want to point out before we go into the discussion has to do with the HapMap data. The HapMap project is what I am referring to. And this very important project was intended to compile a significant fraction of human genetic diversity. They examined millions of variants in thousands of people from around the world and made the data easily available. Dr. Robert Carter puts it perfectly when he states, and I quote, "I am quite happy with what we learned from the project." What have we learned? The human genome is young. Shared blocks of DNA are large, and there has not been enough time to scramble them to randomness. The human population came from a single source. Most blocks are shared among all world populations. The human genome is falling apart. Deletions tend to not be shared among populations, but are unique to subpopulations. This is further evidence for the youth of the genome, and that we came from a single source population in the recent past. I've got 10 seconds here. Genetic entropy, orphan genes, the chimp Y chromosome, endogenous retroviruses, linkage blocks, for example. There's many different lines of evidence we can look to that point to limited ancestry. And I'd be more than happy to discuss any one of these topics with Erica and show her why limited ancestry is true and universal common ancestry is false. Thanks so much.
Thank you very much, Standing for Truth. Just several seconds over. We'll give Erica the same leniency. So with that, we will jump over to Erica's opening statement. Thanks again for being here, Erica, especially given how late it is. It's a pleasure to have you.
Please don't worry about it. I will, if that's okay, share my screen. I know I normally have my nice monitor up, but I don't have anywhere to put it. So
happy to do that.
If that's cool, it's just a PowerPoint. I've never done the screen share thing, so bear with me, you guys.
Totally.
Here. All right, share my screen, and then can you guys see that?
It's now showing. So let me just squeeze it down to make it fit.
And I'll do one of those. Does that work? Okay. Very cool.
Almost there. 3, 2, 1. Okay, and we're set.
All right. So biology supports a universal common ancestry. This is the argument that I am going to make today. Now, generally speaking, when we look at a universal common ancestor, what we're kind of referring to is that all life on Earth shares a common ancestor in the form of a single-celled organism some 3.8 billion years ago. Now, as Standing mentioned previously, his argument is somewhat different in that he's sort of going for the creation orchard, so to speak. So if you can see in this picture here, this would be Standing's creation orchard on the left, where we have several sort of nodes that are acting as creation origin kinds, right? And the diversity within those kinds is stringent and kept separate from one another. Now, of course, my position would be the conventional tree of life, which is here on the right. So the question is, why do all of the fields in biology agree that universal common ancestry is indeed sort of the reality that we live in? And the reason is because, at least in my opinion, in my humble opinion, it is the case. This is, in fact, our reality. We can look to genetic support, we can look to paleontologic support, and we can look to morphologic support. Now, as Standing said, we're probably going to be talking mostly about genetics today. So while I included some slides here on paleontology and morphology, which I will skim if I have the time, we're mostly going to be considering genetics. So I've harped on this many times before in other debates and in other conversations, but genetics by definition dictates relatedness. This is simply the case. The same sequencing that links humans to all other humans links us to the other apes, all the mammals, all the chordates, etc. So when you look in this picture, again, as I've said multiple times before, the same logic, the same genetic sequencing, the same means by which we develop phylogenetic trees, Standing would agree within sort of the kinds. Like they, Christians tend to use kinds, sort of structure their kinds with genetics as well. The question is, can the lines cross? And my argument here is that there is no empirical reason to suggest that they would. There just isn't. It's a smooth gradient. And I've said this before too, but the sort of the same process that we use to allow paternity tests to be considered admissible in court. We use to reach the 98.8% similarity between us and the members of genus Pan, and then indeed 92 with the macaques, and so on and so forth. So in addition, we could talk about endogenous retroviruses. Now here I've linked a couple of nice papers that cover the similarities of the ERVs between us and the chimps. And we have this nice little quote on the side that you can read if you like, which, to summarize it, 99.9% of ERVs in humans are at the identical location and are structured identically between us and the chimps. And even when we look at these specific ERV insertions, we find that the mutations that those ERVs experience in and of themselves are also identical, which means either we're dealing with a completely separate event for every single ERV in every single primate lineage, both within and without or outside of the human and the ape kind, and the monkey kind, I'm not sure how standing structures it, or we're dealing with a common ancestor. So my question would be, why can creationists not draw these lines between the kinds? Why do we see this smooth gradient that I've been sort of alluding to? You can sort of see the same thing when we look into deep homology, which would be kind of the argument that we're dealing with the same building blocks. So geology and paleontology, of course, continued to confirm common ancestry, and not just that, they preclude a 6,000 to 10,000 year old Earth. Now, I know it might seem sort of tangential to bring this up in a conversation about genetics, but in genetics, we get sort of divergence times using molecular clocks. And interestingly enough, radiometric dating, a completely isolated physics-based sort of just equation that we use to measure radiometric or radioactive decay, confirms this. They corroborate one another. And not only that, but paleontological evidence can also be corroborated with other methods like ice cores or dendrochronology or natural nuclear reactors like the Oklo reactor. Then, of course, there's morphology, atavisms, vestigial structures, deep homology. Here's some nice pictures. Sometimes we see horses, display these additional toes that they used to have when back with Eohippus and the like. Vestigial pelvises, which I know some people say have a function in copulation, but not so. Ask any of the whales that require a third party to mate. We see deep homology in the form of the PAX6I gene. Rector pili with our hair standing on end, and of course our wisdom teeth. None of these make sense when we're sort of taking this idea of a designer into our mind. And I know that genetic entropy is going to be brought up, and that's the reason why we have these sort of degenerate traits, but I'm ready to have a conversation about that. So my question for standing is sort of threefold. Well, I think there might be more than three, but where, and more specifically, why do you draw the lines between the kinds, and what separates the humankind from the ape kind? You can do this genetically or otherwise, I don't care. Another one is, how can limited ancestry account for the gradient of forms that bridge the kinds in the fossil record? So here we have an amphicyanid, and we have a wolf, and we have a grizzly bear. Now, morphologically, it essentially looks like you took 50% of the traits from the amphicyanid and then sort of parceled them out into these two very closely related animals that we have today. And lastly, why do we see atavisms and vestiges in nearly every animal? And why do these vestiges seem to indicate and suggest that they're from our genetically derived ancestors? Why do they match evolutionary theory? What's the deal with a whale having a pelvis and then also us finding similarly structured organisms living in the same location with the involucrum, which is an inner ear structure unique exclusively to the cetaceans, and through geologic time? So these are sort of my questions for the conversation, and that's it.
Thank you very much, Erica. So now we will switch back over to, or I should say we'll switch into open discussion section. So I will close your share screen. And gotcha. Okay, thank you. Very sassy. I appreciate that. Next, we will go into the open discussion section. So very exciting, folks. And the floor is yours. Thanks for being here again.
Yeah.
Awesome.
All right, Sadie, where do you want to start? You get to pick because that's how we did it last time.
Sure. Awesome. Well, I appreciate your opening. Thanks for the visuals. Definitely lots of good questions, lots of good topics. Since you started off with ancestry anyways and where we can draw the line and kind of how there's a perfect gradient, a perfect nested hierarchy of life, I guess you can put it. My question to you then would be regarding certain taxonomically restricted genes that we can look to separate ancestry, right? So if we're going to look at limited ancestry, for example, if we look at orphan genes, and orphan genes, they lack similar counterparts in other organisms, as in like there's no evidence for common ancestry with, say, humans and chimps because of these taxonomically restricted genes that are specific to humans, and then also very specific to, say, chimpanzees or like the cat family.
Well, sure, of course there would be, because the divergence time between humans and chimpanzees, well, the divergent time would be approximately 13-ish million years ago, with the speciation time being 6 to 7, give or take. So that's plenty of time for you to get emergence. That's of sort of genetic novelties. That's why we have ERVs that are also unique to humans. But you can point to those, and the exception does not make the rule. You can't point to the exception and say, oh, look, there are, individual ERVs or orphan genes, et cetera. I don't know nearly as much about orphan genes as I do about ERVs. But then I will simply turn and point to the 99.9% of ERVs that we share that are identical and in identical locations. So are you suggesting, just to kind of turn that into a question, are you suggesting to me that there have been separate genetic events regarding sort of these ancestral viruses for every single primate lineage, and then also humans, who I'm assuming you wouldn't accept our primates?
So good questions. I definitely want to talk about the endogenous retroviruses, but going back to the orphan genes first, as a counter to that, the orphan genes, for example, they're fully functional gene sequences, and what they do is they code for both a functional messenger RNA and a protein, okay? These orphan genes, though, Erica, they don't fit the hypothetical fairy tale of evolutionary theory, and our prediction based on ancestry and proving limited ancestry would be function, okay? So if these orphan genes, which according to our model are needed for the uniqueness that's associated with each created kind, as, say, described in the book of Genesis, which obviously we look to as a starting point, the fact that this amazing category of genes are taxonomically restricted and extremely functional and unique to each type of organism would suggest a limited ancestry, for the main fact that they are fully functional. I mean, how did these come about in separate ancestries according to the evolutionary theory? I want to just make an analogy real quick, just for the audience. It's like looking at 3 different books and then finding specific words that have important meanings in the different books that aren't found in all 3 books, right? There's no evidence for any type of ancestry. That's why they call it orphan genes, right? There's no actual evidence for the ancestral genes leading to these genes. So I mean, how would those pop up in evolutionary theory?
Well, I'm asking though, why are you yes, things can be taxonomically restricted. I mean, obviously there are, as I said previously, there are sort of unique ERVs to humans. There's also unique breakages like that are just in the primate order. There's a breakage that does the same thing, the gulo breakage, that also exists in guinea pigs, but it's very different. It's in a different location, and it lacks some of the sort of regulators that ours has. So I'm kind of wondering why it is that you're suggesting that in any shape, form, or fashion that these orphan genes cannot emerge after splits, after divergence points.
Well, I mean, it can be suggested that they do pop up. Like, I believe that the evolutionist explanation is de novo gene synthesis, that they popped up through the non-coding regions of our genome. But the question is there any empirical observational data for that occurring? And the fact that they've popped up to be extremely functional in the genome seems to be more ad hoc, post hoc reasoning. But if I'm arguing for limited ancestry and these types of taxonomically restricted genes that are extremely important in the genome, or what are expected to be found, and this is exactly what is found.
Right, but what you're doing,
would suggest limited ancestry. It's exactly what we expect to find. Go ahead.
Right, but you've got to. I think a clear distinction has to be made. So when we're looking at data in general and we're trying to support a hypothesis or see if the data does support a particular hypothesis, it can, obviously, as we know in the nature of science, data can support multiple hypotheses. But the sort of the issue with this is you're suggesting the orphan genes. Again, that's kind of why I wanted to make it more about biology in general, because I'm not a geneticist, but I know enough about it. Yeah, but I know enough about genetics to know that these kinds of sort of emergent genes, ERVs, et cetera, things like that, they don't preclude evolutionary theory in any way. You're arguing that it supports limited ancestry, and again, I don't know enough about it. It may support limited ancestry, but it also doesn't preclude evolutionary theory and universal common ancestry. And in light of pretty much, in my opinion, everything else that sort of I brought up in my presentation that I'm sure we'll touch on later, which not only does it support universal common ancestry, but it also precludes limited common ancestry. You see what I'm saying? Because there can be data that's like, it fits both frames. Like I know Jensen likes to do that with nested hierarchies, which I disagree. But the fact of the matter is then he turns, and I'm sure we'll do the same thing, and covers other subjects that he believes supports limited ancestry by precluding universal ancestry. Well, right, so it sounds to me, you get what I'm saying. Sorry.
Right. Yeah. And if we look to homology, right, engineers build in a homologous type pattern, or we can look at DNA level nested hierarchies. We can look at nested hierarchies on an amino acid level, right? I know Dr. Herman Mays likes to look at neutral variation, for example, but when there are competing hypotheses, we need to look at lines of evidence that can differentiate between the two. Now, I disagree.
Absolutely.
Right, but I disagree with your point in that orphan genes can be explained through fish to fisherman evolution because of the important functional roles that have been discovered in them. They are taxonomically restricted, and I've yet to hear an explanation from you as to how these orphan genes can pop up, can be specific to lineages, for example, humans, to the great ape family, to the cat family, to the dog family. How are these popping up and having very important functional roles? I mean, that doesn't just happen. We also don't see that empirically in the lab. That's the thing. There has to be some type of explanation in order to have that competing hypotheses, but I don't see no explanation for these. That's why they call them orphan genes. That's it. You know, they belong in specific taxons, and that's it.
Sure, but you're suggesting that the existence of, and I know that you mentioned that sort of the conventional science side that would say, okay, well, it's kind of this de novo emergence, but that does happen. I mean, I know you're frequently a fan of using ERVs that play roles in embryologic development because they've sort of been retrofitted. That's like a huge tenet of evolution, the atavisms, right? Like this idea of taking, something that used to do something else and, or not atavism, sorry, in some cases of vestiges, and using it for something new. I mean, because you're right, most ERVs though have zero function, but some of them do. And they did pop up, right? At least according to
real quick before you guys, I understand that you want to move on to the endogenous retroviruses. Just to kind of end the part on orphan genes, we can do that. I don't want to beat a dead horse. Let's move on to endogenous retroviruses and retrotransposons, for example. I would just disagree that orphan genes aren't a line of evidence that can differentiate between the two hypotheses, right? Universal common ancestry and limited ancestry. We can just agree to disagree.
And we can.
Want to look to the de novo gene synthesis, we definitely need to see empirical data, whether it's in the lab or some type of technical paper that can actually show a non-coding region of our genome suddenly pop up and become functional as a protein coding gene.
So I kind of know where this is going. So I am going to openly in front of everyone make sure that this is clear. I don't know very much. In fact, I know very little about orphan genes. What I do know quite a bit about, or a decent amount about, is endogenous retroviruses. And the reason why I'm making the connection is because it sounds like conceptually there are quite a few similarities. So I'm not saying that I know enough about orphan genes to say this is certainly the case. I probably need to look into it, but I don't particularly find presenting a piece of evidence that, knowing absolutely nothing about it except for the blurb that you've given me here, could go either way in light of everything else that we're getting ready to discuss, convincing as a gotcha. You know what I mean? Because it sounds very similar.
Well, there's many
to
lines. Yeah, no, I agree. There's many,
it sounds similar to the gotchas that creationists use with ERVs. That's why I keep making the comparison. Not because I'm trying to dodge away. Oh, I don't want anybody to know I don't know very much about orphan genes. I don't. I'm not a geneticist. But that's the way the cookie crumbles sometimes. So I'm just saying I don't find that convincing. I mean, if there are, geneticists out there who are saying, yes, de novo orphan genes can happen, then the fact that we have de novo ERVs, emerging from ancient viruses and such things like this, and of course, new information through various mutations, I don't see a problem. It's completely in line with other conventional arguments that we're going to talk about.
Right. If I could just jump in real quick, because I definitely want to jump into the ERVs and the retro transposons, and I'll give an answer to that. Just on the orphan genes and in the, it's not necessarily just a gotcha type argument. I will go on record that the evolutionist community, they are somewhat baffled, and that is why they look to de novo gene synthesis. But to me, that's more of a circular argument, because the evolutionists know that orphan genes exist. Therefore, they need to hypothesize, why do they exist? So they resort to de novo gene synthesis. Well, why do they resort to de novo gene synthesis? Well, because orphan genes exist. So I'm just saying it's more of a circular-based argument. Now, when it comes to the co-option in the functions found in endogenous retroviruses, I agree that these endogenous retroviruses, or the retrotransposons, for example, Erica, they are shared among humans, among some of the apes, of course. You can find nested hierarchies in the placement and positions of the ERV. So I agree with that. But the question I think we need to ask ourselves, Erica, is what are these endogenous retroviruses? What are these retrotransposons? Are they actually the leftover remnants of viral infections in our DNA, like you're suggesting, right? Or are they, say, created units of DNA function? Because for years, Erica, it has been assumed that they were the former, right? The leftover remnants of viral infections. And that is because, like you iterated in your opening, they bear strong similarities to actual viruses. And this predicts that these sequences are non-functional. And I know you look to co-option as an answer to the function, but this is a testable prediction based on the design model, and we are beginning to accumulate data. So what we do know at this point in time, Erica, is the trajectory of experimental results, and the trajectory points to increasing and surprising levels of function. So to me, it looks as if these are not remnants of viral infections, but actual functional DNA units. Now, what's their role in ancestry and in speciation? But this specific prediction, it does differ from creation and evolution expectations. Go ahead, take as much time as you need.
Sure. So I'm going to kind of respond to that in twofold. One, I'm not kidding here. We do know of a lot of endogenous retroviruses. We're not completely in the dark about this, and I know of like a handful that actually do something. And so I'm kind of wondering where you're coming with this sort of concept of, oh, well, the trajectory is we're going to find out that they have more function. And I think I know where you're going with it. And I think it has to do with the ENCODE project, because I've heard you speak sort of before on ENCODE. And for those of you out there who don't know, ENCODE was a sort of group that did quite a bit of genetic work on discovering the functionality of the human genome. And they came out with this quite large number, 80%, they came out to say the human genome was functional. Now, their definition of that sounds impressive until you actually read the work.
Erica, I don't want to interrupt, but I feel like ENCODE in general I just feel like ENCODE at this point is kind of a rabbit trail, because we're specifically on the endogenous retroviruses.
Sure, but you'll see the point I'm going to make. It's relevant. Because I actually watched your discussion with your series of discussions with CRISPR earlier today. And you mentioned several times this concept of, oh, well, the trajectory seems like we're going to find a lot of functions. But so I thought to myself, okay, well, time to look into that. Let's see, because I know CRISPR was saying, no, absolutely not. The vast majority of people in the field are saying, similar to ERVs, no, it's not looking like we're going to find more function, because every time they investigate, they find a function for something new. It makes up a smaller and smaller and smaller proportion of the genome. And there was a paper that came out in 2017, very recently, that put an upper cap and very unlikely upper cap of 25% of functionality, with a likely range of 10 to 12%. So that's the most recent literature on that, and it doesn't follow the trajectory that you were mentioning. So I don't think that you can say, because you find functions in one ERV, or you find a little bit of function in say, an intron or whatever, you can't just say the trajectory seems like we're going to find more and more, and then eventually we find out all ERVs are functional, or all of the human genome is functional. That's all I had to say. That was the connection.
Oh, awesome. And I appreciate that response and those points as well. And I did enjoy my discussions with CRISPR, and would definitely recommend anybody watch them. But you say that like just one endogenous retrovirus, for example, was found to be functional.
Oh, that's hyperbolic. I'm sure it's more than one, but continue.
Okay. No problem. Even in the ERVs though, it's not just low levels of function. And that's the problem that the evolutionist faces, because the ERVs, they actually have crucial functions, Erica. For one, they help regulate genes. So they're not just functional in the embryo. They help regulate genes and even determine cell types. So I know that you're claiming that they were co-opted, but I would just say that that's mere uninformative gloss, because I would have to see empirical evidence, whether it's in the lab or some type of technical paper, that actually shows us a non-functional endogenous retrovirus going from non-functional to extremely functional in determining cell types or regulating genes. Before I continue, actually, would you be able to present something like that?
Hold on. What I want to talk about is your request there. You're saying, okay, well, I want to see.
I'm not saying you have to present it right now, but does something like that exist where it has been observed empirically that a non-functional endogenous retrovirus went from non-functional to a functional DNA element, important in the embryo, important in regulating genes, important in determining cell types? I mean, could you present that to us?
I mean, I would say you've already done so, because we have, what I mentioned earlier, right, is that we have several, and what you agreed to is that we have, so many non-functional ERVs, you can't hardly list them out on a piece of paper. And then we proceed to talk about a functional ERV. So I think the burden of proof is on you to find function for them. If the vast majority is non-functional, and you're making the claim that functions do exist for all, or at least the vast majority, the burden of proof is on you to show that they have function, not on me because we have point A and point B.
Well, real quick.
This would be like
real quick, I don't want to, because you brought up some things about ENCODE. I was kind of just clarifying with you, and I want to kind of touch on everything, because it's not just one or two ERVs that are being found. I mean, there's accumulating paper after paper. I mean, I've got papers here from 2019 that are now showing these ERVs. They frequently act to distribute regulatory information and thus confer genes with new patterns of expression and function.
I don't doubt it. I don't doubt that there are tons of ERVs that have functions. The problem is, and I checked today, the vast majority of ERVs are functionless. And
have they functionally tested the vast majority of endogenous retroviruses though? Because remember, real quick, evolutionists assume, and you admitted it earlier, that the vast majority of our genome is based on genomic fossils, evolutionary leftovers. But far from being junk DNA, the pervasive retrotransposons, or the endogenous retroviruses, for example, that populate our genome, they have a powerful capacity to influence genes and even chromatin. I mean, the functions are endless. I can go on and on. Even the pseudogenes. I'm saying I'm saying that your argument about co-option and suddenly the burden of proof is on me is more of a circular argument, just like with the orphan genes and de novo gene synthesis. So you're seeing that these real quick, I'm almost done. You're seeing that these endogenous retroviruses are playing very important functional roles in our genetics. So instead of actually giving us and providing us empirical evidence for the co-option of these endogenous retroviruses, you're just assuming that they've been co-opted because it doesn't fit the evolutionary theory, but it hasn't actually been demonstrated. And I'm saying that the trajectory of discovery does favor genome-wide functionality because every single month, more and more papers come out suggesting more and more function. That's
no, why. You're okay. First, I'm going to make a quick analogy. If I come out and I say horses are the most important mode of travel, that's just what they are, and you say, well, no, that can't be so. And I say, yeah, look at the Amish. They can't get around without horses. And then you say, well, no, because mostly people get around in cars. And then I say, no, it's really, really important in this one particular case that the Amish use horses. Are you getting what I'm saying? Case. These functional ERVs have indeed been co-opted. And the way that we know that they've been co-opted, other than the fact that they look very much like ancient viruses just in structure, when we look at them genomically, is the fact that the vast majority don't do anything. And when you say things like, well, the trajectory looks like, that's a very vague statement, because the fact of the matter is your talk with CRISPR was what, at least a year ago? And I checked today and they capped it right where he said they were going to cap it. He said upper limit, I think he might have said 20%. So he was a little off. He said upper limit, no more than 20%. Right. 2017, upper limit 25%. And
real quick,
I'll pull something up for you.
I'm actually happy that you've at least admitted to that, because I even debated a biologist, I think it was 2 weeks ago, and I've debated like T-jump, for example. And every time I ask that question, right, how much of our genome, both non-coding DNA and protein coding DNA, do you believe the evidence suggests is functional? And you just said it there, just like CRISPR said, it can't be any more than 20%, 25%. But the thing is, that's because any more than that makes that type of fish to fisherman evolution impossible, simply based on mutation accumulation. Well, I've got a paper here that suggests that the genome has to be under 20% functional, or else ape-to-man evolution could not. Well, actually, real quick, before we go on too many rabbit trails, because I still want to touch on ENCODE, because a few things that you said I disagree with. Are you disagreeing with the fact that we do see massive amounts of literature nearly every single month that gives us unexpected functions of RNA? And then as you answer that too, how much of our genetics, of our genome, do you believe we've functionally tested according to the gold standard of genome testing? Go ahead, take your time.
So first, we can swap papers in a moment, because I straight up sat down today. I sat my butt down on Google Scholar and I combed for all literature that I could find that was recent on functional DNA. And the most cited paper, the most seemingly sort of groundbreaking biggie that came out this paper in 2017. Now, of course, we're always discovering new things about genetics. And of course, some of those things are new functions. But again, this conversation you had with CRISPR was at least a year ago. And we have discovered we haven't passed the cap. We haven't even gotten close to passing the cap that he set. These guys are saying, and I'm going to read this to you instead of sharing my screen, just because it's annoying for everybody I know, and it causes a delay.
Well, real quick before you do that, can you just answer the question as to how much of our genome has been functionally tested? Because that's important in this discussion. Because whether
I'm going to respond to that with the same sort of rhetoric back and forth that you and CRISPR had. So humans are mammals. And that's why we use mice and that for testing and things like that, our drugs and sort of pharmaceuticals. And that's why our pharmaceuticals tend to work so well, because we share so much in common. We have done extensive knockout tests on mice. We can knock out so much of their genome and they will be just fine. They reproduce, they have babies, their babies are just fine. So that's because that section that we're knocking out is non-functional. It doesn't harm them to knock it out. So, because I know this ENCODE conversation is going to go down the, oh, well, maybe the non-coding or the non-functional quote unquote DNA is actually for development. That debunks it right there. The fact that these mice with enormous portions of their non-functional DNA knocked out can go and reproduce just fine. They might have a couple of like weird little morphologies, but other than that, their fitness is increased.
Well, before you go on for too long with the mice, the problem is many non-coding RNA genes, even pseudogenes, for example, much of the non-coding regions of our genome, they're only expressed under certain conditions. And much of the genome is likely involved, for example, and used between conception and birth. And the fact that many of these non-coding sections of our genome are only expressed under certain conditions, you'd need almost unlimited sensitivity in these genetic knockout tests being done on mice to conclude with any type of certainty that those genes being knocked out really are non-functional. Because if these genes are being turned on and off, let's say after the developmental stage, or just based on environmental conditions during the life of the mice, especially because these mice, the genes are being knocked out in the laboratory. Therefore, many different environmental conditions that are outside of the laboratory, that a certain gene that isn't expressed and it's being knocked out, well, you're not going to be able to know that it's functional or non-functional. And the answer to your question, based on genetic knockout tests, especially with humans, because it's unethical, it's less than 1% of the genome that's actually been functionally tested according to the gold standard of science. So I even asked that question too. I asked that question to CRISPR, and he went on looking for a paper to show how many of these experiments were performed based on these genes that are only expressed under certain conditions, and he never came back with the specifics on that. So you'd have to show that. I don't believe that those types of knockout experiments on mice have been performed.
To be fair, in that conversation, while he was looking, you were like, you can just get into me later. So there is always the possibility, as I frequently do, that he just forgot to send them to you. Now, I obviously have not,
and that's fine. That's fine.
Yeah, and that's fine. But I feel like you kind of obfuscated the point there, because again, for everybody who's watching, right, these knockout tests have been done on adult mice, or rather the impacts are on adults. They reproduce, they pass those knocked out genes to their offspring, who develop just fine, and then reproduce themselves after living their merry mice life. So the point is that if you're suggesting that there is no plausible way that I can see to suggest that genes that have been knocked out, even though we've done it on enormous portions, are secretly doing some kind of function when nothing bad happens when you turn them off completely.
Well, no, I'm not saying something.
Already broken breakers.
Well, just to be sure that Erica's finished here, because you talked for a long time, and I want to just be sure Erica gets plenty. Also, right. You got it.
Well, I'm not saying that I'm not using a pseudoscientific argument suggesting that many non-coding RNA genes are only expressed under certain conditions. I mean, this is actually a fact. And my main point regarding that is we have only begun to discover just how functional, for one, the human genome is, and how functional the mice genome is. And I'm saying it's mind-boggling how many experiments, and I'm not saying it's impossible, but these number of experiments have not yet been done, and that's a fact.
And it's not, though, because knockouts have happened, and the mice still reproduce.
But the amount of experiments that would be required to conclude, is my point, with any level of confidence that a particular set of DNA sequences has absolutely no function, is mind-boggling. And
but the amount of experiments that you would have to do to conclude anything without beyond a shadow of a doubt is astronomical. The point is that the fact that you can knock out enormous portions of a mouse, and then the mouse can reproduce, and then its offspring can also reproduce because nothing of merit has been lost, is parsimonious only with evolutionary theory, that's what I'm saying. To use your word from earlier, the trajectory indicates that enormous portions of the genome can indeed be knocked out because they don't do anything. So, and I want to segue this in because
I didn't say that they don't do anything. I'm saying a lot of those regions in the because the non-coding DNA, it functions much like a computer, okay? It's involved in regulatory functions. It's involved in embryonic development. It's even involved in the stagings of proteins for.
But they can't regulate if they're off.
But I'm
if
saying
you knock them
that,
out, they can't do anything.
No, but if these specific genes, and we have to look at which ones, what types of developmental windows, which types of environmental conditions, because if these experiments are being done strictly in the lab on these mice, well, these non-coding RNA genes, for example, even some of the pseudo genes, yeah, you're going to knock that out. You're going to snip it out, and it might not have some overall effect on genotype or phenotype, but that's because it's just not expressed.
Yeah,
so
but we're not talking about.
Just real quick, if you consider that, and then you consider, if you look at comprehensive knockout experiments for humans, for example, it's unethical, obviously, at this point. We functionally tested, genetics-wise, under 1% of the genome when you consider non-coding DNA and coding protein coding DNA. But the thing is, and the question I asked you earlier regarding the RNA, we do see massive amounts of literature that gives us unexpected functions of RNA. For example, are you familiar with protein moonlighting? Because
yes,
in the past,
of course.
Right. In the past, one of the ideas, you can just pick up a textbook from 40, 50 years ago.
One gene, one function, or protein, one function. Yes, I'm with you. Continue.
Exactly. Now, if we're looking at the protein multifunctionality, or we're looking at, say, on an amino acid level, these redundant codons, and I'm sure you've heard me say this before, those were always assumed to be absolutely neutral. Now we know they don't just tolerate error in the cell. These redundant elements, they're used to slow and speed the process. So the level of information compression into every single letter boggles the mind. It's actually incredible. And even
I'm sure that is indeed the case, but that's not the problem that I have with your statement that and in this conversation and in previous ones, that the majority of the genome is functional. The fact of the matter is, if you knock it out, it doesn't work. It doesn't do anything. If it doesn't do anything before you knock it out, there's no harm, no foul, right? So the fact of the matter is, if they do something important, anything, regulation, whatever, it doesn't matter. If they have a job that's even minute, if you knock it out, that job doesn't get done.
How much of the mice genome has been knocked out, though, on a percentage-wise?
Oh, I could not give you a number on that. If you
well, I could, and I could be corrected on this, but the last time I checked, it is less than 30%. So based on the fact that these tests are being done in the lab, based on the fact that less than 30% of the mice genome has been knocked out, and the fact that, as I've said about 3 or 4 times, many non-coding RNA genes are only expressed under certain conditions, less than 1% of the mice genome, the human genome, mammals in general, has been tested for genome functionality. And all you have to look at, like I talked about earlier, you just have to look at the history of genetics. Like you said, back in the 40s, 1 gene, 1 protein, 1 function. I've said that multiple times. You can see how many things have been changed. So yeah, I agree that the results from the ENCODE project, Erica, I do agree that based on their suggestion that at least 80% of the genome is functional biochemically, right? Because it's showing that the non-coding DNA is transcribed into RNA. Those are preliminary. I agree with that. But I'm saying the trajectory is clear based on genome testing, based on the history of genetics, that the trajectory does suggest most non-coding DNA in the human genome is functional. At least it serves in a regulatory capacity. I mean, do you stand by a genome of only 20% max functionality?
Here's the thing, Standing. I go by current literature. And what I try to do when I don't know something about a topic is I check the most recent literature, I see how many times it's been cited, and I see who's on the paper and investigate their background. because that's, it's just like what they teach you. It's appropriate sourcing. And I'm going to read you this excerpt. It's quite short from this 2017 paper, which was New Limits to Functional Portion of Human Genome Reported. An evolutionary biologist at the University of Houston has published new calculations that indicate no more than 25% of the human genome is functional. This is a stark contrast to the suggestions made by the scientist with the ENCODE project that as much as 80% of the genome was indeed functional. They took a deceptively simple approach, basically, to sort of sussing this out by looking at deleterious mutation rates and replacement fertility rate, which is quite odd, and I wouldn't have thought to do it, but I'm also not a geneticist and that's not really my world. But this is the quote that I think is important. This is from the paper. It's Grauer et al. If you want to look it up.
I've got that in front of me.
Or I can send it to you, too.
I have it in front of me.
Oh, good. Okay. For 80% of the human genome to be functional, each couple in the world would have to beget an average of 15 children, and all but 2 would have to die or fail to reproduce, he wrote. If we use the upper bound for the deleterious mutation rate, which is at 2 × 10⁸ mutations per nucleotide per generation, then the number of children that each couple would have to maintain a constant population size would exceed the number of stars in the visible universe by 10 orders of magnitude. So this is the most recent literature. Not only does it say, probably no more than 25%, they're saying it's impossible. So that is evidence that precludes, it's just using math, deleterious mutations and reproductive rates, replacement rates and things like that. And it directly precludes what you just said about trajectory. Because like you said, these papers come out every day. And every time the new DNA that they find that's functional, the new portion of the genome, gets smaller and smaller and smaller. They might say, oh, wow, we found out that 0.15% of this, given portion is functional. Add it to the list, but it's sort of exponential. There's not that much more to kind of sort of complete what we know, at least about the proportion of what is and what isn't functional. I encourage you to read the paper because I'm not a genetics person, but I found it quite easy to understand. And the math is pretty straightforward.
Right. So I appreciate that response. So in that paper, what Gore says, he says that human evolution would be very problematic if the genome was 10% functional, but would be completely impossible if 25% or more was functional. So what he's demonstrating here is what results from an evolutionary mindset, because he knows, based on the possible functionality of the genome, if we look at mutations, if we look at what's inherited, mutation accumulation in general, it would make that type of ape to man evolution impossible, because of the fact that if you have a genome that is, say, 50% functional, 60% functional, well, that means these so-called neutral mutations that supposedly build up with no real effect on phenotype and genotype would actually be more so nearly neutral.
Right.
That
so
means
you're saying there's a heavy bias, is what you're saying.
I'm saying there's a heavy bias, and you can even see that with the ENCODE researchers themselves. You can see that they did their research without that evolutionary bias. And evolutionists like the author here in this paper, they would have to fight the results of ENCODE. They would have to fight any type of trajectory that suggests the genome is any more than 20 or 25% functional based on the accumulation of mutations. Because, for example, Komura's theory of neutral mutations, right? Neutral mutations build up. Those neutral mutations are used over time by organisms to change, to adapt, to modify. But
well, Komura was taken greatly out of context. I looked into that as well, with Jameson or Tompkins. I can't remember which one. But I want to make a very short, brief comment.
Real quick before you do go on to that, and you take as much time as you need. The point that I'm making here is, obviously I disagree with the with the idea or with the belief that the genome is 20% functional or 25% non-functional or functional max. Because, and even if I were to just say concede that or just choose to agree to disagree, even if though 90% of the genome is perfectly neutral junk DNA, say only 10% of it is functional, that's still a huge problem, because based on what we know about the human mutation rate, right? We accumulate 100 new mutations per person per generation. That means, Erica, if I were to just agree with what you're saying, about 10 harmful mutations are still arising in every person, every generation. That means even the most fit individuals are still more mutant than their parents. And so even with intense selection, if we're looking at natural selection here, against the less fit, it cannot stop mutation accumulation. But like that paper suggests, the more functional the genome is, the more of a problem genetic degeneration becomes. Okay, take as much time as you need.
Yes. So here's the thing, and I'm going to use this to segue into genetic entropy, because I feel like that's kind of where you're, pulling a little bit, which is fine, because I got my notes right here, because I don't know enough about genetics just off the top of my head. Give at least numbers. But I want to make a quick comment about bias. Now, in the social sciences, anything that require many areas of science that require an interpretation of the data, bias can be problematic. Here's where bias can't be problematic: with math. When you're just doing equations based off of either known rates or variable rates or whatever, as long as you've got your error bars, they're going to cover your bias. That's what they're there for, to say, okay, well, it's give or take, right? So you can say, yeah, he's biased to evolution, so's the vast majority of science. And I would agree with you, because I am also biased towards evolutionary theory, but it doesn't matter, because all he did was use math to get his point across. He plugged in equations. You can say I disagree with it, but that's the same thing as being like, I disagree with whatever, the Pythagorean theorem or something like that, just like an equation. Now, if you went in and you discovered, I guess that's a bad example, if I showed you an equation and you were like, I disagree with it. Now, if you go in there and you find an actual problem with it, that's another story. But as far as bias goes, it's not problematic when you're dealing with mathematics or physics or things like that. Or at least it's far less of a problem, because there's less room for interpretation. Now, as far as genetic entropy goes, it's not real. Genetic entropy, or at least the conventional science term, is error catastrophe. And it doesn't happen for several reasons. If you've got, go ahead and give me, I want to make sure that I'm kind of addressing the proper point, so I don't go on a big spiel and then we're talking about something different. When you talk about genetic entropy, are you talking about the accumulation of near neutral mutations that causes degeneration?
I would say, if you look at genetic entropy or genetic degeneration, for example, it is the fact that natural selection cannot stop the accumulation of most harmful mutations. The problem is that the human mutation rate, for example, it is widely accepted to be 100 new mutations per person per generation. Now, even if I were to agree to disagree on your point or assertion that max functionality of the genome is, say, 20%, 25%, even though I want to make one last point about the function of the genome anyways, I would say that it is a fact that ENCODE, which you were referring to earlier, it does at least show that most of the human genome is functional, but also functional on many layers. Like, we literally have layer upon layer upon layer of programming, Erica, within the genome. And no computer program has ever been seen to arise by trial and error or by chance. But genetic entropy would suggest that these mutations that evolutionists are saying drive the evolutionary process are either nearly neutral, which are slightly deleterious to the genetics, or detrimental. And that's the problem, is what type of selection is going to be able to filter out all those bad mutations, whether nearly neutral or just detrimental. Go ahead.
So the thing about ENCODE, again, just to give my, I guess, final point on it. For those of you who are watching, one, the definition of functionality is incredibly loose. And if you watch Stanning's conversation with CRISPR, who is has sort of hands in many different fields. He knows quite a few people who are, he's a cancer guy himself, but he knows quite a few people working in various areas of bioinformatics and things like that. And his conclusion was that he could maybe find 2 people out of the dozens upon dozens upon dozens that he works with who would agree that the definition of functionality was even remotely appropriate, because their definition of functionality covers everything. And the reason is because that's how you sell a project. I've been trying to sell my project for grants, because I'm doing a master's program right now, for several weeks, and you have to make it sound good or else you don't get the funding. So, and that I'm not saying that like it's anecdotal. That's how it is. That's just academia.
And just for the record, I'm not disagreeing with the definition that ENCODE used and the definition that CRISPR says that they use, right? Because ENCODE defined function as specific biochemical activity. And that's why I agree with you that the results suggesting that over 80% of the genome is actively transcribed in RNA is preliminary. That's why we've made a prediction as creationists that based on further genetic testing, knockout tests, for example, or testing mice under various types of environmental conditions where these non-coding RNA genes can be expressed in various ways is functional. That's our future prediction. And I think
yes, of course. And my answer to that would be ENCODE has already been busted by this 2017 paper. And I think there was another one in 2016, maybe, but I picked the most recent one because that good practice, I suppose.
Do you know how many, I think this is an important question before you move on. Do you know how many cell types ENCODE tested?
Oh, no, I don't.
Well, here's the problem. Here's the problem. So based on what ENCODE discovered regarding the function of our DNA, I understand that they defined it as specific biochemical activity. We have more than 1,000, and I'm sure you already know this, we have more than 1,000 cell types. So I'm saying, and I'm saying this to you in the audience, and to James, the moderator, I'm saying that more function is going to be discovered in the future. Because if you're testing only 200 cell types and we have over 1,000 cell types in our genetics, I think it's just based on an evolutionary bias to say that max functionality of our genome is 20 or 25%. And I know that the reason why he concluded that in the paper is based on mutation accumulation. Because if it's any more than that, mutation accumulation makes ape to man evolution impossible. That's a fact.
The problem though, is that I don't know, excuse me, I'm not sure for certain where you're getting your mutation rates from. I have a hunch that it's GeneSyn's rates, or at least Kimura, the people that GeneSyn sort of pulled from. And if I'm correct on that, which I don't know that I am.
Are you saying the 100? Are you saying the 100 new mutations per person per generation? I mean, you could find that all over the place.
Whichever mitochondrial rate, mutation rate, and nuclear mutation rate that he uses to make the case in replacing Darwin. Am I correct on that or no?
No, well, right now, I mean, if you want to get into replacing Darwin and the created heterozygosity hypothesis and mitochondrial DNA mutation rates and stuff, I mean, that's a totally different topic than
all I'm asking is it the same mutation rate that GeneSyn uses that you're using to say it over 25%, or not over 25%, but the deleterious mutation buildup would make ape to man evolution impossible?
No, that's just secular literature. I mean, the human mutation rate is generally known to be 60 to 100 new mutations per person per generation. I believe that's on trio studies.
Yeah, I was mostly just curious because there are potentially infinite problems with the way that GeneSyn did his methodology.
Right, and we can go into that, but that's a totally different topic.
That's why I was just checking. It's up to you. We can talk about genetic entropy, or we can talk about the LMN haplogroups, whatever you want to talk about. I'm good to talk about it. My closing thoughts are, I think that you got to look to the current literature, and I think that it was handily proven exclusively with math that there is a 25% cap.
We are coming. Hold on one sec. We are coming to the closing of the open discussion pretty quick here. So let's see, we had standing start, and so if you want to do one quick rebuttal, hold on one second.
Discussion wise,
it's been about 50 minutes.
Well, can we bump it to 60 minutes so we can touch on just a couple more things here, or it's up to you? I know it's getting late for Erica.
I don't have a preference. It's up to you guys. I can stay up 10 minutes later.
That 50 minutes went by fast, Erica. I think we could go at this all night.
I think what we can do is, if we want to, how about we do this? Instead of an extra 10 or 15 minutes, if we want to just Standing for Truth, we can give you another round to kind of make your points, and then we'll give Erica one more round to make her points. And each of those being just a few minutes.
That's fine.
Okay. Should we do a couple more minutes of back and forth, and then because that kind of sounds like it would be like almost like a concluding statement if we're just going to go a few minutes uninterrupted. I mean, whatever you guys think is best.
Yeah. So that's right. You had heard right. So we'll just have it be like a few minutes kind of making your points, and then we'll give
Sneaky
Erica a
James
chance to make her a few points, and then we'll wrap it up.
Okay, who wants to start then their few minutes final points?
As I just said, given that you were about to start, like, you can now start, and then...
Okay. So I think... since what we were kind of heading into there is genetic entropy, you can answer the question as to, what type of selection is going to be able to filter out all the bad mutations, because the major issue is the fact that selection, it can amplify the best beneficial mutations and it can get rid of the worst detrimental mutations, but it's pretty well powerless to the nearly neutral mutations. Those are invisible to natural selection. I mean, you could think of it this way, Erica. I mean, we've got a genome of 3 billion letters. 3 billion are passed on from mom, 3 billion passed on from dad. But if you take out one letter, say change one letter randomly, are you going to have a huge fitness effect? No, it's going to have a tiny fitness effect. It's kind of like rust on a car. You can't see each rust event, but it's continuous and destructive. Or like a single spelling mistake in a book the size of an encyclopedia, right? Make one single spelling mistake. It's not going to have a huge overall effect, but the accumulation of them over time, yeah, that's going to destroy the message and the book. But why can't natural selection filter out all the bad mutations, Erica? There's two reasons here that you'll have to address. There are too many bad mutations continuously pouring into the population, and most bad mutations are too subtle, as I talked about earlier, to be selectively removed. And we see genetic entropy in real time. Alzheimer's disease, dementia, autism clearly has a genetic component to it. Asthma, autoimmune diseases, cancers, 1 in 3 now? Immunological disorders, diseases. I mean, there is a pandemic. It's pretty well entropic degeneration on all levels. And the 100 mutations per person per generation is a fact. And, you're going to have to address how that accumulation of mutations is going to be rid of in our genetics, because, I mean, that's what we see. We see genes are going down and not up. And if fish to fisherman is true, I mean, you're going to have to explain the major problem, which is a net gain versus a net loss of information. So, I mean, if you want to kind of address those points and give me your thoughts on genetic entropy and what your best argument is against genetic entropy, I guess that would be a good way to proceed.
Okay. So genetic entropy does not happen. The ecological term, again, is error catastrophe. And the reason why it doesn't happen, even though ecologists who have no affiliation with creation, evolution, anything along those lines, have tried to induce error catastrophe and have failed time and time again. They've done it with E. coli, they've done it with phages. It doesn't work. And the reason they do it with those is because they accumulate mutations way faster than sort of macroscopic life. So they can see if deleterious mutations are going to build up in a rather short amount of time. And here's the reason why they don't. Near neutral mutations, If they're near neutral and sort of beneficial, then they're going to be slightly selected for. Selection isn't an all or nothing thing, right? Let's say you have a near neutral mutation that is sort of a negative, right? It might not kill you, but it might decrease your fitness, because if it is a negative trait, right? If it is a bad mutation, by definition, it's decreasing your fitness. So you're going to reproduce less than your peers, and whatever offspring that you do manage to produce will reproduce less than their peers, and they will continue to pass on that sort of slightly bad mutation until eventually it is eradicated from the population by one reason or another. It might simply be missed reproductive opportunity. So if it is even remotely bad, selection acts against it. That's just how it is. If it's neutral, and when I say neutral, I mean truly neutral, they can accumulate all they want. Nothing's going to happen. There's nothing to select against. That's the definition of something that is neutral. There is no good or bad kind of impact to it. Now, what you might have in sort of your best case scenario is if an entire group of organisms all get bad mutations at the same time. And as they build up upon one another, they sort of have I think it's epistatic, sort of an impact on where they build up, and it makes them subsequently worse when they combine with one another. But the problem with that is the definition of genetic entropy and of error catastrophe means that it has to accumulate across generations. Regardless of whether it's epistatic or not, the negative mutation will hit the second, and negative selection against sort of this trait will happen the second fitness is reduced. One way or another, that's happening in one generation. So there is no plausible way to suggest that error catastrophe or genetic entropy can occur, because it is the accumulation of bad mutations across generations that eventually harm fitness. We don't see that. Ecologists have tried. Understanding error catastrophe, because cancers and things like that aren't error catastrophe. They're similar in ways, but again, it's not cross-generational. So understanding it would be quite helpful for fighting those diseases, but they can't do it because it's not a phenomenon that occurs. Sanford, I believe, claims it happened with H1N1, but I read that paper. Not only is it a bad paper that actually makes several mistakes, but it swaps its definition of error catastrophe around whenever convenient. So essentially, my answer to your question is, there is no such thing as genetic entropy. We don't see it naturally. We don't see it in a lab, even though we've tried. At least the definition that creationists give. So it's not a problem because it's not real.
Gotcha.
That's all I got to say about it.
Thank you very much. And standing for truth, I know that you have another round in the barrel, but just for the sake of
too well, James.
We can always do the tiebreaker debate. We can do an end game debate. We should call them that from now on.
That's a good idea.
The trilogy end debate where we have the final of 3. So we definitely can do that, but I do just want to make sure that Erica gets to sleep on a decent, hopefully at a decent time.
You're
so
sweet, James.
It's
I will
no
say
problem.
That conversation flew by. It was a lot of fun.
It's
I
also,
had a good time.
It's also because I'm tired. Now, next up, Steven Steen, thanks for your super chat. He says, standing for truth cannot be stopped. He's a beast. SpongeBob. You have a fan out there.
That is far too sweet of Steven to say. I obviously paid him to say that before the debate. If you could read a couple more super chats, I'm running upstairs for literally 30 seconds, James.
Deal. Steven Steen, that sicko, also says, James is the new Adam sent from God to fix us soy boys' flawed genes and restart the human race without flaw or weak jaws.
Listen, James, I have heard you are an alpha Chad. I've heard that from other people.
That's hilarious. An alpha Chad. I had never heard that before, but I like that. We'll call Steven Alpha Chad from now on. Let's see. Bent Hovend. No relation, it says in the name. Says Erica and Dapper Dino should debate standing for truth and Kent Hovend at the same time.
I'd be down for that.
That would be epic.
Be fun. Could be fun.
We actually, I forgot to mention. So we do actually, it's coming up quick. We do have, as you see in the bottom right, Kent Hovend will be returning. We got off on the wrong foot one day, and I will take responsibility for it. And long story short, for a while, it looks like we weren't going to have Kent Hovind on anymore. But Mark Drisdale convinced him. So you see Mark in the picture there. He, on the left side, he looks kind of like an action hero star, the bald head and the goatee. He has convinced Hovind to come back on, so that will be a good one. But
you don't want to get on Kent's bad side. He'll ban you from Dinosaur Adventureland.
That's true. So it's also Genesis and cosmology. A discussion will be going on this coming Monday with Skydive Phil, popular YouTuber, really pleasant guy, and also Dr. Jeff Zwierink. So that's going to be a really fun one. That's one that we've had planned on 2 different dates because I don't know what was wrong with me. It's the first time I had ever wondered, like, oh my gosh, really wondered. Is there something wrong with me? Like, because I really thought, so they contacted me, they called me, they're like, James, it's not today. And I was like, oh no, you're right. So long story short, glad you're back standing for truth. I could hear
You've only wondered that once. I wonder that every day.
Yes.
About myself.
Well, thank you. I appreciate that. And standing for truth, I think I could hear you cackling in the back. You must be back.
I'm back, my friend.
Gotcha. Thanks so much. So
wanted to make myself known.
You betcha. Let's see. Michael Dresden with his normal trollish super chat says, I'll save you all the time. Evolution is a myth. You can respond to that, Erica, or you can not dignify it and ignore it.
I'll respond. You're wrong.
Gotcha.
Yeah.
It's short and pithy. I like it. Speed of sound of gravity. Who says, by the way, he said that he or she said, standing for truth, you are afraid to debate them. So they said, standing for truth, buck, buck, buguck.
Buck, bagok. Like, you know.
Okay,
yeah,
Speed
of Sound sends his regards standing. He says he wants a rematch, so.
Okay, so, and that's funny, Erica mentions that. So I've had 2 debates with Speed of Sound. So definitely over 2 hours, maybe 2.5 hours of dialogue. We debated the same topic that Eric and I just debated, and a topic specific to chromosome 2 fusion. So I recommend anybody go look at those debates. I suspect he only wants another debate because of something called damage control. He knows he lost, but you know what, Mike? Maybe one day. I'm going after the big dogs now, though.
Gotcha. Very sassy.
That's what they call me.
That's right. Jay Shy, thanks for your super chat, said, what if there were people outside the garden whom evolved, then mated with Adam's descendants, still making Adam and Eve our genealogical ancestor? Cain hints to other people who might kill him. So, standing for truth.
Right. Well, I would say that we don't even need to go that far because the Bible tells us we came from just 2 people, Adam and Eve, of course. And if you just look at my opening, I went over the fact that we've got these pieces of DNA, for example, the Y chromosome DNA, the Y chromosome we only get from our fathers. And it's passed on, unbroken from father to son. And every once in a while, a mistake happens. And every time this happens, a new branch in the family tree is formed. So all we have to do is look at all the branches in the world, James. They go back to a single person, not to a chimpanzee. Okay, and that's what this debate was, limited ancestry versus universal common ancestry, but to a man who lived just a few thousand years ago. And the same thing goes with mitochondrial Eve. So we can just believe the Bible. And when we start with the Bible as it's just plainly understood, we can make accurate predictions and retrodictions.
Gotcha. Thank you very much.
James, if I can make a recommendation for some reading for that individual, they should check out John Walton's series because he actually subscribes precisely to that, what the question asker was talking about, sort of like a theistic evolution type thing. I've read some of his work. He's an academic. He seriously knows what he's talking about. I'd give it a look. It's pretty interesting stuff.
Gotcha. Thanks so much. And next up, Stupid Whore Energy, as she likes to call herself. Very sick. She says,
I haven't heard from her in a while.
That's right. She says, new genes can arise from non-coding sequences. That's why orphans are not a problem.
Right. So it's just as I iterated earlier. It's called de novo gene synthesis. And I don't want to beat a dead horse, but just go back and watch the discussion. It is a circular-based argument. It's never been observed that these non-functional, non-coding DNA regions are suddenly co-opted to have an important functional role. But orphan genes in general, they are taxonomically restricted. They are functional, and they do suggest, along with many other lines of evidence, that limited ancestry is true, because there's so many lines of evidence that the evolutionists have a major problem explaining, other than weak rescue devices, in my opinion.
Gotcha. Very sassy. Go ahead.
As a question sort of for standing, what do you make of all the astrological phenomena that we draw ties to despite never having actually laid eyes on them in person, like black hole physics or supernova or novae, I guess, neutron stars, things like that? We just get data, we just get readings, and we formulate entire hypotheses about them that then are confirmed by other data that we receive. So you don't have to be a direct observer of something to know that it happened. You can see the aftermath and get the same idea. That's where a lot of science goes. Anyways, that's just an anecdote.
I agree. I mean, you can have all types of hypotheses, but those hypotheses have to have supporting evidence. The evidence has to be demonstrable. It has to be empirical. So some of the things you just mentioned are demonstrable, and the inferences that are made are based on really tight scientific-based evidence. But when it comes to like the Y chromosome dissimilarity between chimps and humans, or
we didn't get to talk about that, and I researched that this time, and I was ready for that. We didn't get to talk about it. Dang, well, remember, we didn't get to talk about a lot of stuff.
Well, remember, round 3, Endgame, Avengers style.
Listen, eventually I want an Age of the Earth conversation, okay? Or we can talk about anthropology again. I don't like being out of my element.
I enjoyed the human evolution debate, and now we did one on this topic. So yeah, maybe the next one can be Age of the Earth related, or looking forward to it, put it that way.
Very juicy. Mike Billers, thanks for your super chat. They asked, can Standing for Truth re-explain Erica's explanation for orphan genes and maybe stop using it in the future since it's explained?
Well, I know the answer to orphan genes that is given, because it is a major problem to evolutionist theory, is de novo gene synthesis. I can't remember if that's the argument that Erica used. She I guess looked to endogenous retroviruses, for example, and the functions that are now been found in these so-called ancient viral elements have been co-opted. It just comes down to the fact that, are these anything more than just stories, rescue devices? So I understand the arguments put forth by the evolutionists. I just don't see them as being very convincing.
Gotcha. Thanks very much. Moving quickly, Josiah Hansen, thanks for your super chat, asked, Erica, protect your hand when giving such a spanking. Very nice. Gotcha. Excellent. Let's see. Next up, thanks for your super chat from Florida Man Edo Hypnotoad Evangelist. Appreciate it.
Blessings on you.
Gotcha.
Priest.
Thank you very much. Let's see. They're asking, give me 1 second. They asked, why can't creation answer the phylogeny challenge?
I'm guessing that question's for me. Yep. I would say that the phylogeny challenge is fallacious, because it all comes down to, where can we draw the line regarding ancestry? Where can we where does that phylogeny break down? But the thing is, that entire argument misunderstands biology and genetics, because and theology, because they seem to imagine that God created humans and then all of other biological life, and that there's absolutely no similarity between humans and any other species out there. So based on the biblical model, there's really no reason for us to believe that that's true, as in, there should be no type of hierarchy in the biological world. As in, there's no reason to believe that we shouldn't be more similar to, say, apes than to another species, say a whale, right? So we too predict nested hierarchies in biology, whether it's on an anatomical level, physiological, morphological nested hierarchies. So that's why I always say we need to look to differentiating kinds of evidence to show which explanation, limited ancestry or universal ancestry, is true. And that's where we can get into function. We can get into Y chromosome, mitochondrial DNA predictions. This is how we're going to truly answer the question of ancestry. So long story short, the phylogeny challenge it's fallacious and it's based on a misunderstanding of science and theology.
Hey James, can I answer this one too? But just from my side.
You bet.
I think the best question that the question that I have for creationists on this one, of course, it has to do with primates because I love primates and I am a primate. But frequently creationists lump all the apes into an ape kind. And my question kind of runs along those lines because frequently a kind is described as things that bring forth, organisms that can bring forth with one another. But chimpanzees obviously can't reproduce with gorillas or orangs, or, well, they can with bonobos, but they're actually very recent divergence. And there's been slightly disturbing, but a bit of sort of theoretical research looking into how reproductively compatible humans would be with chimpanzees. And it's more than it is with gorillas, and it's not actually been considered to be impossible, as terrible as that sounds. It's simply a ring around the egg, the zona pellucida, that sort of gate checks any spermatozoans or sperm in general that try to come in. So reproductive isolation is kind of a bad way of drawing the line, which is why I always ask why and how we draw it. And that's why I don't think they can answer the challenge, because there is no way to draw a line. Genetics is a gradient and it runs through all living things. And that's why paternity tests work. And that's why, genomic comparisons work.
Well, if I could make just one quick point.
Really
if you just
quick.
think about it, Erica, okay, according to our model, I'm just going to throw some, kinds out there, say humans, pigs, rats, ducks, and dogs. They're all land dwelling, okay? Even though they are separate kinds according to our model, since they are all land dwelling and share many similarities with each other, they can share similar nested hierarchies or designs. So where are we going to draw the line between those separate kinds if they already share certain levels of nested hierarchies, morphologically speaking, genetically speaking, physiologically, speaking? So that's the thing.
But that's a fancy way of saying you can't draw the line. That's a fancy way of obfuscating that the line can't be drawn. And if your model is correct, then the line should be able to be drawn, because it is, of all the things in Genesis that are like Genesis 1 that are like super clear, there's quite a bit of emphasis on the kinds. It's repeated over and over and over again. You would think it would be quite obvious.
Well, even though we predict nested hierarchies, evolutionists, when they say that there's this perfect nested hierarchy, there's this perfect phylogenetic tree of life, that's not actually true, because anytime there's an inconsistency, Erica, and say a lack of uniqueness in that phylogenetic tree, as you know, it's usually explained away by what? Convergent evolution. So that's a rescue device. There's also something called independent lineage sorting. If you look at different genes in, say, humans or apes or gorillas or orangutans, depending on the gene you're looking, can create a totally different type of phylogenetic tree. So even though you're implying that there's this perfect nested hierarchy of life, that's not true. There's many, many types of inconsistencies I can point to.
Gotcha.
Yeah, but the thing is the inconsistencies are, while present, they're present in every branch of science, from medicine to astronomy to, of course, evolutionary biology. That's the nature of the beast. The question is, how strong and how parsimonious are the lineages that we do have these straight through lines? And the answer is incredibly. I know primates the best. It's undeniable from my position. But that's just me.
We have to standing for truth. I'm sorry, but just to get through more questions, we have to jump through.
That could have been debate number 3.
Yes. Dapper Dino, thanks for your question. Asking to both, are you familiar with the observed de novo emergence in Drosophila or Saccharomyces.
Yeah, so the fruit flies,
yeah.
for example, read that paper.
That's a
For
good
one,
example.
it's done in the lab. It's also inferred. And what they've done in the lab is they've forced these orphan genes out of the genetics of these fruit flies. So he's trying to say that this is an example of de novo gene synthesis, when all it is an example of a loss of orphan genes, which can happen, obviously. So I want to see an example in real time, not in the lab, of de novo gene synthesis, and not just an example of an orphan gene being lost. I mean, that's just
how would you even do that, though? How would you see the emergence of a de novo orphan gene not in the lab? Like, you're not gonna, like, I don't know, maybe you follow like a colony of Drosophila around with a net, and you catch them every couple minutes, and then you do some genomic sequencing to find out. I mean, I don't know how you would even go about doing that. It's an impossible experiment.
So are you admitting that it's never been seen?
No, it has in the lab, but you would just ask for it outside of the lab, so you can't do it outside.
It hasn't been seen in the lab. I just told you that all that was seen was the loss of orphan genes. That's not the gain of orphan genes, Erica.
Hold on, hold that thought. I'm not sure. Let me pull up this paper. James, pull up the next question, if you would, please.
Yes. Next up, thanks for your super chat, Pax Americana, asking, standing for truth. Even early church fathers, such as St. Augustine, knew that Genesis wasn't a literal account of creation. YEC isn't even theologically sound.
Yeah, technically, if you look at what the plain reading of the Bible is, if you look at church fathers, quote unquote, throughout history, the majority of them did believe that the geology of the earth was explained by Noah's flood. Ponds come to people evolution was not heard of. But the most important thing is we can just look at a plain reading of scripture, and we can see that God created Adam and Eve, and we can also make predictions and retrodictions. And the science tells us we come from a Y chromosome Adam, a mitochondrial Eve. The human species overall has low genetic diversity, which points directly to Adam and Eve. That's why the evolutionists had to resort to the out of Africa population bottleneck theory. I mean, Erica and I discussed that thoroughly in our previous debate, but a plain reading of Genesis clearly is consistent with empirical scientific data. So
look into the Toba catastrophe, if you would, Standing. That's one of the primary explanations for the bottleneck that there's quite a bit of evidence for.
Right, and I did, and it looks like there's no major consensus on whether or not this Toba volcanic eruption is resulted in the population bottlenecks. There's, I believe, some sides in science that believe there's some inconsistencies with that theory, while others hold to it. So, I mean, that just might be a discussion for another debate.
Yeah, I think that it's best explained with a combination of that and founder effect from populations leaving Africa. But that's just me.
Just to move through as fast as possible, Jay Shy, thanks for your super chat. They said, Francis Collins, a Christian, mapped out the human genome and is convinced of universal common descent. Why didn't this lead him to your conclusion? I think that he's asking Standing for Truth that.
So he looked at, actually, can you repeat that real quick?
They said, Francis Collins, a Christian, mapped out the human genome and is convinced of universal common descent. Why didn't this lead him to your conclusion, Standing for Truth?
Good question. So Francis Collins, I definitely recommend his book, The Language of God. The major arguments he looks to, for example, you'll see him speak of ancient repetitive elements, the non-functionality of our genome, shared genetic mistakes, for example. But he's had to actually go back on a lot of that because he's one of the scientists who has admitted that ENCODE has revealed that much more of the genome is functional, that the genome has many more functional DNA elements than previously thought. And even Richard Dawkins has had to go back on that. I mean, he's the one who quoted, and I don't have it right in front of me, that over 90% of our genome may as well not even be there, implying that most of it is useless. Yeah, Richard Dawkins, just go knock out that 90% of the genome. So it's just based on an evolutionary bias. But yeah, Francis Collins, I'd recommend reading his book and all his best evidence for universal common ancestry. has been completely overturned, just like the junk DNA paradigm has been overturned.
Gotcha.
No, that 2017 paper disagrees with you, though, Standing. That one doesn't quite agree that 90% couldn't be knocked out if we're dealing with the 10 to 12 range, which is pretty typical. I'm sending you a paper, Standing. I think this is the one that was being discussed. Go ahead, James. Sorry.
Gotcha. And then let's see. Kevin Tremblay, our friendly moderator, if you can do me a favor, and we usually only time people out or delete their messages if they are using hate speech. So even if they're abusive, like, please ask them like why they're being abusive towards somebody. But in other words, like, try to discourage them. But we usually try to only delete or ban people if they're engaging in hate speech. Next up, Mr. Archaeopteryx, standing for truth, an amoeba genome is 100 times bigger than a human's. Does an amoeba need 100 times more information, or is most of it non-functional?
Well, amoebas, looking at an amoeba genome, is a lot more different than, say, testing the genetics of mammals, humans specifically, which is where we're making the direct predictions. But organisms like amoebas, yeah, they are subject to whole genome duplications. Also redundancy, and in a lot of these organisms that do have 2 or 3 or 4 times the amount of genetic content than, say, a human, may just need more redundancy for environmental conditions. So, epigenetics, environment all play a factor in our assessment of the genomes of all forms of life. So, yeah, amoebas, they are subject to whole genome duplication. So some of it could certainly be non-functional.
Hey,
Gotcha.
James,
Yep.
real fast. For those of you who also want the paper that I just sent, Standing, it covers the orphan genes quite well. There's some excellent sources within it covering orphan gene emergence, which I believe, I didn't get a chance to read the entire thing, but it's sort of alluding to the fact that this has been observed in the lab. Not positive. Yeah. Don't quote me on that. Side note, I also had the chance to briefly look, hold on, pause. I'm pulling it up, look at my email, and I had a message from Call Me Emo, who brings up an excellent point that I wanted to post to Standing very briefly. I think it's if that's okay with you, James. It's very short.
Yes.
Emo, yes, I've seen his argument, and we've rebutted.
Well, hold on, I'll ask you the question because it's quite short. He brings up an excellent point that I didn't even think of, but
so am I debating Emo now too?
Well, I saw what I was saying.
Let me just Google some arguments against what you said. Okay, go ahead. Yeah, what's the
listen, I just think it's a good point. It's not my point, so that's by far no. But I did think it was quite good. He brings up the fact that orphan genes, if even within kinds, vary wildly from species to species, which would support de novo origin far more than sort of a taxonomically restrained, limited ancestry.
Well, he assumes that those orphan genes are found within kind. So, for example, you can find orphan genes that are taxonomically restricted to humans, gorillas, and chimps. But he's assuming that gorillas and chimps are of the same created kind. That might just indicate that they are 3 separate created kinds. And the paper that you posted on the fruit flies, for example, we have an article in our book, Raw Matt and myself, debunking that. What they did technically was they forced adult males to reproduce with infant females to get rid of their orphan genes. So it's unrealistic in nature and therefore irrelevant to the entire argument. Because like I said earlier,
I hate to say it, but if you think that that's unrealistic in nature, I've got some bad news for you. There is a lot of weird sort of sexual crossings across adult juveniles in various instars with arthropods. Arthropods are extra weird. But yeah, it kind of busts up the point that you made previously, though, that because they're taxonomically restrained, they are the ones that dictate what a kind is or isn't. And that
I'm saying it's a line of evidence that can dictate what's created and what's not. And that can actually dictate to us that humans, chimpanzees, and gorillas are all of separate created kinds. But the thing is, orphan genes are very specific. For example, we have noticed that all taxonomic restrictive orphan genes in, say, felines or the dog family correlate perfectly with what I'm saying. So right here, we've identified a feline kind, a dog kind, a human kind, a chimp kind, and a gorilla kind. I mean,
but that's that you want to talk about unrealistic. You're going to tell me that chimps, gorillas, and orangutans are separate kinds, but that every felid and every dog is within the same kind? That's wild, dude. That is like out of this world. The orangs and gorillas, really gorillas and chimps, diverged incredibly recently, even in evolutionary times.
Hold on one sec. We do standing for truth. It's got to be really short and pithy here. Standing for truth.
Yeah, you can finish up standing. Sorry, I keep inciting things, James. I apologize.
I like interaction during the Q&A. It's fun. It's fun.
Okay, gotcha. Thanks so much. Next up, appreciate your question. Speed of sound of gravity asks, standing for truth, what H3K4ME1 in Tompkins graphs indicate?
Histone methylation signatures. It's indicative of active gene promoters in transcription. He's trying to stump me, but I would recommend going to watch my debate. He's really good in genetics, so I've enjoyed my debates with him, but I got to be honest, he didn't do quite well against me on chromosome 2. We discussed it for an hour. It was a good debate. He's even admitted in one of his hangouts with some evolutionists that he was blindsided by some of my arguments. So, kudos for him to trying to stump me there, but sorry, speed of sound, you failed, man. Big time.
Next up, appreciate your feistiness. Appreciate your question from Terry James, who says, if creationism, quote unquote, predicted nested hierarchies, would disproving nested hierarchies falsify creationism, or would you take this as evidence against evolution?
Well, like I said, there are inconsistencies with the phylogenetic tree of life. That's why they need to look to convergent evolution. For example, I mean, you can see evolutionists invoking convergent evolution, which shows that this so-called phylogenetic tree of life is not as, it doesn't flow as well as they say it does. Because you can even look at an example that at the top of my head, let's say whales, dolphins, and bats, for example, okay? They're the only mammals that have echolocation systems. And maybe Eric has an answer to this, I'm not sure. But on the basis of gross anatomy, the whales and dolphins, okay, they're classified closer to the cow and other ruminants than to the bats. But on the basis of their echolocation systems, they should belong with the bats. Now, it gets even worse for them because molecular analysis of the protein prestin puts whales and dolphins squarely.
70% of women stated that
for anyone in the audience who doesn't know, prestin is a sound sensitive protein and it's essential for hearing in general. So it's just one of the mechanisms, hearing mechanisms of the echolocation system. So this plus other lines of evidence I can go into is strong evidence that the phylogenetic tree does not represent objective reality and should falsify universal common descent. But we do predict both models some levels of nested hierarchies. So yeah, that's my answer.
Thank you very much. Sidri Sarabia, thanks for your question. They asked, Erica, how does a random evolution process create symbiotic associations? How does nature, quote unquote, select anything to work with another being in ecosystems?
That is a fantastic question. And I think that is quite intuitive because you would think that would be somewhat of a complicated process. But symbiosis has been happening from an evolutionary standpoint from the very beginning. I mean, we have the endosymbiote theory, or hypothesis rather, which is that quite a large cell sort of phaged another smaller cell, and that's how you get the mitochondria. But the truth is that it's close, loose associations that then have such a fitness benefit for these two organisms being in close proximity to one another that it actually becomes more beneficial for them to stick together than to stay apart. We've seen this recently in certain species of primate use, for instance, vervet monkeys. They can actually rely on the predator calls of starlings. Now, that has been a recent adaptation in many locations. Now, of course, it's location specific because symbiosis does take a long time, but that fitness benefit of being able to utilize a starling call to know whether a predator is around because they have a better vantage point has popped up somewhat, in the sort of distant past, and it's actually led to some really interesting conservation methods where they teach vervet monkeys how to respond to starling calls, and they actually spend more of their time, kind of making their sleeping quarters near starling nests because of it. So that's basal symbiosis, but that's how it happens. It happens with loose associations that through time become cemented, and that's what I got to say about that.
Gotcha. Thanks so much. Appreciate it. And we do have another question from Stupid Whore Energy, who asks, she says, slightly deleterious mutations are responsible for neutral constructive evolution. I think that's for you, Standing for Truth.
Right. I'm glad she brought that up. I mean, that's exactly what I was iterating earlier in the debate. They assume these neutral mutations build up in the genome, and they're almost used as a reservoir for change in adaptation and in forward evolution. So that's based on an assumption. What we now know about the genome, and as Erica and I discussed during the debate, most random changes contradictory to the evolutionists are going to be deleterious. But even if, like I said, Erica, even if the 90% of the genome is perfectly neutral junk DNA, as Stupid Whore Energy is insinuating here, that means, and Erica didn't answer this problem, and I don't think anybody can, that means 10 harmful mutations are still arising in every person, every generation. So even the most fit individuals are still more mutant than their parents. And you can have any kind of selection all you want, and it's only going to amplify the best and get rid of the most detrimental, but we are going to degenerate.
Gotcha. Thank you very much. Just to keep moving, Mothra J Disco says, Standing for Truth, where does the simp gene come from?
The simp gene? If it's a like many genes, for example, if we look at allele frequencies, whether it's rare or common ones, they can arise, say, post-Babel, depending on their frequency in the. I'd have to know exactly what that simp gene does.
Gotcha.
I don't know. I'd have to have clarification. Do you know what that gene does, Erica?
New to me.
Again, to reiterate, genetics is not my field. I can speak with a decent amount of authority with primates and with human evolution. Genetics, that's why I had notes.
Yeah, I would say that the majority of our genome is created heterozygosity, but there are some alleles that have, there are some mutations. For example, blue eyes, that's based on a mutation, according to our model, post-Babel, post-flood. But we can determine that based on allele frequencies around the planet. So I'd have to know exactly what that does, if it's a mutation or if it's created. It's one of the two.
Gotcha. Appreciate it. Next up, appreciate your super chat from Jay Shy, who says, Standing for Truth forgets we have recombination.
Yep, recombination occurs, but recombination is no help to forward evolution. I mean, recombination and gene conversion, for example, those are a couple mechanisms that we look to in our created heterozygosity hypothesis. That's actually going to create diversity quickly, especially if the DNA differences are built in from the start. It's kind of like shuffling a deck of cards. I mean, you're going to have diversity in every single generation. That's why two people can technically have millions of children, and every single children are going to be different. No two children are going to be absolutely identical, and that's because they're heterozygous. And like I said in my opening, that would be optimal design. If you, that's all I have to say to that one.
Gotcha. Next up, thanks so much, Sigifredo Sarabia, who asks, Erica, is genome degeneration real? If no, what evidence can you give going against it? If yes, what evidence can you give that deterioration of ape DNA doesn't follow the same degeneration before evolving somehow?
So the problem with this concept of degeneration is that it depends entirely on what this individual is talking about. If this is a reference to degeneration, at least in the form of genetic entropy, the answer is selection always selects if it's not neutral. Even if it's partially bad or partially good, selection still occurs. It just might not occur as quickly. As far as, variations in how selection works and other kind of genetic concepts like mutation and things like that, mutation is not constant. It's not constant in a single species through its lineage, and it's not constant further throughout into other species lineages either. Chimps have a 30% higher mutation rate than we do, and orangs and gorillas actually have a 40 to 50% faster mutation rate than us. So accumulations of any kind of mutation are going to vary depending on the species and depending on how far back they diverged. Now, again, I'm not 100% sure what they're asking with regard to genetic degeneration, but if it has anything to do with genetic entropy, there is no way natural selection doesn't select. It's not an entity. It's just literally response stimulus with the environment. There's no, people like to say that evolutionists use natural selection as like a god, but that has nothing to, that there's no, it doesn't follow. It's a non sequitur. Natural selection is simply how an organism interacts with its environment on a genotypic and a phenotypic level, and the changes that occur based on sort of a combination of chance and fitness.
Gotcha. Tioga.
Actually, if I could say something, I promise.
No,
I promise. Less than 5 words. Less than 5
I'll give
words.
you. Okay, less than 5 words. Go.
The problem is, that's 3. Natural selection acts on phenotype and not genotype, and I'll just leave it on that.
Tioga, thanks for your question or super chat. They said, "I stan Erica, my biology queen," all in capital letters.
Oh my God, you've made it worth staying up this late. That is a lovely compliment.
Very nice. Subtracted, thanks for your super chat as well. They say, "Hey, standing for truth, if Adam and Eve didn't know they were naked, how was Adam aware that Eve came from his rib? Genesis 2:23, you need to be naked to see your ribs."
I'm going to have to think about that one. Obviously a theological based question, but how did Adam not know that Eve came from his rib? Didn't God put Adam to sleep when he took his rib, made Eve out of it? I don't know. I'd have to think about that one a bit.
Gotcha. Jay Shai, thanks for your super chat. They said X and Y Adam were separated between 30,000 years. So put that in your pipe and smoke it.
I was hoping, I figured we would get into the discussion on mitochondrial Eve and Y chromosome Adam, but based on observed mutation rates, the empirical method, trio studies, for example, we can use pedigree-based studies. Adam and Eve only lived just 6,000 years ago, but evolutionists have to counter that by using unobserved and unrealistic mutation rates. So they don't use the empirical method when it comes to mutation rates. So realistically, you can look at the studies and look at how those dates are derived, and they're really, really heavily based on evolutionary assumptions. So
gotcha. Thanks so much. Almost there. Let's see. Sigifredos Arabia, thanks for your super chat. They said, "Standing for truth, is a platypus a kind of mammal or bird?"
Or bird?
Yes.
Because of the bill, I guess.
I would say platypus defies evolution. I mean, what did the platypus evolve from? It looks to me like the platypus is of its own separately created kind. I'm not sure if there's a universal consensus as to the history and the ancestry of the platypus, but definitely not a bird kind.
Gotcha. Appreciate it. Next up, appreciate your super chat from Stupid Whore Energy. Strikes again. She says, 2 transposable elements in humans and chimps at the same genomic locus means the original insertion was in the ancestor because there are tens of thousands of possibilities for a TE to insert itself within large genomes.
Right. So these TEs, which as he iterated stands for transposable elements, but they are an important source of highly regulated, they're biochemically active. They are non-coding elements, but they are important in transcription factor binding sites and in non-coding RNAs. So they are pervasive in the genome, but they're also functional. So based on their position and location, that's predicted based on our nested hierarchical expectation based on similarities and dissimilarities. But the fact that they're functional DNA elements, just like the endogenous retroviruses, the ALUs, that's exactly what we've predicted all along.
Gotcha. Appreciate it. Next up, Stupid or Energy. Thanks for your super chat. She said neither Dawkins nor Collins have commented on encoding or encode.
Yeah, ENCODE project. Yeah.
Gotcha.
Well,
yeah,
neither
they
of them
have
are
both.
genetic.
I've got quotes from both of them that have commented on it.
You what? I didn't hear that.
I've got quotes from both Collins and Dawkins that have commented on it. Actually, you've referred to the CRISPR debates I've had many times. I've quoted Collins many times on ENCODE and junk DNA in general, and CRISPR had no objection to it. I mean, I'm not sure where.
I don't remember. I can't comment on it. I don't know.
Gotcha.
Yeah, I've got a quote from Richard Dawkins here. He had a book in 2009. What he said was, "It is a remarkable fact that the greater part of the genome might as well not be there for all the difference it makes." Then, after ENCODE, in a debate with, I believe it was Jonathan Sachs is his name, he said regarding ENCODE, he said, "I know there are some creationists who have jumped on it because they think it is awkward for Darwinism. Quite the contrary, of course. It is exactly what a Darwinist would hope for, to find usefulness in a living world." So you see that he's kind of embraced the ENCODE results. So, I mean, there's a couple quotes right there for you.
I don't know that that's embracing it. That's embracing the work that they've done and perhaps being open to the idea that there's more functionality than previously thought, which you're right, there is. But the question is how much? And I'm telling you, current literature, you gotta stick with it.
Gotcha. We appreciate it. Next up, folks, thanks so much for all of your questions. It's been a true joy. We are going to wrap up just to let Erica get some sleep as she is in London. And so let's see if I remember right. Huh?
You're more tired than I am.
Yeah, that's probably true.
I'm getting pretty tired too.
I am impressed. Go ahead. What were you saying?
A good 2-hour debate, Erica.
No, this is child's play. I stay up this late. Listen, I've been writing the same project proposal for months. I have to stay up later. I get nothing done.
Gotcha.
There's something called coffee.
Erica says you're a beta if you're tired already. So thanks so much.
That is, yeah. You're a virgin data. And what is it? Virgin beta cuck? Is that the phrase?
Very glad. Thanks so much. You're the first person that's ever said that on our channel. We appreciate that.
Oh, good. I'm really glad to hear that. That's my claim to fame.
A lot of triggered people out there right now. I appreciate that. That is good work, Erica.
I live to trigger. That's what I'm here for.
That's right. I like that. That's why we have you on.
Actually, quick question. I just caught a glance in the chat, and somebody was saying that I need to address Erica's LMN. Did you bring up? I don't think we discussed that in the
yeah. So I mean, there were. Hold on a second.
I think I brought it up, and I was like, let's maybe discuss it, but then I don't think we actually did.
We can do that for a third debate, but it wouldn't be fair for me to jump to that question because there were a lot of other questions before that question, and it technically, I don't know if it was originally put in the form of a question, but so I can't jump ahead of that one. Otherwise, it'd be kind of cheating everybody else who was in line first.
Actually, from what I recall, is during the discussion, we were deciding.
We were not going to talk about it, Standing for Truth. I appreciate it. However, we are not going to. I don't want to just ignore all the questions that came in before that. So, thank you very much. If you'd like, there's always a possibility for a third debate. And like I said, I don't want to, for all the people that asked the question before Jeremy at War, I don't want to just ignore theirs. So thanks so much, folks, for being here. It's been a true pleasure. Erica, what were you going to say? I think I didn't mean to cut you off. I was happy to cut Standing for Truth off, but.
Oh, no, I was saying that you were.
The master, James.
I said standing, go easy on James. He's exhausted.
Listen, Standing for Truth, my old arch nemesis. But by the way, do want to mention, folks, very excited. As if you didn't know already, I'd maybe mentioned it before, but in case you hadn't seen, we are pumped for the fact that not too far away, actually, we do have a sweet event that we're excited about. If you enjoy Standing for Truth for some reason, we are pumped about the fact that we are going to have none other than Standing for Truth's father. He is going to be on shortly, and that is actually none other than Kent Hovind, or Daddy, as Standing calls him. So that's you'll see that on the bottom right. That will be the end game of their trilogy of debates.
James, I could have gone my whole life without hearing that Standing refers to Kent as Daddy.
Yes, he does. So,
James, you made that up.
Okay, I maybe made that up. He doesn't really, but I might start telling people he does. So it's been fun, folks. Both of our speakers are linked in the description, though. So I want you to know, folks, if you've enjoyed listening to them, I forgot to mention this up front. If you've enjoyed and you're like, I want to hear more, well, you can. I've put their links conveniently down below in the description. They're waiting for you right now. Actually, I just noticed, Standing, seriously, this is a coincidence. I haven't put yours in there yet, but I'm putting it in there right now. So do want to let you know, folks, we do want to be open to topics. So feel free, if you happen to have any topics, please let us know, as we do want to have more topics, new formats like tag team, triple threat. Other things, like it does help us a lot if people let us know, like, hey, I like this or I don't like this. So feel free to give us that feedback. And now Standing for Truth is officially, he officially has his link down in the description. And so again, thanks. Those links of both Erica and Standing are down in the description if you've enjoyed and want to hear more of them. And thanks for being here, everybody. Thanks so much for your questions. And most of all, we really appreciate Standing for Truth and Erica being here, staying up late and debating for us. We appreciate you guys being here.
Always a pleasure, James.
Always a blast, James. You know that. I'm looking forward to the next debate.
Always a true joy. So with that, keep sifting out the reasonable from the unreasonable, everybody. We hope you take care. Ladies and gentlemen, thrilled to have you here for another epic debate, as this is going to be a lot of fun, folks. We have two very experienced debaters. They've been here many a times, and this is their third debate, the endgame debate, the best two of three. It's going to be a lot of fun, folks, so we are really excited about that, and want to let you know, if it's your first time here, consider hitting that subscribe button, as we have a lot more debates coming up. So, for example, you'll see at the bottom right of your screen, this Friday, Jonathan Sheffield and Matt Dillahunty will debate whether or not the Gospels were actually authored by Jesus' own disciples. So that should be a lot of fun this Friday night. We hope to see you there, folks. And also want to let you know, though, for our guests today, I've put both of their links in the description. So that way, if you're listening and you're like, I like that, you can hear plenty more by clicking on those links in that description box below. Also, what we're going to do is have a kind of a formal but mostly informal type of format tonight. It's mixed, where it'll start with 7-minute openings, followed by open discussion for about 50 minutes, and then Q&A. Of course, that would be right after the 3-minute closings that each of them will have. For the Q&A, if you have a question, feel free to fire it into the old live chat. And if you tag me with @ModernDayDebate, it makes it easier for me to make sure I get every question in the list. Also, Super Chat is an option, in which case you would not only have the option of asking a question during the Q&A, but also making a comment toward one of the speakers. Perhaps you want to make fun of Standing for Truth's appearance, if you've ever seen him in real life. Anything you want, folks. So we do ask, though, for real. Okay, I can tease him, but it's okay. But we do ask that you can lightly tease him. That's all right. But you be your friendly, regular selves. So with that, want to let you know, we are going to jump right into this. So thank you both very much for being here. It's honestly a pleasure to have both of you here. Thank you for coming back to spend time with us.
It's always a pleasure to be here, James. You know that. I love our formal, informal discussions over here on Modern Day Debate TM.
You got it.
I concur with that, James. It's always a blast. So thanks for giving me the opportunity today, as usual, to discuss this topic with Erica. Erica, thanks for doing it.
Hey, same at you, Standing. You know I love our chats.
Absolutely. So with that, we'll kick it over to Erica. Thanks so much. The floor is all yours, Erica.
All right, let me share my screen. This is always kind of an ordeal, huh? All right, let's see. Okay, can you guys see my screen?
Not yet. Give me 1 second. I just realized it got reset. So it'll take literally about a minute. So if you
I can see it, yes.
I just have to
Okay.
go into OBS and you'll be ready to go. Don't worry, I haven't started the timer yet. It's all right. Okay, so
You just give me the thumbs up when we're ready to go.
Will do.
James, are you, for some reason on my end, James, what you just said there, I couldn't hear anything.
Yeah, you're a little muffled.
You're like really silent.
I know why. That'll go away in a second.
Okay. Well, maybe that is because of the screen share. I don't know.
Not to worry.
Oh God, the screen share is so powerful. Takes away the voice.
This will be ready in 3, 2, 1, and they can see your screen right now.
Okay, excellent. Then I'm going to go ahead and begin. So, on the origin of species, evolution by natural selection. This is my little title card. I hope you guys like it. So, understanding our world, what does that mean? Well, it's all about parsimony. So, every relevant field supports the origin of life having occurred around 4.5 to 4.8 billion years ago, and evolution by natural selection being responsible for modern biodiversity. This is supported by morphology, paleontology, genetics, statistics, physics, geology, chemistry, and those are some of our more heavy hitters in that aspect. So I figured, my case, the case I'm making for you today is precisely that life began some 4.5 to 4.8 billion years ago, and that since that point, it's been evolving and changing. So I figured we're going to start with the abiotic stuff and maybe make some comparisons along the way. So first of all, evolution obviously requires time. A very ancient world is necessary for evolution. In fact, the theory was conceived after the Earth was discovered to be quite old. Darwin had the Principia of Geology with him on the Beagle, rather. So how do we know that our world is 4.5, 4.8 billion years old, and how solid is that science? Well, first we have to ask a question. Or rather make a comparison. So young Earth creationism requires that the Earth is 6,000 to 10,000 years old, and evolution requires lots of time. The molecular clock suggests around 4.1 billion years. So, radiometric dating, this is solid as a rock, and it's essentially rooted in a firm law of physics. So this is the radioactive decay law. Basically, when we're dating rock, we just look at a ratio. It's a simple ratio between the parent nucleus and the daughter nucleus, and depending on which one you have more of, you can get a general idea of the age of the rock because things decay consistently. They don't change in meaningful ways in nature on our planet. So a bunch of creationists back in 2005 and a little bit earlier decided that they were going to disprove radiometric dating, and they couldn't. They had to admit that a young Earth position cannot be reconciled with the scientific data without assuming that exotic solutions will be discovered in the future. No known thermodynamic process could account for the required rate of heat removal, nor is there any known way to protect organisms from radiation damage. So this is the radioactive decay law to the left, and to the right, I've got this classic. You guys have probably all seen this before. I've talked about it here before, of what would happen if we tried to compress or cram in 4.8 billion years of radioactive decay into about 6,000 years, and it would be a bad situation. According to the equation, basically at the time of Adam and Eve 6,000 years ago, the Earth would be around 70,000 degrees Celsius for every square kilometer. So you can check that. There's a little source at the bottom there. But also $257 billion depend on the fact of radiometric dating working. Here's a paper from the University of Durham. It essentially talks about how chronometers are very reliable and precise. They can tell you the depositional age, oil generation, things of this nature that require the geologic column and, of course, evolutionary theory. Both of them corroborate one another to be factual. So I very much doubt that this is usually what I point to when people, sort of point to conspiracy as something that's keeping young, YEC down, which is that that's a lot of money to be rooted in something that isn't certain. So, young Earth creationism requires a separate ancestry for the kinds of animals, and evolution requires a universal common ancestry. We can look to statistics for this one. I've also shown this here before. These are two excellent papers that basically just do statistical analyses on common ancestry versus separate ancestry. And these quotes to the right are very powerful. The first one says, quote, "We overwhelmingly rejected both species and family separate ancestry due to infinitesimally small p-values. Many of the data sets reject species separate ancestry strongly. Essentially, the odds of getting this data set and having separate ancestry be the reality is it's about the odds of picking a specific atom in the known universe, which is to say very small. And under the second one, we have that, we demonstrate rather quantitatively, as predicted by evolutionary theory, sequences of homologous proteins from different species that converge as we go further and further back in time. And at the bottom, it says it's time that researchers insisted that doubters put up testable alternatives to evolution. I have a feeling we're going to be talking about nested hierarchies today because No Standing has a response to that, and I hope we can get into that later. So young Earth creationism also requires that humans are somehow unique from the animals, including the apes. And of course, evolution requires that humans are animals and descend from an ancient hominoid. So we know that we're apes. We know that we're animals. We know this by our morphology because every category that we use, or rather the criteria that we use for various categories to cram other animals into them, we match all of the ones that land us as catarrhines, that land us as hominids, et cetera, et cetera. But we can also, of course, look to genetics. I use this slide every time because I think it's so important. When we align genomes side by side between humans and bonobos or chimpanzees, we find they're 96% similar with whole genome, or around 99 for coding base pairs. And interestingly enough, when you compare a chimp to a human and also to a gorilla, they're more closely related to us. The way that we do this is through comparative genomics, which is basically a souped up version of a paternity test. So, young Earth creationism typically requires that no transitional forms exist that bridge the gaps of major groups, whereas evolution requires lots of transitional forms, particularly bridging those major groups. I know we're probably going to be talking about this as well, as it does have to do with that nested hierarchy. But to be clear, obviously, there are transitional forms. Evolution makes a prediction. Basically, can we show a gradient from more basal ancestors to more modern ancestors through geologic time? And the answer is, of course, that we can. Oops, that's in the wrong place. Here are a couple of skulls, right? I show this one every time as well because it's also very powerful. All of these skulls are found in, generally different geologic layers, and you'll notice that they have small morphologic differences, which of course exist through geologic time, and that geologic time is backed up by the radiometric decay law, rather. And we do the classic comparison of humans and how Australopithecus africanus and afarensis are indeed very intermediate in both their knees, their parabolic palates, their inline big toes, their pelvises, their foramen magnum, et cetera, et cetera. But we can look to the tetrapods, and what do we see? We see morphologic change through geologic time. We see the emergence of pectoral muscles, the nostrils moving to the top of the head. We can see it with whales. Modern cetaceans are the only organisms that have an inner ear structure known as the involucrum, and the only terrestrial animals we find it in the fossil record are very coastal organisms that through geologic time in the same location slowly become more aquatic. They get shorter, more awkward limbs. Their nostrils move to the top of their head. And yet still, when we look at animals like Dorudon, which is, markedly a cetacean, a whale, we still see that it has a little bitty pelvis, little bitty knees, and little bitty feet. So, evolution, if it ain't broke, don't fix it. Because of the nature of natural selection, much of the genome in any given organism is non-functional and littered with the remains of ancient viruses accidentally preserved within the genotype. So life is chock full of these redundancies and mistakes. And a classic example would be the gulo gene, or our vitamin C gene, which is broken in all of the haplorines. We can talk about endogenous retroviruses, and to jump back to this slide right here, because young Earth creationism suggests that the human genome is at least close to 100% functional, whereas evolution suggests that lots of junk DNA and other elements indicative of retrofitted genomes exist. And one of those, of course, is endogenous retroviruses. I know we're going to be talking about this. These are little bitty ancient bits of DNA lodged in our genomes. Now, we know for certain that they are indeed viruses because when you transplant them, at least in their whole form, from one animal to another, you get a zoonotic effect. They become pathogenic. So these are some papers where we can talk about that later. I'm sure we will. We could talk about how we share 99% of our ERVs with chimps in the same exact location, and the mutations are all the same as well. Or we could talk about the functionality of the human genome, or indeed any animal's genome, none of which are fully functional. They've done knockout tests on mice, hitting out half of the entire genome, and still they're able to reproduce and have normal mice babies, et cetera, et cetera. This paper in 2017 puts a cap on human functionality at around 25%. Oh, look at this. I screwed up all my slides. They're all mixed up. But here's some birds here in transitional forms that are also quite neat. So to finish, this is what I've got to say. Here's some listed facts and their implications. Radiometric dating exists and confirms an ancient Earth. Statistics make separate creation very unlikely. Morphology, genetics, and paleontology confirm that humans are animals, apes, and not physiologically unique in any major way. Behavior is, of course, a different story. Most of the genome is junk, and transitional species exist and bridge gaps. Thus, young Earth creationism is entirely unsupported in at least what we've talked about specifically here, and evolutionary theory is entirely supported. So that's all I got. Yes.
And then, and I didn't want to interrupt or anything. My timer did say just over 9 minutes, so I'll put, which is fine. I always say take your time.
Oh,
I'll
I
put
wish you guys would have stopped me.
No,
Okay.
you know what? You were on a roll. We didn't want to stop you, but I'll do 9 minutes as well on my timer.
Mm.
I'm not saying I'll need all that, but I'll just.
I did lose track of time. Sorry about that. And to be fair to our dearest friend, Standing for Truth, I do have to mention really quick. And Standing is that. Let's see, that must be your PowerPoint. Okay, so
Yes.
you're already showing, but I do want to mention, just so people know, that Dearest Standing for Truth is not moving the goalposts. The subtitle for tonight's debate, but I told him, I said, Standing, that's just not going to work. Because he was like, let's do this totally long title, man. And I was like, we're just going to keep it Origin of Species. But the subtitle, admittedly, is Limited Ancestry versus Universal Ancestry. So with that, the floor is all yours, Standing for Truth.
Awesome. Thanks so much. Give me 1 second here just to make sure everything is good. I'll start my timer in 3, 2, 1. Okay, awesome. Thanks for doing this, Erica. Thanks so much for that opening. You know what? The molecular clock she talked about is the direct way to test for age. And contrary to what she said in her opening, molecular clocks go back just 6,000 years and not millions and billions of years like she insisted. She looked at dating methods, of course, and went over a number of things indicating old age. Of course, we're going to stick with that, which is direct evidence, for example, genetics. You know, that's what's inherited, sperm and egg. But briefly, I do want to touch on the dating methods that she talked about there, including isochron dating. Even that relies on at least one or more unknowable assumptions. Some of these assumptions being about initial conditions, constancy of rate, for example, and a closed system. And even isochron dating will require an assumed history. That's pretty obvious. What she said about rate project not having any explanations or evidence, that's not true either. For example, a number of lines of evidence do indicate that rapid decay has occurred in the past. For example, byproducts of radioactive decay include helium, fission tracks, and radio halos. This is observable evidence in the rocks that nuclear decay has occurred. She looked to fossils quite a bit there, but fossils cannot establish genetic relationships. Similarities in fossil organisms, for example, may not always be due to common ancestry. So I just wanted to touch on a few things there. As you can see here, Debate with Erica, Chapter 3. I enjoyed the first two, so I'm looking forward to this one. Tonight we are debating the origin of species, universal or limited ancestry, as James reiterated there. In Erica's previous debates, including the two with me, she focused heavily on genetic related evidence to demonstrate universal common ancestry, genomic comparisons, chromosome 2 fusion, for example, endogenous retroviruses, which she touched on there, pseudogenes, for example. So I'm happy to discuss any of those. I have no problem with this, as it is in our DNA where the question regarding ancestry is answered. What directly records a species' ancestry? Sperm and egg do not pass on a fossil or a bone. They do not pass on geography or a rock. They pass on genetics and traits. And so if we want to find out the history of humanity and the origin of species, this is where we must look. We can look at dogs as a basic example as to why genetics is so important in determining what is related and what is not related. Dogs of all types make it clear that morphology, anatomy, and bones in the dirt can oftentimes fail us because there is often more diversity within a species than between a species. This makes it difficult to classify animals by their physical traits alone. Therefore, the best way to determine ancestry is by looking at the genetics and that which is passed on sperm and egg. This is the only direct measurement of ancestry. And she talked about, or she showed a couple papers there based on statistics that limited ancestry can't be true, but those studies are all based on the assumption that creationists don't predict nested hierarchical patterns, and those studies have never been done based on a starting point of created heterozygosity. So that negates all those studies. Creationists and evolutionists have vastly different explanations for the origin of genetic diversity. I will only briefly touch on the created genetic diversity hypothesis, and will do so by asking, would God have created Adam and Eve with two identical versions of DNA, and Eve the same way? If this were the way God chose to do things, Adam and Eve would have created clones. God said, be fruitful and multiply, not be fruitful and clone yourselves. What makes the most sense, both scientifically and theologically, is that God created DNA differences from the start. This is the idea of created heterozygosity. Adam and Eve would have had within their DNA the genetic potential to produce every shade of skin that exists on the planet or known to man. If these studies she talked about had the assumption that both models predict nested hierarchical patterns, they wouldn't have come to the conclusions that they did. Evolutionists explain the vast majority of DNA differences as a result of mutation, and this is the way that they look at it. This one genetic difference and starting point leads to vastly different expectations and predictions on DNA function and speciation. Every single one of Erica's genetic related evidence for universal common ancestry that she pointed to in her opening here have been overturned, and I'm happy to discuss every single one of them. The lines of evidence Erica uses are evidence for this model of created heterozygosity. I'm glad she brought them up. Since both creationists and evolutionists expect nested hierarchical patterns in anatomy, physiology, and genetics, and we both expect homologous patterns, and we both expect types of creatures that can best be explained as mosaic or, in a sense, transitional, I can demonstrate that the function of DNA can differentiate between the two models. Pseudogenes are functional DNA elements and not mistakes. ERVs that she pointed to here are functional DNA elements and not the remnants of ancient viral infections. And the chromosome 2 fusion has been overturned for a number of reasons that I will discuss here with Erica. She also talked about the gulo pseudogene, which can be explained based on mutational hotspots, which is what evolutionists look to explain some of the data as well. So here are some papers. A lot of evolutionists, even Erica, will say it's just a few functional, retroviruses or retrotransposons, but we can see paper after paper, retroviral promoters in the human genome, large-scale discovery of insertion hotspots and preferential integration sites of human transposed elements, regulatory activities of transposable elements from conflicts to benefits. So intronic ALUs influence alternative splicing. I mean, you can find paper after paper after paper. So nested hierarchies, of course, are the products of design, and humans build in homologous patterns. So here are the questions I have for Erica. I want her to begin the discussion by answering these questions regarding the chromosome 2 fusion. This is extremely important. As you can see here on the slide, Kenneth Miller has said that if we do not find evidence for a chromosome 2 fusion in humans, then evolution is wrong, and we do not share a common ancestor with the chimpanzee. So if there was no chromosome 2 fusion, well, as per the title of the debate, looks like limited ancestry is what we see empirically. So therefore, the discussion must start by Erica answering these very critical questions and simply not ignoring them. These are the questions I have asked of her in our first debate, and from my recollection, I received no answer. So we know the fusion site is a functional element inside an RNA helicase long non-coding RNA gene. Erica has issues with this, but this is the least of her problems. Why is the telomeric region so degenerate and small? Where do we find the necessary disabled second centromere, the cryptic centromere? And most importantly, chimps have very distinctive and exceptionally large satellite sequences at the ends of their chromosomes. Where are these large ape-specific satellite sequences in the reputed fusion site? You have my permission, of course, to take your time answering these extremely critical questions uninterrupted when we start the discussion. Since your theory hinges on the fusion event being true, then you should obviously know how to answer these questions. Another question I'll have for Erica is, we know that ERVs, which she touched on in her opening, are in other classes of retrotransposons, accomplish many crucial functions in regulating gene expression, differentiation, development, and even cell stress responses. Does Erica have any real empirical evidence, maybe even a technical paper, that actually demonstrates a non-functional DNA element that she points to, such as an ERV, a pseudogene, an ALU, for example, going from non-functional to something critically functional in the genome? And I do not want her to simply invoke co-option with no real empirical evidence. I have just over a minute here. I'll go over a couple other questions. Human chromosomes, for example, are made up of relatively large linkage blocks. An analysis of these original text strings tells us that the genome is young. Why? Because the genome has only been partially scrambled. Crossovers and gene conversions should scramble all linkage blocks quite quickly in an evolutionary time frame. This is a big problem for evolutionary theory. How does Erica explain this? A near fully functional genome turns these nested hierarchies into design hierarchies. Therefore, Erica has to fight the evidence, as you've seen in the opening, for genome function, including the results of ENCODE, which suggests that over 80% of our genome is indeed functional. We can discuss the Grar paper that she uses in the discussion portion if she'd like. But my question would be, if less than 25% of the genome really is functional, as Erica suggests, why would the cell bother with it? Why would the cell bother with so much junk? Such an activity would be wasteful of energy and resources and would have been eliminated by natural selection long ago.
Set. Thanks so much for that, Standing for Truth. Now jump right into the open discussion. So thanks so much, and the floor is all yours.
Oh, wow. We do have a lot to discuss. I'm excited. I want to touch a bit on, before we begin, as we tend to touch on this topic. One, I would like to see a source for saying that molecular clocks don't go back further than 6,000 years.
Sure,
I would be interested to see that. I suspect it's Nathaniel Jeanson, which
we'll talk about that for sure.
I'm sure we will get into Nathaniel Jeanson. I also wanted to ask what unassumed conditions your
actually real quick, because you did bring up Nathaniel Jeanson there, why don't you explain why you believe Dr. Nathaniel Jeanson is in error regarding his regarding the mutation rates that he has derived and used to show that mitochondrial Eve goes back just 6,000 years and Y chromosome Adam actually goes back just 4,500 years to Y chromosome Noah. And I just want to point out, we can talk about the decay rates. I do believe, because of the title of the debate, it's detrimental that you do address the questions regarding the chromosomal 2 fusion.
Yes, I agree. Although a couple of things there. One, I do agree, but as for instance, Kent Hovind has always pointed out, evolution does require a lot of time. And I find that given it does quite frequently in these conversations boil down to how old the Earth is, because created heterozygosity is quite strange if you really are working with a sort of progressive creation in a 4.5 to 4.8 billion year old Earth, which is why I bring it up, because I find it to be very glaring for creationism as a whole. And that's why I would like to discuss that sort of.
If I could just add something in real quick. Evolutionists will say that time is the hero of the plot, so that's why you'll look to the dating methods, for example, and isochron dating. But to be honest with you, time is actually the enemy of the plot, because we see that genetic change is down. For example, we can see direct evidence in our molecular clocks that only take us back max 6,000 years. So before we get to that, let's discuss you're the one who brought up Dr. Nathaniel Jeanson. So what do you believe about Dr. Jenson's mutation rates, which I'm saying directly prove a young genome of 6,000 years? What do you believe he is in error on?
I think
you brought it up first.
Yeah, I think, well, I mean, if we were doing it in order, I think that normally, since it's a back and forth, it would be sort of, we address my question first and then move on. But I think I found a decent way to tie this in, because if I remember correctly from Nathaniel Jeanson's book, Replacing Darwin, one of the reasons why he invokes the mutation rate that he invokes, that is to say, a constant one, completely ignoring time dependency slowdown or the hominid slowdown hypothesis, is because, and this is almost, this is paraphrased, but this is verbatim the concept, is because he says that since evolutionists can invoke constancies, right, in the speed of light and in radiometric decay, he should be allowed to do the same thing for mutation, which of course, those three concepts are completely divorced from one another. Natural selection, or any kind of selection, doesn't work on inanimate objects that don't reproduce.
Well, do you have predictions on natural selection and how much natural selection would have to remove? Because universally, mitochondrial DNA clocks and the Y chromosome mutate fast. They mutate quickly. Evolutionists, there's no mutation rate that can be slow enough for evolution in 250,000 year ago for let's say Y or mitochondrial E, Y chromosome Adam. There's no mutation rate that's slow enough to account for that. But we just use the empirical method, and that's why Dr. Nathaniel Jeanson, in I guess as an objection to what you're saying, he has made testable predictions on the rate at which mitochondrial DNA changes in non-African people groups. groups, for example, the Khoisan peoples. Do you have a prediction as to how fast the mitochondrial DNA would mutate or change in people groups not measured yet?
Well,
Because
I'm certainly,
it's not science.
yeah, I'll be the first one to admit that I'm not a geneticist. You know, I have no idea the precise
Has anybody
number.
made a prediction from the evolutionist community on how fast mitochondrial DNA mutates in non-African people groups, for example, the Khoisan peoples? Because Dr. Nathaniel Jensen has pointed to non-African people groups and said, okay, as support for the mutation rate that I'm using, this is exactly what I predict these people groups will mutate.
Yes, I believe that there have been quite a few predictions on mitochondrial mutation rate. But the thing is that
not from the evolutionist community. No, that's wrong.
Well, I would find that surprising. I don't know if like what those papers would be off the top of my head, because it's so well understood in the community of genetics that mutation rates change.
How come Dr. Nathaniel Jensen's predictions are working so well? Because
they're not. They're working within his own framework. I mean, if we go back into his, if memory serves, and you can correct me if I'm wrong, because you're the one who's probably read the book more recently than I have, but if memory serves, he near the end of the book, he actually ends up taking several different species, not just humans, and he's trying to figure out what the predicted mutation rate using evolutionary theory would be, and what using his particular type of very, very constant mutation would be. And I think it was either 3 or 4 out of the 7 he actually got while tweaking the mutation rate to be constant, which it's not. In fact, I have a paper, it would take me a minute to pull up because it's in my history from today, but I have a paper that shows very handily that mutation rates don't just vary through time, they vary by population. Now, not very much, mind you, but that right off the bat deep sixes Jensen's idea of using a single constant mutation rate. Now, he does tweak the generation.
He's not using a single constant mutation rate. So he's looking at the mutation rates in humans, for example, and making direct predictions on human people groups. For example, non-African people groups, such as the Khoisan people.
Short and pithy, standing for truth, just so Erica can...
So non-African people groups like the Khoisan peoples, their mutation rate hasn't been measured. So he made predictions on that. If you look at various animal species.
All right, that was one point. So let's go back to Erica, since you, standing for truth, you did interrupt Erica. So I do want to...
I just don't want Erica to go on a tangent. I just want you to
I promise we'll come back to you. We'll promise we'll come back to you. We already let you... It was already generous to let you make one point while she was talking. So we'll come back to you once she finishes her point. I promise.
Take your time. I just don't want you to go on a tangent.
It's totally fine. Because I do go on tangents. I fully admit to that. I get excited with myself, and I want to take these rabbit holes down
me too.
So wherever I need.
We're both. I want to give you uninterrupted time just to go over why you believe his mutation rate in human people groups on the mitochondria is inaccurate. Go take your time, and then I'll give a rebuttal after. Go
yeah,
ahead.
So I'm just going to give you one very simple thing that I've just said, which is that he uses a constant mutation rate for humans. Human mutation rate is not constant. Like I said, it varies within populations as well as through time and as well as across species. So while I understand that Jensen used different mutation rates for different species, he uses a single uninterrupted mutation time to go back and get the numbers that he requires. And to kind of add on to that, the whole concept of the hominid slowdown hypothesis, right, which is that in both humans and in chimps and bonobos, mutations are occurring slower and slower, is mapped on the Y chromosome that we have been dying to talk about for so long. But the second part is that Nathaniel Jensen has made a prediction about the Khoisan people. We've been waiting for his definitive Khoisan paper results for quite some time now. And if I remember correctly, because my close YEC friend who I used to get coffee with had a copy of Replacing Darwin, we were talking about when those papers were going to come out when we used to get coffee 6 months ago, or rather 9 months ago. And he was like, it should be any day now. And here we are still with no paper, no results, nothing with regard to something definitive that matches his claim. And it just makes me wonder why, but to definitively answer your question, human mutation rates aren't constant. That's why Nathaniel Jensen's mitochondrial Eve and whole backwards span, movement backwards to 6,000 years for Y chromosome and mitochondrial Eve is incorrect. That's all I have to say on that.
Awesome. I appreciate that. So I'll just respond by saying once Khoisan people give us their blood and their DNA, we can test that. Of course, Dr. Nathaniel Jensen is not just going to go over and do that himself, but the prediction,
Sure.
it's a novel prediction that's in print. So, I mean,
Yes.
people that say, just real quick, people that say that creationists don't make future testable predictions that future observations can confirm, whether they're true or not, is just false. And remember, the mutation rate is constant, yes. The only thing that is different is generational times between different animals. That's why Dr. Jensen says you can point to, say, a fox, and I will predict how quickly their DNA changes. And that's something that evolutionists are not doing. When it comes to mitochondrial Eve, for example, the papers that he has looked at, for example, the mutation rate used in, I believe it's the Parsons paper, was actually so good that it was adopted by the FBI. You might even be aware of this. And then many of the subsequent papers that he puts in his endnotes of replacing Darwin, following the Parsons paper, right? There hasn't just been one paper, for example, have actually confirmed, they corroborate that mitochondrial Eve lived just thousands of years ago. And this even accounts for heteroplasmy, I'm sure you know what that is, and somatic mutations that people like Evograd like to complain about. So many studies have looked at the D-loop region, that's highly conserved, of course, in the mitochondrial DNA, and those are 100% germline mutations, given, of course, that they are multi-generational pedigrees. Trio studies are the best way to determine a mutation rate. Now, I don't want to bore the audience here, but they can look this up themselves, and these studies actually line up perfectly with other studies of mitochondrial DNA. So there are mutations in this compartment of DNA, of course, that are heteroplasmic. You've probably heard of this. They'll drift to fixation, but regardless, all the dates themselves are in agreement. So unless you add in evolutionary phylogenetic assumptions or archaeology-related assumptions, all the papers corroborate on one. And then take all this taken into consideration, he has actually made testable predictions about non-African people groups, which evolutionists aren't making. That hasn't been. So you can say natural selection.
This is a lot of points.
Solves this problem. But without any testable predictions, Erica, it's just not science. So go ahead.
But the thing is that what you just said there was, you made several points, but in the middle, I noticed that you said the mutation rate is constant. I can't stress this enough. It's just not. It's not in populations. It's not across species.
So what's your testable prediction?
I'm not going to make a testable prediction.
Nathaniel Jensen has, so he's doing.
That's great. He's entitled to make that testable prediction. In fact, I very much commend him for making it. That's very gutsy of him to put that out there, knowing that mutation rates do vary. Now I want to make a prediction of my own here. You mentioned that a lot of his mitochondrial DNA, I imagine they were more secular papers, have been corroborated by other studies. One, I would be interested to see those studies, because my prediction is whatever studies they have to do with mutation rates that are occurring right now. The whole crux of the issue is Nathaniel Jensen gets his number of 6,000 years by taking a current mutation rate and tracking it backwards. Now, that's not how mutation works. Like I said, we see it, differences in mutation in population, species, and through time.
Of course.
So the problem with that becomes, can he provide any kind of reasoning for why he thinks that the mutation rate in humans should be constant without invoking the old, well, evolutionists do it for the speed of light, evolutionists do it for radiometric decay, which are, of course, as I know you would agree, are very different from biology. So that's my whole problem with him. I noticed that.
But he does account for those, because
he has one mutation rate. He uses one mutation rate to get that 6,000 years. The mitochondrial DNA human mutation rate is what he tracks backwards to get 6,000 years for mitochondrial Eve. And interestingly enough, as I know you've seen from Evograd's blog, which I do recommend that everyone check out, he goes very in depth into replacing Darwin. When Jensen's methodology was applied to chimpanzees and bonobos, the prediction that he was supposed to get using a constant mutation rate for chimps and bonobos and what their differences would be was completely off base, which proves my point. They are subject to the same hominid slowdown hypothesis that humans are subject to. So using that constant mutation rate on a species that, at least to our current knowledge and with regard to the sex chromosomes in particular, is mutating faster, you run into problems. Constancy is very much out the window when it comes to genetics, is something that I've learned, at least in the past 2 weeks of spending a lot of my time reading up on it. But again, I'm not a geneticist.
No, that's okay. That's okay. That's why the mutation rates that he's using in non-African people groups are leading to testable predictions. It's now revealing genetic signatures in the mitochondrial DNA as well as the Y chromosome, once we get into that, regarding the history of civilization, which evolutionists wouldn't even expect to be there. But that's why he's looked at African diversity, for example. So there's all types of rates, there's all types of considerations that he needs to consider. Even in the Khoisan peoples, for example, in the African people groups, there's more genetic diversity. So he looks to not just explanations from the UN data, on, as you know about, on when people marry, but also goes into different rates of gene conversion, different rates of chromosomal recombination, different historic population sizes. These are all factors that are considered in these predictions. It just so happens to turn out that the mutation rate derived in all these papers and using the empirical method does take mitochondrial Eve back to 6,000 years. And he can consider somatic mutations, heteroplasmy. He looks at the D loop, for example, which
yes,
germline, and it goes back 6,000 years. And he's making testable predictions, which you have admitted, based on your assumption of evolutionary deep time, that these predictions have not been made. So the creationists are the ones doing the science, and the evolutionists are the ones that are just coming up with rescue devices. Is the problem.
Well, so to be clear, though, so again, you've listed a ton of different things that Jeanson has taken into consideration, all of these varying factors that he's going down his list and checking off and saying, all right, we're including this in our empiricism, except for the fact, the enormous glaring hole in the entire thing, which is that he uses a constant mutation rate for humans. That's the problem. You can include 100 million different factors, but if one of the biggies is incorrect and is incorrect on its head, then the data's out the window. It's just not viable at all. So it's great, that he has reasons for or that he uses triads rather than dyads, and he makes sure he's using his germline mutations and looking at the D loop of a single paper, mind you. But again, I cannot stress this enough, and you haven't provided anything to me here that suggests that I'm incorrect in what I'm stating. He's using a constant mutation rate. Humans don't mutate constantly, like at a constant rate, rather.
Right. And that's why no size fits all. That's why he needs to look at generational times when it comes to species. When it comes to African people groups, we need to look at population history. For example, we need to look at genetic processes such as gene conversion, recombination. But that's why he's actually made a testable prediction, not only on people groups, human people groups, but also species. And the point is that based upon the actual empirically observed mutation rate, you have to say that these mutation rates have changed throughout history, or natural selection has been faster in the past, for example, because there is no mutation rate that's slow enough for deep time evolution to be true. But the thing is, you can say those things all day, but without any testable predictions that flow from those explanations and those rescue devices, it is not science. Creationists are the ones that are making the predictions. Dr. Jensen's making predictions on non-African people groups. He's making predictions on hundreds of animal species, for example, and he's making predictions on the stamp of civilization in our genetics. And they are working so well, and evolutionists can't explain why. Evolutionists, when they do these analyses, rather than using the actual observed mutation rates, the empirical method like we're talking about here, and you just admitted it, they have been compelled to use hypothetical, and you're proving this, hypothetical mutation rates that are about 20-fold lower than what's actually observed. And then they base this based on archaeology or certain evolutionary assumptions. But guess what? No testable predictions. It's not science. That's the problem.
So, but the thing is, though, is I'm again forced to repeat the fact that mutation rates vary, yes, through time, but also across species and also across populations within species. So Jeanson's not taking that, at least to my knowledge, maybe he's done something since then, he's not taking that into account at all. And very much, yes, I will 100% say that when devising things like phylogenetic trees, mutation rates are looked at in the context of how they've slowed down through time. But Keep in mind, that doesn't help Jensen's case because he's still using a single mutation rate for all humans since the dawn of time, whenever that may be. But the problem is mutation rates vary from population to population.
Everybody agrees that humans mutate differently, and species may mutate differently, and there's different generation times and population histories. That's why he's making a prediction on an African people group who he is saying has a different population history, because he's saying that those Khoisan peoples are mutating faster, or maybe there's faster rates of gene conversion. But let me ask this. So humans, though overall do mutate fairly consistently, that's why he's able to make these testable predictions that evolutionists are making, except for in Africa. And that's why he's got different factors at play there. But why? Let me ask this. Why, if it's so inconsistent, for example, or it's so different in the past, and we should look at these phylogenetic assumptions, why is the FBI using those Parsons rates in forensics? If it's so,
because the mutation rate that's occurring now is to a degree very accurate for the people that are here, particularly as I know I don't know this for certain, as I very much guess the FBI is doing. How they're using it, I would wager, is very dependent on the ancestry, perhaps the gender or race of the particular individual that they're working with, because there's variation in the human population. So I would need to see, I want to see when Nathaniel Jensen is finally going to show us the results of this paper. I have no idea how far he is on it, if he started.
He's already shown results. Yeah, I can send you those.
Yeah, well, I mean, yeah, please do. But the fact of the matter is, like, and now that we've covered Nathaniel Jensen, hopefully to your satisfaction.
Well, I don't think you answered it satisfactorily, because you've admitted there's been no testable predictions, which means the evolutionist explanation is not science. And yet, not only the Khoisan people prediction, he's talking about if all modern human lineages do trace back their genetic differences to ancestors who lived only a few thousand years ago in the mitochondrial DNA and in the Y chromosome, then the history of civilization must be recorded in both DNA compartments. And yet you can see a couple papers, one based on population genetic history. You can see that these genetic signatures in the Roman empires, the Mongol empires, the Americas, the Greek conquest, for example, these are actually being revealed. But the evolutionists don't expect those, because guess what? The last 4,000 years of human history would just be a tiny little blimp at the end of a needle compared to the whole history of deep time evolution. So there's a 10-part series
give
that goes over these things.
Erica a chance to respond.
Yeah,
and then
so again,
Erica, just to be sure that if you want, you can ask questions regarding Standing for Truth's opening right after you give answers to those questions or objections that he had just made.
No, James, I'm easy. Whatever. I mean, if Standing wants to take the conversation in whatever direction, that's fine with me. But what I do want to make sure we talk about here today is radiometric decay.
That is the reason why. I just want to point out to the audience, the reason why is because, as you're proving here, genetics, which is the direct measurement of ancestry, goes back to just 6,000 years ago and 4,500 years ago for the Y chromosome, and testable predictions are being confirmed based on those hypotheses. So yeah, you want to go to indirect evidence because the direct evidence is not in your favor. But of course, we can go to the indirect evidence at a time. But you even admit it with the Parsons papers, because that's the empirical method. That's the observed mutation rate. Then you say, oh, it's been so different in the past, but then no testable predictions can flow from that. So I'm just saying, you can. I feel
like you're not hearing me here. I'm saying that no, I don't think Jensen is making accurate testable predictions with regard to the human mutation rate and the origins of humanity. Whether or not his technical papers are being used by the FBI or not, I know nothing about those papers, but I suspect if we went and we looked into them, they probably have, this is just my speculation, they probably have nothing to do with the origin of humanity or anything to do with the very fact that human populations change mutation rate. I would wager that what it actually has quite a bit to do with is his methodology with regard to acquiring pedigree data. Now, I don't know that for certain, but again, I want to be very clear to everyone who's listening here. Nathaniel Jensen is not making accurate predictions because he is using a constant mutation rate for all of humanity. Which, by the way, as I've said many times before,
that's ridiculous, because African people groups are part of humanity, and he's not using a constant mutation rate for that prediction. So why are you making things up?
All right. No more points from Standing for Truth until she gets to answer this one, as well as the one that she was actually making when you interrupted.
Of course, take your time.
No, sure. And Standing, you can get a bit agitated about it. That's fine. But the fact of the matter is, I can provide, like, in a quick Google search, dozens of papers that showed the technical literature for why the mutation rate varies, or we could just pull up the fact. I mean, we can play the games of authority all day long, but the fact of the matter is, a great volume, I suppose, of the predictions that have been made by evolutionary theory have come to fruition, including, mind you, the great majority of the ones that have to do with anthropology. So again,
which predictions have come true? Sorry, I don't want to, because you made a claim. Which ones on mitochondrial DNA and mutation rates, for example, and genetic signatures in both mitochondrial DNA and Y chromosome? Which predictions are you referring to?
So Standing, I feel like what you're asking for here is you're asking for me to provide a prediction that evolutionary theory has made.
You just said they've made predictions
using your mutation rate.
You can use your own.
That is this constant.
Okay, we need fewer interruptions from Standing for Truth.
No, it's fine, James. I mean, I get what he's saying.
We're having just a back and forth discussion.
Yeah, I get.
There are disproportionate interruptions from Standing for Truth, and so
hey, I don't take it personally. If I can't get riled by,
you can interrupt me at any time as well, Erica. But I'll go uninterrupted.
Yeah, if I can't get riled by Nathan Thompson, I'm not going to get riled by you, Standing.
As long as it's equal, I'm fine with it.
No, yeah, absolutely. I mean, I feel like, I guess, honestly, I'm not really sure what kind of predictions you would expect evolutionists to make. Like, to make a clear comparison, I feel like what you're asking is quite similar in concept to when those who accept evolution say, okay, well, what would you expect from a transitional fossil? And then typically, the creationist gives either an answer or they don't. So I guess I'm not sure.
Actually, can I interrupt you just for one? I just want to make one point.
Well, but I want you to answer my question after I let you go here.
Because you made the claim that they're making predictions. So I just said, what predictions were those? And now you're
asking. But you want them with regard to mitochondrial DNA, which, considering we're using a constant mutation rate for the population that is here right now, you're asking. And I'm going to answer your question right here, right now. You are asking for a prediction on how mutation rates change on whatever the mitochondrial DNA. And given the hominid slowdown hypothesis, even if we could make that prediction, we wouldn't know our results for hundreds, if not thousands of years, because the change in mutation rate is rather slow. Now, and keep in mind, this is falling in line with the hominid slowdown hypothesis, which suggests that it's getting slower exponentially. We see this in bonobos and chimps, and we see it in humans, less so with gorillas. So I'm feeling like, to be very clear, I'm feeling like the predictions that you're asking evolutionists to make couldn't come to fruition until both of us are dead. You get what I'm saying?
And that happens often. I mean, Darwin himself has made those predictions. You're talking about different factors in the history of humanity or the history of other various species that have changed the mitochondrial DNA molecular clock, and it would have to be changed for the slower, for deep time evolution. But we're just looking
and to be clear, this is very analogous to saying, why don't we see big evolutionary changes today in and usually people, what they want to see is the big, the sexier phyla, right?
I just wasn't really, and see, you interrupted me there, and it's okay. It's just a back and forth dialogue, because I just wanted to point out that
I'm cool with it.
I'm starting to gather. Do you not believe that Jensen is using secular mutation rates to come up with his predictions?
No, I know he's using a singular secular rate from Soares et al. And I know for a fact that in that same paper, everyone out there, go look this up. I'm saying this with emphasis because I know it for a fact. Soares et al.'s paper, the one that Jensen cites, notes that mutation rates vary. So I don't know why Jensen, being the fantastic geneticist that he is, missed that. You get what I mean?
Yes, but I feel like you're not hearing me as well, because I've already said, in a nutshell, he's considered heteroplasmy. He's considered somatic mutations. He's considered germline mutations. For example, there's already agreement between two mitochondrial DNA rate sets that exist. For example, the D loop, the coding region, which we know is germline. And then the second set looks at the entire mitochondrial genome. And Jensen took a look at that data, and it came out as the same as the D loop result. So these are all corroborating with each other, which has now led to predictions on non-African people groups, as well as predictions on the history of civilization regarding genetic stamps.
Right. So two things on that, though. Two things on that, and now that we are both healthy in our interruption, because normally I'm not too big on it, but that's we're having a passionate discussion. That's okay. So I want to hear this from you now. Are you suggesting that the paper that Jensen pulls from Soares et al. Supports the notion that there is a single mutation rate that can be used for the mitochondria?
So if the paper that you're referring to, is that paper the one that's considering looking at heteroplasmy and possible
where Jensen gets
his
mitochondrial mutation rate from? It's listed in the book and then in the footnote or whatever, and then it's also listed on EvoGrad's site. You can pull it up and see the one I'm talking about there.
Right.
Is that paper? Are you telling me right now? Because I really want to know for certain what you're asserting here. Are you telling me that in that Soares paper, Soares himself agrees with Jensen's conception that there is a single mitochondrial mutation rate that can be used for humanity?
That's a good question, but the thing is, you're assuming that he's only looking at one paper.
No, I'm not assuming. I'm just asking that particular paper because he cites Soares et al., which means he's citing Soares et al. For a reason. In that paper, do you think he's honestly representing Soares et al.? And I'm asking this because I know the answer. Do you think he's honestly representing Soares et al. in pulling a single human mutation rate for the mitochondria from that paper? I think it's 2009. I'm not positive.
If that's the paper, if he's actually just looking at the rate at which the mitochondrial DNA mutates per generation, then yes, that is exactly what Jensen is looking and considering. In that paper, he might conclude different, of course, mutation rates. A lot of these papers are written by secularists and evolutionists, so therefore they're looking at ways of explaining the empirical data. They'll look at
so then it's not corroborated by a secular source then, because if Jensen is looking at, if I want to write a paper on how big the average cow is, and I go and I look at a paper and I see that this person has this big long list of data, right, for cow sizes. And I see, look, the average cow size is 300 pounds, right? And I walk away from that. But then when someone else goes and looks at it, they see that the average size for a cow is being 300 pounds is for a single year. Then you're not representing the data properly because you're only taking a piece of it. What I'm asserting here is that Jensen is pulling a mutation rate that works for him from secular sources, and that what he's not doing is considering it in light of all of the rigorous methodology that went into not just finding that mutation rate, but all of the other mutation rates. Right. So that's my point. Now, may I suggest? I want you to have the last word on this. So I want you to have the last word, and then I would like to move to a different topic since we've been on this one for a while.
Yes, I agree. I was about to suggest that too. And you know what? This was a good back and forth. I've had fun. There's no animosity as well.
Oh no, standing please. Come on. I get passionate. I don't get mad.
No, it's because I think we're both the same. We like to address every single point. So I would just say that, there is agreement in all these different mitochondrial rate sets that he's looking. I know that he considered I believe it was the Mark Stone King's lab 2016 mutation rate, where it looked at the human mitochondrial, I believe it was the germline transmission bottleneck, and that can be used. So he'll use these as indirect measurements of mutation rates, and then he'll consider heteroplasmy and then find a similar mutation rate as well. But my last word on that would be, like, with the mitochondrial DNA and even with the Y chromosome, which we know that mutates faster, there's only a few mutations that separate the mitochondrial DNA differences from the mitochondrial E sequence. And there's only about 300 DNA differences that separate the Y chromosome from the Y chromosome atom sequence. So with the Y chromosome, you just need a faster mutation rate, and boom, there you go. And with the mitochondrial DNA, there's only a few that are separating the E sequence anyways. So it seems more consistent with our model, but of course I understand what you're saying. If you want to say something to that as well, you can, and then we can go to the question you had.
Yeah, I just have a problem with the constant mutation, right? That's the long and short of my problem with Nathaniel Jeanson as a whole. Yes, I do like to harp on his weird method of getting the African generation time, but I don't. That's not my biggie. So I would like to ask you a question. I want to dig into heterozygosity a little bit, and I want to dig into your statement from your presentation where you say that that both camps, both young Earth creationists and evolutionists, both predict nested hierarchies, because to my understanding that is completely retrofitted in mostly in Jeanson's work, but I've heard other creationists say it too. But the idea that nested hierarchies are something that is predicted by creationism to me is a wash. I've never seen a source older than like 2015 that does so. So why do you feel that you can say that both camps predict that, when what it seems like what's happened is that there's such a wealth of transitional forms now that creationists now have to say, well, okay, there are some, but we predict that too. So take that away. Let's run with that.
So do you have two separate questions? Like, why would we predict mosaics, and also why would we predict nested hierarchies?
No, I'm saying, do you have any evidence that anyone did predict that?
So with what Jensen's saying in his book, I mean, a lot of this would just be, I think nested hierarchical patterns have probably been known since Darwin's day. So a lot of this is retrodictions, but our prediction is based on the design model. If God designed life, and you've heard this before, I guess for the audience sake, what would we predict and assume he did? Well, if he created us in his image, of course, then we can get a sense for how he may have designed the biological world based on the way we design things. And we can see that nested hierarchies in DNA as well, on a mitochondrial level, nuclear DNA level even. You can see just based on modes of transportation, you can see that they all fall within nested hierarchical patterns. And I think it's just common sense that from both models, we'd expect more similarities in a human and a chimp in DNA, in morphology, in anatomy and physiology than we would with a human and a fish, for example. So those groups within groups patterns, for the most part, would be expected on both sides. Now, there are inconsistencies, of course, that we can look to, just like you could probably point out inconsistencies in the design modes of transportation hierarchy, but that's why there's convergent evolution, incomplete lineage sorting, for example, loss of traits evolution. But for the most part, that's what we see is nested hierarchies. Go ahead.
Okay, so Darwin predicted transitional forms. In fact, he did so with quite a bit of kind of sorrow, because at his time there pretty much were none. Paleontology was not a huge boom until, unfortunately, the later half of his life, and he actually did live to see Archaeopteryx lithographica get wrenched from the ground. So he was validated in that aspect. But do you see why I have a bit of a problem with the retrodiction idea being, because I think it's more of a philosophical standpoint, like where creationists have kind of been like, okay, well, we've got a lot of this stuff going on, we've got to do something with it, and we might as well call for a nested hierarchy. And from that point, I would say, and this question was coming, where do we draw the line between organisms that are connected by a nested hierarchy, like wolves and dogs, or organisms that are not, which, as creationists propose, and as I'm sure you propose, or I'm not sure, I would wager that you still propose, humans and chimps. So, why do we have you had time to kind of look into that? Because I know we've been kind of doing a back and forth on videos on that. So I don't want to jump you on it if you haven't had the time to look into it.
No, yeah, of course I have. And I think those are good points. I believe that Morris and Gish, they predicted like nested hierarchical patterns in DNA. I believe it was in 1985. I've got a paper here somewhere else. In morphology and anatomy, of course, that was predicted long ago by Darwin. I just think it's obvious, because I feel like some evolutionists will think that like you're supposed to have humans, which are just completely unique and separated by all types of species, right? Equally distant from, say, chimps as they would be with fish. So I'm just saying these groups within groups patterns, I think common sense would tell us, are expected. But of course, there always is lack of uniqueness in the phylogenetic tree. That's why there's those certain things that I talked about. When it comes to the transitional forms, a few mosaics that you can look to, Tiktaalik, or you can look to Archaeopteryx, even the reptile like mammals, for example. But the majority does prove the rule, and you've heard it before. For the audience sake, I mean, if we want to build, let's say, a military vehicle that's built for the environments between land and the oceans, well, we would build something like an amphibious assault vehicle or even a crossover SUV. So based on the design model, these things are expected. Now, you're right. We have to differentiate between the models by looking at a way that can actually draw a line in phylogeny, or where do we, is that pretty much your question now? Like, where do we differentiate between ancestry?
Well, yes, and as you know, I've asked this question many times before, and there have been many attempts to answer it. It's not my question. It's a very specific version of R and Raw's phylogeny challenge. Mine usually specifically looks at humans and chimps. I don't want anybody to think I'm taking credit for that, because I'm not.
It's a valid question. It's a good question.
Yeah, but my thing is like, I have a problem with that, because that means that genetics and the nested hierarchies that we see in genetics are completely indistinguishable. If you're looking at these two models, right? It's completely indistinguishable to tell which is which, unless, as I know you said in your conversation with Conspiracy Cats, unless we're looking at the completeness or lack thereof, or rather, sorry, functionality or lack thereof of any given genome. And I don't want to go too far down ENCODE, just because we talked about it so much last time. But you could.
Yeah, go ahead.
Sorry. Yeah, I was going to say, I did take your advice, and I looked into what the work that they were doing on those knockout tests, because you posed a good question to me. You said, okay, well, if we know that most of the genome isn't functional, and in conventional geology, ENCODE notwithstanding, usually what I have heard, at least in textbooks and things like that, functionality means that it impacts phenotype. So sheer transcription outside of the realm of ENCODE is not typically considered functional. And so you asked me, we were talking about knockout tests for mice, because I had said to you, well, they do these big knockout tests in mice where what they do is they artificially go in, for the audience's sake, and they knock out a bunch of genes, pump, 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 like that. And then they see what happens. Can the mouse still reproduce? And they do this usually in vitro. So it's like, can the mouse still reproduce? Does it have normal arms? Does it have a normal tail? And I looked into it, and they managed to, the extent that they have gone to is they can knock out half the entire genome of the mouse, and of the what is considered the junk DNA. And it is still like running around doing its deal.
Well, and that's a good, I wasn't going to point to function just yet. We could talk, I was going to point to something else as a way to draw the line, but since you did bring that up, I would say I do have a study here where what they did was they knocked out junk DNA of a mouse. And you're right, there were some experiments where the mouse offspring were just fine, but they've also done multiple experiments to see if they corroborate that. But what they found was that I believe there was some long non-coding RNA gene knockouts that actually showed lethality that were associated with the development. I think it was tissues such as the lungs, the heart, the testes, even the brain, for example. And even when they knock out certain classes of retrotransposons in the mouse embryo, when it's when that jumping gene is turned on, the mouse suddenly dies, which shows the importance of certain in various classes of retrotransposons. But what I said in the previous debate as well was that many non-coding RNA genes, even pseudogenes, are only expressed under certain conditions that are not, unfortunately, are not available in lab type settings. But redundancy, I mean, even if you're seeing some genes that are knocked out and the mouse is just fine, I mean, redundancy is an amazing thing. I mean, in computer code, redundancy is highly beneficial. How does evolution explain redundancy, for example? Natural selection sees the long term. That's what, or natural selection sees the short term. So how does a natural selection help evolve something like redundancy in the genome? Go ahead.
Well, conceptually, and I don't know, I would need to take some time to look into the technical papers on this, but I can answer you from a conceptual standpoint,
sure,
which is you're right. Natural selection works in the short term. In fact, there is nothing, there is no kind of gene that is partially really naturally selected. And I want to explain what I mean by that. It's either bad and it's selected. It's kind of fickle, I suppose. But I would encourage you to look into the concept of precursor mutations, because I think they have quite a bit of bearing on co-option. They're certainly not the same thing, but essentially the idea of a precursor mutation is that I can't remember who did it, but that there's one guy who has like this classic example of the mousetrap where he removes, most of the parts of the mousetrap for it to be a functioning mousetrap. And he's like, it makes a really ugly tie clip. So the idea is that every single stage in the concept of precursor mutations, if you're trying to get a complex structure or behavior or length of DNA, whatever, but every sort of subsequent step is useful in some way. You get what I'm saying? So this has, and I know this has been done to quite a bit of success with the flagella, but I don't know if it's been done with what you're talking about here. So I would love to look into it. I very much imagine it's going to be the same type of scenario.
Sure. And I would love to look at those papers too, just to kind of go down deep in it. You know what I mean? I want to see how much of it is empirical, how much of it is philosophy, because I think for evolution accounting for DNA repair and the redundant mechanisms, for example, that we see in the genomes, those redundant mechanisms, as it looked like you agreed with, is it requires forward thinking, when we know that natural selection works in the short term. So it's like there's so many things in the genome that evolution would have to account for. And I'm willing to look at those papers, but you're looking at self-organization, you're looking at the communication between the cells with other cells.
Yeah, I mean, with that though, you're talking about the evolution of sort of complex behaviors and what spurs that. I was listening to an interesting podcast the other day that covered how behavior always comes before morphologic change. And I believe that is sort of amplified even to a very small degree. But yes, we'll have to swap papers on that and look a bit more into it.
I did want to make one little point about drawing the line in phylogeny. I showed
please do.
I showed because I noticed that you, and I'm glad to hear that you're well informed on the chromosome 2 fusion. So I showed the quote by Ken Miller, who said that, and I'm not saying that every evolutionist has to agree with that, but he did assert beforehand, before they discovered what looks like a chromosomal 2 fusion, that if there was no fusion, there was no ancestry with the great ape family, with the chimpanzees. I know you think humans are apes, so with the apes, or with the chimps and other primates. But
can you present a reason to why we're not?
Well,
I mean, I'm being hypothetical. Okay. Obviously, we're not talking about that right now, but when you get a moment.
I would just say if I could demonstrate that there was no chromosomal 2 fusion, which is why I asked you some of those important questions, then just like Ken Miller said, no chromosome 2 fusion, then no ancestry with chimpanzees. And I think that
I'm comfortable with that.
We're not apes.
Yeah, I'm comfortable with that. Well, the thing is if the chromosomal 2 fusion isn't a fusion, then the alternative hypothesis would then subsequently be looked at, which is that the other hominoids gained the chromosome, or the chromosome pair. But to be very clear, for everyone out in the audience, you can go check out. Yeah, because you were there. You were in the chat for my discussion with Steve McRae on this the other day, and
you guys were respectful. I enjoyed listening to that. Ruhif, I have respect for. I've actually learned a lot from him. I often talk to him in comment section. So I did want to, without any interruptions, James, you don't got to worry. We're passionate sometimes. I did want to give you the opportunity to, because I watched that entire broadcast. I managed to get around to it. And I feel like there was a few things that you guys didn't touch on. So I was wondering if you could take some time maybe because you have spent a lot of time on the chromosomal 2 fusion.
Yeah, sure.
Those questions. I'm not sure if you remember the questions that I asked in the opening.
Cryptic centromere and satellite DNA, I believe.
Yes. Maybe if I can find it. So the first question would be, why is the telomeric region so degenerate and small? I did ask that in our first debate. I don't know if we got as far enough to get like a solid answer from you. And I believe you do have an answer, so that's okay.
Oh, yeah. No. I did not know at that point. I had not looked into it very closely.
I don't want to do, as they say, gish gallop. So why don't we start with that question? And you take as much uninterrupted time as you want to. The satellite DNA is a very important question that I'd like to ask, but let's start with the telomeric region. Why is it so degenerate and small? And then I'll give a response after.
Ruhif actually explained this to me in our conversation with Steve. For those of you out there, in the human chromosome 2 fusion, in the center where the fusion site is proposed to have occurred, there are very degenerate telomeric sequences. Now, those telomeric sequences they usually cap the ends of the telomeres. Now, the reason why that's degenerate, and Ruhif pointed this out, I would go back and rewatch that if you would like to hear him explain it better than probably I will, is because you have a gradient the ends of all chromosomes. So there's fresh new telomeres on the outermost point, then degenerate telomeres, because as we both know, when DNA replicates, the telomere sequences really take a beating. And then after that is when you start to have the classic regular chromosomal, business that chromosomes do, whatever base pairs. So degenerate sequences, according to Ruhif, and he sent me some cool, or rather he has some cool stuff on his channel that goes over this more in depth. But the reason is because that's entirely expected. In fact, all of the criticisms that I've seen regarding that by individuals like Tompkins, in the responses to Tompkins, they're usually like, why would you expect it not to be degenerate? In fact, if it wasn't, that would be quite weird, because that would suggest that when the fusion occurred, it completely ate up that degenerate site, when the degenerate sites, when they're exposed, is what causes fusion. Essentially, it's like having, I explained it like this when I was talking with Ruhif and Steve. It's like having two magnets. The ends of the magnets are degenerate telomeric sequences, and they want to stick together. But those new telomeres that are on the ends are like putting a cloth in between the magnets, so they can't. There's no real way for them to. It's like a weakened attraction. That's a very rudimentary way of explaining it. And interestingly enough, I'm just going to kill two birds with one stone here, because we talked a bit about satellite DNA.
Right.
Telomere fusions, which Tompkins objects to, the fact that telomere fusions can happen, which is what we see in human chromosome 2, they do happen. And Ruhif gave me two great papers for that. One occurred in pigs, and the other one occurred in equids. And what we find in both of those is the same thing that we see in human chromosome 2, which is telomeres stuck together like this, not satellite DNA, not satellite telomere DNA, telomere. So, and I can send you those papers if you would like, or I can put them in the description.
Yeah, of course. I really appreciate that response. That was well said and very concise.
Not as good as Ruhif did it.
For James's sake, I did time it. It was about 2 minutes, so I don't want him to think that I'm going on for too long as well. So we'll do equal time here. Actually, before I respond to the telomere one, the question I had was a little different about the satellite DNA, because chimps have this very distinctive and exceptionally large satellite sequences at the end of their chromosomes, not the satellite DNA that Tompkins was talking about when the centromere breaks, for example. Because, like you said, if this is a telomere to telomere, you may predict that maybe there won't be that satellite DNA. So that was a little different question. I was asking, where are those large 8 specific satellite sequences in the reputed fusion site?
Would you like me to, as quickly, under 30 seconds, explain that as well?
Yeah, you know what? Take 30 seconds, explain that, and then I'll try and address both at the same time.
I figured you could just go ahead and just take a.
Just because it was and I appreciate you answered the other satellite DNA objection, but this one was a little different. So take your time.
Sure, it was my mistake. I goofed it up in my head. Yes, so the ends of the chromosomes, like I said earlier, those are the areas that are most frequently in the chromosome, sort of renovated, so to speak, if you want to call it that, because they just take such a beating in cellular replication. So I don't understand why, given evolutionary theory and what it says, why it would be difficult to sort of conceptually, what's the word I'm looking for? Conceptually square those two things together, because according to evolution, maybe it's different with sort of the creation outlook on it. But to be clear, from an evolutionary perspective, we expect mutations on those repetitive sequences on the edge of the telomere because they're renovated so frequently. So given the split between humans and chimps was 7-ish million years ago, that's quite a long time. It's similar to the degenerate concept. That's quite a long time to be developing sort of unique sequences. In fact, 7 seems to me, on a totally an anecdotal note, seems to me like not that many. Compared to, given you've got 7 million years. Sorry. Take as long as you need. I will.
No, I just want to make sure you answer that last one, just to, because I want you to feel confident in your answer. So the question on those very large satellite sequences at the ends of their chromosomes with apes, are you saying those are absent in man because of the divergence time of 6 million years that would have got rid of it? I'm saying
that if you have two chromosomes like this, right, and the ends are constantly changing to a degree, right, because of cellular replication and repair. Now, if they suddenly join together and that that lineage continues onward. You're no longer getting a change in those end telomeric sequences, but if they stay separate like they are in the rest of the hominoids, those areas can still be subject to change and mutation. So I don't know why you would expect, it's like any of the other, pick any difference between humans and chimps, and the reason that it's there according to evolutionary theory is because it's been 7 million years. So there's naturally going to, it's kind of like how we've noted that we've had the conversation before, how there are orphan genes that are unique to humans and there are orphan genes that are unique to chimps. Even though they share a great majority, there's still been time for unique novelties to accumulate. I'm sorry.
Okay,
that was a long time.
So are you saying that those unique sequences that are those ape-specific satellite DNA sequences that should be seen flanking the reputed fusion site on both sides, if there really was a chromosomal fusion, after the split between the chimps and human ancestors, say 6 million years ago, are you saying the reason we don't find that, just I guess yes or no from what I gathered with what you were saying, is because of the divergence time? There's been enough time for that those ape-specific sequences to be lost. Is that more or less what you're saying?
Divergence or speciation. Either, if you want to go for divergence, you've got 13 million years, maybe, depending on who you talk.
Okay. So the reason we don't.
Yes.
So the reason we don't. I just don't want to put words in your mouth. So you're saying that the reason we don't find those sequences around the reputed fusion site is because of the deep time since the fusion. They've been lost essentially for whatever reason.
Yes, according to the evolutionary paradigm, that tracks very well with everything else that we say.
Okay. I think, so I wrote down as much as I could from what you said on the telomeres. So I think contrary to what you're saying, even the original paper, and I would ask the audience to read it, even the authors there, the researchers, they emphasize a level of confusion and awe as to why the head-to-head arrays of repeats at the fusion site there have degenerated so much from the near perfect arrays found in telomeres that you described, right? So you can examine the fusion site for yourself. Anybody can do it. It's an extremely small segment of DNA compared to what should be present if a fusion actually did occur in the deep evolutionary past. I think the site is about 798 bases in size. Now I understand with what you're saying is you would expect it to be degenerate. But even if there were two very small size telomeres that fuse, let's say, we're still looking at about 10,000 bases. And then if it were larger telomeres that fuse, then it's an even bigger problem because obviously, since now we are looking at about 30,000 bases in size. And yet what we see in this signature is a pathetic 798 bases as the remnant of a so-called ancient fusion. But I think what you're saying is also weak as a rebuttal, because why would both of the fusing chromosomes be degraded to exactly the same point, yielding a minimized semi-symmetrical fusion? But I think the most fatal blow to what you're saying here, as a way to explain why the area is so degenerate, and I want you to comment on this, of course, is that we see these telomeric repeats, these internally telomeric repeats that you're pointing to, right? Because if we're saying that it's too degenerate, that implies that something's still there. So what is it? Well, we see those telomere repeats occurring throughout the entire genome. And these internal telomeric sequences are found to be functional. I've got many published papers here that's giving us functions for these sites. So they're binding to things called transcription factors. And what they do is they initiate the copying process of a gene into RNA. And what's amazing, it's kind of a double whammy because that's yet more confirmation of our model, because we predict much of the genome, as you know, and many of these DNA sequences, for example, cytochrome C and other conserved genes have multiple roles and multiple functions that play in the regulation of the cell and many other things, of course. So how do you explain the fact that that region is found throughout the genome? They're not found throughout the genome in relation to fusions. They're actually just functional sequences. So have you heard of that argument?
I want to give Erica a chance to reply, and I think what we might do is go into the closings right after that. So go ahead. The floor is all yours, Erica.
Yeah, sure. And Standing, we're going to have to talk about radiometric decay at some point. That is, to me, one of the biggest blows to the creationism model that there is. So outside,
I do feel bad. I mean, if James wants to give us an extra 5 minutes of discussion to touch on that, I mean, I don't mind that, but I mean, it looks like I don't mind. After you answer this question and even just briefly touch on the cryptic centromere, I mean, Are we running low on time there, James? I feel like we just started talking.
If you guys would like to, that's okay with me.
Yeah, standing and I have a good time. Yeah, that works. 5 minutes. I'm sure we can at least broach the topic.
Yeah, let's do this. If you could answer what I said about the telomeric sequences, a really quick response to the cryptic centromere. I can do a quick response to that too. And then we'll give like the last few minutes to radiometric dating if you'd like to.
Yeah, well, and in fact, I'm not opposed to foregoing my closing necessarily if we would rather just have more conversation. But if you want a closing, I'm cool with doing closings as well. So it totally just depends.
Sure, you take your time, as much time as you need to address the points I made, and then we'll play it by ear.
Yeah, okay, so one, I noticed that you said that the fusion site is small compared to what we should expect, and I wrote down on what basis, essentially, like what are we comparing it to? What other fusion sites specifically? Because according to the paper that I can link in the comments, the two papers actually, one on pigs and the other one on equids, specifically the zebras. It's very analogous. So, and it's a telomere fusion. So again, on finding telomeric sequences throughout the rest of the human genome in areas that aren't necessarily telomere specific, I would be interested to see, and I would predict that they are not found in the same bulk as they are in the center of human chromosome 2, because there are two things that make the telomeric sequences found in the center of human chromosome 2 so very important and so very indicative of fusion. And the thing number one is that there's so many of them, and the thing number two is that they exist there in accordance with the synotony, both behind and in front of the one on top, and I guess whatever, on top of the one on top and below the one on bottom, with synotony with the chimp chromosome 2A and 2B. In fact, when I was doing research for my most recent video, I found out that every single gene on the chimp side tracks to human chromosome 2 from 2A and 2B, if memory serves. They track over. Human chromosome 2 is a bit bigger, but mostly it's those pesky repetitive sequences that show up in most hominoid genomes. So, and with regard to the centromere, actually, I didn't have a chance to write it down earlier. I watched your conversation with
I'm not interrupting, I promise. You didn't really answer why those internally located clusters of telomere sequences are more common in the genome than just, where we're looking, and why they are now found to be extremely important.
Oh, no, but I did, because it's context specific. The fact that we're finding the telomeric sequence in the center of this chromosome 2, in massive bulk in comparison to where we find them elsewhere in the human genome, is very, very indicative of a fusion site. And that is taken in accordance with the fact that the rest of chromosome 2 on either side of the fusion site tracks gene for gene with chimp 2A, and chimp 2B. To be clear, I'm not saying that they're identical. The human chromosome 2 is a bit bigger. But again, it's those weird indels that make up the approximately 3% difference between humans and chimps. With regard to the centromere, what I was going to say was that I took a screenshot of your conversation with Conspiracy Cats, because I remembered this was from several days ago, that he had brought to your attention the fact that there is a cryptic centromere. Right. He disagreed that it was a cryptic centromere. But for those of you who want to know specifically, I suppose, the name of it, it's Q21.3 and Q22.1 regions. And I don't know why it wouldn't be cryptic. If you're sort of fusing two chromosomes together, would you not suspect that areas, given it's a centromere, that it's going to be at least partially written over or subject to the same mutations that the rest of the chromosome is subject to? I don't know why we would even expect it to be crystal clear. So I hope that, at least, even if you disagree, I hope that at least you got an answer to each of your questions.
It's not that I disagree that is the point or the area that they choose to look to, because I understand, and you obviously understand, that if there was a fused chromosome, if two fused chromosomes, then you would have to demonstrate not only the legitimate fusion site, which is why we're talking about the telomeric region, but also locate a disabled second centromere, the cryptic centromere, I guess you could call it. So and there is a proposed cryptic second centromere. So I guess my follow-up to that, and maybe a question to go along with it, is that, so that 171 base pair repeat that characterizes primate centromeres, right, which would have to be found. It is that region or that sequence is found in many other parts in the human genome. And I have pointed out in the past, you've obviously watched the conspiracy cats debate, which I would recommend anyone watch that. It's too small and too human to be a remnant centromere, but you said that that's expected. But I think the fatal blow to that is that the entire sequence is internal to a functional gene, that ancient centromere site. So that means it would be impossible if that sequence had ever been a real centromere. But I think the fact that the cryptic centromere is a functional region inside a protein coding gene, encompassing both protein coding and non-coding regions, strongly implies that it's a key gene feature and not a defunct centromere, as you're pointing out here. How would you respond to that?
But why? Yeah, but why would it? I mean, there again, you can point to the fact that people who conventional science, when it proposes the human chromosome 2 fusion, it notes that there is on the center of chromosome 2, so the actual proposed fusion site, not even the cryptic centromere, that there is sort of a ghostly trace of a functional gene, the DXL11, whatever. I can't remember what it's called. I'm messing it up, but you know the one I mean.
Yeah, the DDX11L2.
Yeah, the DXL11L2. Yes, that's very classic for again, it's part of telomeric family, which is gene family, which is very interesting. But for the same way that I would answer that question, why is it against the rules to have a gene move onto a fusion site or move onto a cryptic centromere? I would be interested. I don't know this, but what I want to look into is, can we find a promoter anywhere near the cryptic centromere? Because if I remember correctly, and the reason I said I'm going to look into it is because I don't. I feel like I remember reading at some point somewhere that the cryptic centromere is the functional gene that's on top of it is somewhat new, at least with regard to.
I'm not interested, but remember that 171 base pair region is associated with other locations in the human genome that have no relation to a fusion event, and they're functional to the genetics, is the point. So yeah, it's located internally of a gene, but it's also the sequence itself is functional, just like those telomeric repeats. So both of those sequences, the telomeric repeats and the centromeric repeats that you're pointing to as ancient telomeres and an ancient centromere, seem to be, the evidence is suggesting that they're just DNA elements that are found throughout the entire genome. So why are you cherry picking that to say that these are the remnants of an ancient fusion event?
Wait a second. I actually did not know this. Are you saying that centromeric repeats are found in the cryptic centromere, and then you're saying that it's not a cryptic centromere?
Right. Well, I'm saying that
I didn't know there were centromere signatures there. Like I thought it was more of a location with maybe a handful. If you're comparing it to the fusion site, then why? I mean, my answer is exactly the same for both of those. I would imagine,
I'm just saying
for certain, that centromere, those centromeric repeats that we find there are found in larger quantities than they are elsewhere in the genome. Because you haven't said anything to suggest that at the telomere fusion site, right? That those little telomeric signatures that we find elsewhere in the genome are in the same quantity, because that's very important.
Good question.
You find these things like ganglions.
I will answer. Yeah. I think we're both guilty of saying a lot of things, so sometimes we'll forget. Yeah. Those telomeric sequences, those internally telomeric sequences, they're found in parts of the genome in a few hundred base pairs in length, even a few thousand. And they're, for the most part, so all different types of lengths of I guess sizes, but they're associated with function. You know,
so they're found at the same size as they are in
different sizes.
But not as large. None are found quite as large. I feel comfortable proposing that. Am I correct in that?
Are you saying not as large? I mean, the reputed fusion site region's only 798 base pairs?
I'm saying, do you know for certain that the same number of telomeric repeats that we find at the proposed fusion site are found elsewhere in the human genome and are functional?
Yes, some are smaller, some are.
But none are the same size, are they?
The same. They could be. I mean, those sequences that are found there, I'm saying, are just found all throughout the genome, just like
but not in the same. That's what I'm going to assume that that's what you're saying, because I feel like I'm not getting a clear answer. would it be okay with you if we quickly touched on radiometric dating here?
Of course. Because I don't want to leave anything hanging. I don't want you to think that I didn't answer that question. I'm not exactly sure how large the sequences are. I'm just saying that there are many other internal
That's fair
sites
enough.
all over the genome where telomere sequences occur in like this and that are functional. And one last point I wanted to say in response to your the centromere sequences is that actually Tompkins pointed this out, and then I'll even give you the last word on the chromosome 2 fusion before we go into the dating. But he pointed out that, and I want to see your thoughts, that centromere sequences are made up of variants of alphoid DNA sequences, a class of DNA sequences, right? There are different variants, though, of these alphoid sequences that can be placed into different groups or categories. So some types are found all over the genome, while others are specific to centromeres. This is the key issue on what we're discussing here. The type of alphoid sequence found at the cryptic centromere site on the human chromosome 2 does not actually match alphoids associated with functional human chromosomes. So there's no consistency there. Like, how would you, what are your thoughts? Like those alphoid sequences, I want to make it more clear, found at the so-called cryptic centromere are a type commonly found in the human genome outside centromeres, which we can just label them as higher order repeats. So like, what are your thoughts on that?
I mean, my question would be, when you're finding these in other locations, it's very similar to my question with the telomeric sequence. Are they found in the same volume? And again, I think this is left out. So that's sort of my answer to that. But as a tag on for those of you watching,
I would say yes. As an answer, I would just say yes. In the same volume, greater volume. I mean, all parts of the genome, these sequences are found in all different sizes, all different quantities. They're found to be associated with important functions in the genome. That's why Tompkins is saying, okay, this area is degenerate with the telomeric sequences. While there still is, a 798 base pair region there. What is it? And then he's discovered that these sequences are found throughout we've already talked about this, but my answer would be, yeah, size-wise, quantity-wise, all different types of quantities throughout the genome. But that numbers, I'm not sure.
That feels a little bit like a either put a pin in it or like a cop out, because it's like, obviously if we don't know, because I don't know, I will tell you right now, I do not know the number that is found outside of this telomere or outside of the cryptic centromere. It's something that I want to look into. But if we don't know for sure, then we kind of just have to say we don't know. Saying they're found in all sorts of different sizes is somewhat irrelevant, because what I don't know is whether or not finding larger sequences is equally as sort of precluded as a potential analog as too small sizes. Like, is it the perfect size for a telomere fusion? If I remember correctly, and I could be incorrect on this, but I'm fairly certain, according to those two papers on telomere site fusions in equids and in pigs, it's quite analogous.
Well, real quick, I did quote earlier from the actual paper of the chromosome 2 fusion. They did ask, why is this area so degenerate? And even if it was too small, degenerate telomeres, you should still see remnant telomeric sequences of at least 10,000, but all we see is 798.
But standing in the original paper of finding Lucy, Australopithecus afarensis, they were like, well, why is it that the pelvis looks like this? I mean, if I remember correctly, the human chromosome 2 fusion paper was like either in the early 80s or the early 90s. Like, to suggest that them not knowing what was going on is somehow indicative of the fact that now there is indeed an answer to that question. Other than saying, well, I don't like what Tompkins does, which is saying, I don't like it because XYZ, or I disagree because XYZ. But I don't think you can just point to a past paper and say they didn't know what it was and use that as evidence to bolster your point.
Well, and I don't want to recycle everything that I said in my response as to why I believe that argument fails. We'd probably just be repeating ourselves there. And
we would be. I'm just saying that it's kind of pointless to bring the paper up, the fact that the original discoverers of the fusion site were like, well, we don't know why it's degenerate. I very much doubt that if I went back and read that paper that they said, we don't know why it's degenerate, therefore it's not a human chromosome 2 fusion. I think that, like most scientists do when they don't know the answer to the question, they say, well, we don't know. Why is it like that? Maybe we'll find an answer. But then I don't think it's Oh, go
Yeah,
ahead.
but even in that region, even the repeats that are found exist mostly as independent units and not actually tandem repeats. And I believe it's only like 10 intact TTAGG telomere sequences and only 42 CCTAA intact reverse complement sequences that exist. So it seems like all the evidence, when you actually look at it and examine it, and the fact that these sequences, as I've stated, are found internally all over the genome and have various functional roles, that does seem to falsify. I understand that when they first saw it, they were thrown off. Why is this area so degenerate?
Right.
So they explained it away like you said. But when we examine it even further, we see that the evidence does not support that claim as to why it's so degenerative.
We don't see that. We have an answer for the degeneracy. It's just very.
It doesn't hold up. It doesn't hold up.
But why not?
Well, I've given probably about 5 or 6
No,
reasons.
The degenerate sequence specifically. Why does it not? Why is it completely precluded in your mind? Remember the magnet example that I gave? When we do find the tips of chromosomes with degenerate telomere regions and then intact telomere regions, why wouldn't you expect to find degenerate telomeres in the middle if once you strip away those pristine telomeres, it makes it easier to fuse? It's like
because they're not telomeric sequences. I've already said this 5 times. And even if they were, why would both of the fusing chromosomes be degraded to exactly the same point, yielding a minimized semi-symmetrical fusion site? I get that that's the philosophy.
Did you just say they're not telomeric sequences after saying why are the telomeric sequences so degraded?
I'm saying that the area that is being claimed that these are the remnants of ancient telomeres is too degenerate. Now you're explaining away the degeneracy, but I'm showing you that they're not even the remnants of an ancient chromosomal 2 fusion, because these sequences are DNA elements found throughout the genome. That's the thing. Just like the sequences, I think it's 171 base pair sequences or base pairs that's found at the so-called cryptic centromeric site, those are also found spread throughout the genome. And I get your question is what's the quantity, but those are functional DNA elements as well, as my point.
I think we've gone to about 5 minutes, so I'm going to give Erica a chance to respond, and then we will go into closings.
Yeah, sure. Okay, so and we'll have to do that radiometric decay another time, Standing, because I feel like you're running from me on it a little bit. But I'll
address it right now if you'd like me to.
I've heard enough of that. All right, we're gonna go back to Erica.
I'll address it in my closing.
Sure. And you can.
And then we'll have a separate debate on it. Age of the Earth, round 4.
Oh, please! I would love to chat with you on Age of the Earth.
You know what? You've heard it today. Round 4 is Age of the Earth. In my closing, I'll briefly touch on the isochron. Sure. I got 3 minutes, and then we'll schedule that.
Yes. So I will, as James said, take the last word on this. So what I heard was, why is the site so degenerate? And then I said, well, it's degenerate. The proposed idea is that it's degenerate because that's what we see in other species, XYZ, explaining it with magnets. And then you said, but that can't be because they're not telomeres. And then my answer to that, of course, is, well, how do we know that? Why is it being proposed? You say, well, it's because we find little DNA elements that are very similar to what we find at the center of the telomere. And then I say, are they in the same number? And your answer, as you very honestly said, and I say very frequently myself because it's so common, at least for me, that you didn't know what the size range was, what the typical size range was for what we would expect to see at a telomere site. And then I responded to that by saying, if I remember correctly from Ruha's video, which is not a certainty, while the previous stuff I felt decently confident on, it's fairly analogous to what we see in other organisms. And that's I do not think that there is anything that I have not at least provided an answer to. Those of you out in the audience, you can take that as you will. So Standing, please close for us, and I will give my little closing after that, and then we can do Q&A.
All right, setting the timer for 3 minutes for you, Standing for Truth. And I think you already know, nothing would give me more pleasure than to cut you off during your statement. So
James, you're lucky I'm easygoing, or I'd find you and show you that I can bench press more than you.
Ooh, feisty. I like
That's
it.
That's a threat, James.
I like it.
Just kidding.
The floor is all yours.
Okay, awesome. So with the dating methods, for example, I know you like to use isochron dating. And for the audience, isochron is a graphical plot of the isotopic compositions of the sample. So it allows an isochron age to be calculated from a straight line plotted through the graph of the results. You can watch Conspiracy Cat's debates or his videos, and you can see that straight line, which is indicative of accurate ages. But what's funny is geologists have calculated ages for all the individual samples of the same geologic formation using the same dating method, including the isochron, and they turned out to be vastly different. And some of these rocks are from the Grand Canyon. It was Dr. Steve Austin used 3 different isochron methods. Also, these dates all disagree greatly with each other, even when the error margins are taken into account. So the 3 different dating methods give completely different ages that cannot really be explained away. And as far as speeding up the decay rate, I've given a few examples with fission tracks and radial halos, and for example, helium in my opening. But according to the catastrophic plate tectonics model, the CPT, meters per second plate movement, would produce new oceanic crust, replacing the old one. This new oceanic crust would show the same age through isochron dating, since it formed all at the same time. I wanted to address real quick I believe she said, how would we explain away the heat? Yeah, a lot of heat would be generated, but the massive amount of water that was on the Earth at the time, based on the flood, would shield Noah. And the RATE project explains this. So they do have answers, and it would also shield the animals on the ark. If you have a mile or more of water, of course, we even use water, as Eric probably knows, in a nuclear reactor to protect and to shield things. So this would not only shield from radiation, but it would also take up much of the heat. There's also a ton of evidence that at the breaking up of the fountains of the Great Deep, there would have involved supersonic steam jets that would have taken up most of the heat up into space and more. So the RATE project goes over a number of these things. But the thing is, all these radioisotope methods that have been long been praised as irrefutable dating of the Earth to an old age, as Erica talks about here, have repeatedly failed to give reliable and meaningful absolute ages for all types of rocks, including the Grand Canyon. That means these ages are relative and not absolute. I could go on and on. I'm probably almost done here, but the direct evidence, the genetic evidence, does show an Adam and an Eve just 6,000 years ago. I mean, this is based on the empirical method. There's just so many other things we could probably discuss. We'll save that for another day, but this flew by. I had a lot of fun. You can have the last words there, Erica. And
yeah, sure.
Setting it up.
I will. Yes, I will. I thank you for your closing. I will do my closing as well. I'm going to close the genetics concept by just saying I have a problem with gene sense mutation rate. Look into the Soares paper. And as far as the Y chromosome, I just don't see an issue with it. And those of you out there can be your own judge. I encourage you to do look into it on your own. I think that would be good. I have this excellent book here, and I was listening as intently as I could, but I had it bookmarked and I lost my bookmark. So I was leafing through, kind of paying attention and looking at the same time. So it's called The Bible Rocks in Time. I'm a very big fan of it. It's by these two. I hope that's not mirrored. Well, whatever. It's got a cool fish on it, so that's how you can identify it. It's by 2 Christian geologists. They have a whole section in here. It's like 100 pages long on radiometric dating, and they actually have an excellent selection on isochron dating, because to my knowledge, I could be incorrect on Austin, but at least Woodmarap, when he was trying to date materials, he appealed to this idea called the mixing hypothesis to go ahead and be like, oh, look, isochron dating doesn't work. And these guys say, to sum up, appeals to the mixing hypothesis by young Earth advocates to account for the isochron plots fail completely because of the failure to understand the empirical, geologic, and geochemical factors that enter into the interpretation of the diagrams. And then, as I hope to do in a video at some point, they have this incredible list of things that at least Woodmarap just completely threw out the window when he was putting those numbers forward. I don't know about Austin. I would like to look into it. But this has an excellent passage at the end of it. Again, these are 2 Christian geologists who really don't have a dog in the fight with regard to geology. They just don't really find the age of the Earth very important to their faith. But they say, at the very worst, all that discrepant ages indicate is that the geologic conditions are so complex that radiometric dating methods are not as accurate as we might like. The fact that discordances do occur from time to time, however, should grant little solace for proponents of a young Earth, for the simple reason that almost invariably the ages obtained by different methods from the same body of rock are on the order of hundreds of thousands to a few billion years old. Geochronologists generally do not encounter situations in which one method yields an age of 57 million years from a given rock body, whereas an alternative yields 5,700 years. Even rock samples with discordant ages are almost invariably extremely ancient. And then they do this excellent rundown on discordant dates, because it turns out a discordant date is very loose because geologists are very honest. So if they have 3 dates and one is 1.3 billion, the other is 1.33, and another is 1.34, those are 3 discordant dates, but you get the general idea that it's at least 1.3-ish billion years old. So I'm going to conclude my statement on radiometric dating with that, and hope that we can continue that on a later date. I'm ready for the Q&A. I hope I got some questions. Standing always hogs them.
You got it. We are very excited for that. So we're going to run through as many questions as we can, folks. This is always fun. Want to say thanks so much for our guests being with us tonight as we go into the Q&A now. Want to remind everybody, their links are in the description. So if you're listening and you want more, you know where to find it. And with that, first up, Dildo Baggins, thanks for your super chat. I don't know if it really says that on their birth certificate, but they said, did you screen these interlocutors? Obviously, an impersonation of Darth, my dearest friend and arch nemesis.
James, you're giggling like a schoolgirl.
I am talking to Darth on Discord right now. I'm trying to talk him into coming back on. So we're going to see. We'll get him. Okay, IceClaw526, thanks for your super chat, says, love you guys. You make my days at work enjoyable. Well, so kind.
Oh, that's sweet.
That's very kind.
They're not coming at me. That's weird.
Oh, don't worry, we'll get there. Brandon Ardeline, thanks for your.
I thought I was getting off the hook.
Thanks for your super chat. Who said evolution is 100% supported by science. Intelligent design / creationism is 100% supported by the fact that dying is scary. Standing.
That's for you, Standing. That's not for me, but I do appreciate the mimic of my opener.
I would say that, creationists are the ones making the predictions right now. I guess we'll have to wait for another discussion to really go into more detail on DNA function, but we're have many predictions on DNA function, mitochondrial DNA, which we've discussed plenty on. So I think the science is based on, those who are making testable and falsifiable predictions, and creationists are doing it right now. So
gotcha. Thanks so much. Next up, appreciate your super chat.
Trying to keep it short, James.
That was very good.
That was probably the shortest answer I ever gave, and I had a lot more to say too. So thank me later.
Appreciate that. And JB, thanks for your super chat, who said, go to S.J. Thomason's Twitter page and vote Modern Day Debate. That's really nice of you. I'm only saying it because he made me say it in a super chat. And
we all love Modern Day Debate.
Ben Riley, thanks for your kind words. Appreciate that. Ben Riley, thanks for your super chat, who again, Ben, you are determined, said, get Daniel from Hard Lens Media to go against Vosh. I've gotten Daniel's email, so I will reach out to these guys and see if they're willing to go toe-to-toe. So thanks for that idea. Next up, thanks for your super chat. Kakarat, let me know if I said that wrong, said, great practice for my upcoming debate with Hovind. Well, very exciting. And
good luck.
Is that on Modern Day Debate?
No. Someone showed me a screenshot of his email today on why he will not return to Modern Day Debate. But you know what? That's all right. We got no hard feelings. Life is, you can't just, if you get angry, if you have a grudge, it's only hurting yourself. You have to let everything go. Be happy.
You're doing a great job, James. You're doing a great job.
Movie Theory, thanks for your super chat, who said, standing for truth already won, in all caps. Good job standing for truth. That's nice. Your mom sent a super chat.
I even paid her to say that too.
That's excellent. That's Deadly D1001. Thanks for your super chat, who said, I always pronounce Jensen's Jeansons? Nathaniel Jeanson.
Nobody really
Close
knows.
enough, James. Close enough.
Close
They
enough.
say
Yeah.
he uses somatic, not germline, substitution rate.
Right. So, I mean, I don't want to rehash and be redundant. We talked a lot about this in the discussion portion. So I would invite anybody to watch that. But Dr. Nathaniel Jensen has looked at a multitude of studies. You can see that in his book. You can see that in the endnotes. He's accounted for heteroplasmy. He's accounted for that which is somatic, dyads and triads. So it all converges as well. It all corroborates, and most importantly, he's made testable predictions. And specifically, the one on the stamp of human history is fruitful right now. You can see that it's working well. He's got a 10-part series. I'd recommend anyone watching it. So that's it.
You got it. And let's see, Dapper Dino is doing an after show of which he had said that they sent the link to Erica. So just so you know, we are happy to plug any after show for any debate that we have on Modern Day Debate. That includes like the big ones, like if you're like, hey, this one between, so-and-so, like let us know. And if you beforehand can give us a link, we'll put it in the description for you. And we'll do that for either side. So next up, thanks so much for your super chat from our dearest friend, Sphere itself, who says, Erica is wonderful at debating, so respectful.
Hey, I'm here to have a good time and engage in some fun discussion. And Standing and I have fun. We get along quite well. We get a little feisty, but Standing, we're on good terms. We're on good. I think I can count on one finger the number of bad experiences I've had with debating on YouTube. So
that's awesome. And let's get real. The audience likes when we get a bit feisty once in a while.
Hey,
so.
yeah, you gotta mix it up.
Right, yeah.
So true. And thanks for your super chat, Vandalia 1998. They had said, could the Y chromosome Noah and mitochondria Eve, you say, was 4,500 years ago, be for a local group of migrants and not for the entire human race?
Yeah, that's a good question, actually. So it wouldn't be the mitochondrial DNA. It would be the Y chromosome based on the fast mutation rate. Once again, Dr. Nathaniel Jensen, he's looked at some subsequent studies. I think there's been about 4, maybe 5. No, I think there's been about 4, one in 2009, another in 2015, and a couple more. He looked at studies based on high quality DNA and showed that Y chromosome atom is consistent with just 4,500 years ago. And as we know, according to the flood model, that would be Noah. So mutation accumulation shows just 4,500 years worth of Y chromosome. And I don't believe there's any real solid evidence that this was a population of, say, 10,000 or so. So good question.
Gotcha. And thanks for your super chat from Sphere itself, who says, oh yeah, James, we get it already. You're a sexy guy. You don't have to prove it every debate. Well, that's very nice. As I've mentioned, I think Sphere itself, it's just an alias for Earl, the 65-year-old postman from Alabama. So appreciate that every time, Earl. Michael Dresden, one of our regular trolls, thanks for your super chat, said, one cannot defend evolution and still be honest.
Ooh,
you know what? I've heard that. I've seen Michael around. Michael gets a little vitriolic sometimes. I think. If Michael would like to have a conversation with me, I do try to be as honest as I am capable of. I don't believe I've ever, at least here on Modern Day Debate, lied intentionally. But I do get things wrong. I definitely get things wrong.
Do not take Michael seriously. Michael will say anything and anything. So let's see. Next up, Caleb, as he sometimes likes to be called, says black rimmed glasses should be a requirement to appear on Modern Day Debate. I couldn't agree more. We have
I agree, James. We've been matching the past couple times. I don't think I've seen you without the glasses in a while.
It's
Maybe I'm
true.
thinking of different debates. I don't know.
You guys wear them well. You wear them well.
We're gonna have to put some
Fine.
black rim, the hipster glasses on your superhero standing for truth picture.
Believe it or not, I'm wearing the same type of glasses right now. So there you
Oh
go.
my gosh, so hip. Next
I
up,
copied James.
thanks for your super chat from Corporal Annan, who says, why would creation predict mosaics which agree with evolutionary expectations, i.e. Tiktaalik and not griffin or mermaid type mosaic forms?
A good question. I did explain briefly, I guess, in the discussion why we would predict mosaics. The majority proves the rule. You can point to a few, as I stated. Tiktaalik is one of them. And I believe when you actually go into detail on every single one of these transitionals, you'll find that they are not as strong evidence as the evolutionists would say. For example, Tiktaalik, since that's what he brought up, those claim tetrapod traits that are found, they're actually consistent with many living and extinct lobe-fin fish species today. And also they've discovered in Poland, it was tetrapod trackways that actually predates Tiktaalik by nearly 20 million years. So I think in regards to Tiktaalik, the evidence couldn't be any more clear. Tiktaalik was nothing more than a bottom-dwelling lobe-finned fish, and it suffers from what's called the grandfather paradox. So.
Standing, we should have a conversation about those Poland trackways. I've had a talk with someone about those at great length before, because they brought them to my attention. I didn't know about them, and so I did a deep dive on it. We should have a chat about that sometime.
Yeah. Hey, my channel anytime.
Gotcha. And thanks so much. Appreciate your super chat from Caleb again. Says, I guess Skylar is, I don't know, I don't understand this. I'm just confused. So I might have to come back to that one. I don't want to throw Skylar under the bus when he's not here to defend himself. Corporal Annan, thanks for your super chat, said, why would creation predict mosaic? Oh, yeah, that's embarrassing. Okay.
Sworn that we. Let me answer
one.
that. I'll go into it a different one.
Ha. Okay. Mothra J Disco, thanks for your super chat, says, this isn't really a debate because evolution is true.
Erica paid that person to say that one this time.
Everyone who's nice to me in the comments is a paid shill. Every single one.
Next up, Slam RN, thanks for your super chat. Really appreciate it. Said, for standing for truth, do you believe modern humans have Neanderthal DNA? And if yes, why would God allow interbreeding? Were they human when they were human? Also, what does Erica think about this?
So I guess I'll answer first. Yes, we do have Neanderthal DNA in our in our DNA, of course. You can look at our first debate where we kind of discussed a lot of the human evolution evidence and how it fits in our model. And we would explain, for example, Neanderthals, we'd explain as inbred subpopulations that broke off after Babel, and I think you can see this. I've got a paper that shows that the Neanderthal was highly inbred, had very high genetic load. You can see the same in Homo floresiensis, was very highly inbred. Actually, the hobbits seem to suffer from reductive evolution, and what that results in is reduced body size, reduced brain volume, and other pathologies. You can see this in Naledi. So yeah, it's a very easy answer. These populations of so-called subhumans like Neanderthal, hobbits, Naledi, they broke off after Babel. They were isolated, they inbred, and they experienced rapid genetic degeneration. So I think that can explain all the weird-looking morphological features. So hope that wasn't too long, James, but on to you there, Erica.
Yeah, I think it's interesting that you mentioned Naledi, because Naledi has very ape-like basal shoulders as well. So I find it interesting that the reductive evolution they experienced made them look more like chimpanzees. I would say absolutely yes. We at least according to my current knowledge, we know that 5 different hominins actually lived at the same time: Floresiensis, Naledi, Neanderthalensis. obviously sapiens, and depending on who you talk to, actually no, definitely Denisovans. I was thinking about, some people think maybe Heidelbergensis was still lurking around, but again, it depends. And of course they interbred. I mean, it's very interesting, but if you look into the potential hybridization ability or potential between humans and the living members of genus Pan, you will be unpleasantly surprised, because there really isn't a ton that prevents the fertilization from occurring. In fact, there was a recent very cool paper that came out in the past 6 months. I couldn't tell you when exactly. Time has been very much a weird void lately, thanks to everything that's going on. But that talked about how the human lineage and the Pan lineage actually probably interbred until about 4 million years ago. So we're talking, the Australopithecines, and their sort of version would have potentially been able to create viable offspring. So primates are weird. That's the answer.
Can I just respond real quick? It was my question. I should get the last word. James, I don't find you very fair today.
I don't know. They asked for both of you.
It's my question.
They asked for both of you, though.
Real quick, let me just respond to that. I've been pretty patient today.
Hey, don't blame me, Standing. I'm all for it. I've never objected.
I'll let you respond to this one as long as it's short and pithy.
It'll be very, very short. And we did allow Erica to take a few minutes extra on her. I mean, we've been easygoing tonight, I think. I think that those, like the curvature that's seen in some of the Naledi bones, the hands, the feet, the flaring hips, the small brain volume, for example. But the thing is, those secondary anatomical features in Naledi are actually not as unique as some evolutionists would say, because they're also seen in humans. Modern humans can develop curved finger bones due to heavy use in climbing or from habitual tool use, or modern humans with pathologies can have flaring hips, for example, and even the reduced body size. So I think reductive evolution can very well explain Naledi.
Gotcha. Thanks so much. Appreciate your
I appreciate it, James.
Your response. You bet. And Caleb, thanks for your super chat, who said, if evolution could be proven true, there wouldn't be a debate.
Is that one for me, perhaps? Maybe. Do
so.
I get a question? I think the very fact, no shade on you, Standing, but I think the very fact that we're still having flat Earth debates speaks volumes about that statement.
Gotcha. Thank you very much. Next up, Brandon Ardeline. Thanks for your super chat, who said, what was God thinking when he was coming up with the design for the I don't know how to pronounce this. This is embarrassing. ECH echidna's genitalia.
I think that question's for you, Erica.
Oh no, that's for you, Standing. That one's all you.
Sure, that's for you, Standing.
What's wrong with the genitalia?
I don't know. I'm not sure if I want to Google this, Standing.
It might get you put on a list. I don't know that. I don't know that nomenclature. I don't know what species that is. Okay. I'm going to be embarrassed with the primate.
Sometimes known as spiny anteaters.
Spiny anteaters. Yeah. If
do I really have to pull?
If you want to send us a source or something more detailed later, we can try and answer it off air.
Gotcha.
I'm not too sure what that is, to be honest with you.
You should know this, Standing. Okay.
I know. I'm sorry. But Erica, being such an intelligent individual, says she doesn't know either. So.
No, I didn't. That's true. I don't. Unfortunately for me, I don't know the Latin names for every single animal.
It sounds like a good question, though.
Gotcha. And thanks so much for your super chat from Trip4, who says Erica is the most knowledgeable, eloquent, cordial, and intellectually honest debater on this topic. Standing for Truth also did a good job defending his position.
Wow. And I didn't even pay that person to say that. I would say Erica is definitely one, I've said it before, one of the most, if not the most knowledgeable, I'm going to say evolutionist debater that there is. So that's why I've really enjoyed having 3 debates. Sometimes too many debates can be redundant, but with you, there's so much to talk. We can spend on one point, an entire debate. Like our second debate is all function.
Standing and I get along really well. We make a good debate duo just because I think we get a good flow going, and no one ever talks too much. I really genuinely mean that. I have fun every time we chat.
Gotcha.
Me too. I enjoyed this one.
Thanks so much for your super chat from our dearest friend John Lloyd, who says, quote, the chief distinction in the intellectual powers of the two species is shown by man attaining to a higher eminence in whatever he take up, then a woman can attain, unquote. And they say that they're quoting Darwin, Descent, I think Descent of Man, volume 2,
Yes.
327.
Yes. So Darwin, while very intelligent in many different rights, was also somewhat of a victim of his times in many ways. But I did look into his sort of. Someone had mentioned to me that Darwin was like wickedly sexist at one point, and I was like, "Huh, I'd never heard that claim before. I guess I'll look into it." And interestingly enough, if you look into his interactions with both his daughter and other up and coming female scientists, it does somewhat paint a different picture. So I wonder if his mind changed as he aged. But yes, Darwin was a dude in the 1800s. I'm not particularly surprised that he didn't think as highly of women as he did of men. But it's a shame, you know. I don't know. What are you gonna do? Don't meet your heroes.
Gotcha. Zach Brannigan, thanks for your super chat, who says, Erica's dedication to educating the misguided is amazing.
I paid him to say that.
Yeah, standing.
Well, they're saying you're misguided.
I know, that's the joke.
Okay,
I don't.
I paid the wrong person.
Okay.
Yeah, if that's for me, I do want to say that I definitely get the feeling. I think standing is genuinely trying to figure out what's going on. So I don't think you can ever call someone who seeks knowledge misguided.
Very sassy. I like it. And thanks for your super chat, who's from Excalibur, who said, so much better than some other debater that often comes on the show, and flat earthers. Just saying, quote, you are wrong. Stop it. Just stop. You're making stuff up. I added some of those. But if you
I need to debate a flat earther.
If you recognize those quotes, they say, with zero evidence, great debate, keep improving modern day debate. Well, all credit to the speakers. The speakers are what makes this channel fun, and as well as you guys all out there watching and engaging. So we appreciate it. And yeah, so that's a compliment to you, both Erica and Standing for Truth.
Very nice. I appreciate it.
Next up,
As do I.
Carmel Crunk. Thanks for your super chat. They're coming at you, Standing. They said, Saying for Truth, what do you think of Christians who confirm evolution? Or in other words, say it's true.
Who believe in evolution? I think they're misguided. I mean, salvation itself is obviously based on, faith in Jesus Christ. So you don't have to believe in old earth creation or young earth creation to be a Christian. But I think that they're giving up a perfectly good Bible for I don't even want to call it a theory, because it definitely doesn't fit in scripture. Of course, you got to force fit that type of belief into it. But I mean, it's not required for salvation. So I would just say they're misguided in the science aspect of it. So.
Gotcha. Thanks so much. Appreciate your super chat from Daniel Baker, who says, Erica, how do you feel when you bring up so much scientific evidence for your argument and creationists only ever counter with, quote, the Bible says blah, blah?
You know what? I do have to say, Standing has never responded to me that way. And very frequently our conversations that we have spur me to look into more of something that I didn't know about previously. For instance, our second conversation, he brought up Y chromosomes and the divergence there. And I didn't know. I didn't know the answer. And I'm sure you'll remember, I was like, I don't know the answer. But yes, those who do behave like that are missing out on a great conversation. And from my perspective, being someone who finds evolutionary theories so fascinating, I think they're missing out on some really cool science. And I've known some very excellent Christians who as Standing noted below, they accept evolution just fine. And so I guess that's all I have to say on that.
Very nice. That was very charitable.
Good answer. Good answer.
Next up, Serious Startups. Thanks for your super chat, who said, even though Standing for Truth won, Erica's performance confirms. I can't say it about. I love him. I hope Professor Dave is doing okay. It was a wild debate last night for those of you who tuned in.
I did see that.
That was one to remember. That's for sure.
That was.
Yeah.
That was a lot of fun. Caleb, thanks for your super chat, who said, "Be nice to Standing for Truth, James." All right, I'll take it easy on him.
Because of James, I cry myself to sleep Almost every night.
That's very thoughtful. Serious Startups, thanks for your super chat. Who said, this is their second, they said, James just likes to show off his chin. That's kind of you. I don't know. I always felt a little insecure when I was younger because I have this big butt chin. Do you notice that I have this like dimple? It's pretty massive. It's hard not to see it. But thanks. I mean, I don't know if you're making fun of me or not, but I'll take it. All right. Brandon Artolene, thanks for your super chat, who said, when creationists demand an example of a transitional species, why do they ignore lungfish, mud skippers, amphibians, porpoises, platypi, etc.?
So, well, I guess that question's for me. Why do we ignore those? I mean, the lungfish, the mud skippers, for example, I believe he just named a bunch of species that are alive and well today. So, I mean, I don't see them transitioning into anything right now. But when it comes to mosaics, when it comes to, I mean, we've talked a little bit about tiktaalik, for example, which we can elaborate on later. We do predict some mosaics based on the design model, just like we predict nested hierarchical patterns in anatomy, morphology, and physiology and genetics, for example. So we don't deny that some species that God may have created are odd in a way in mosaics, but yeah, I wouldn't say we deny them.
Gotcha. Thanks so much for your super chat from our dearest friend Nathan Artwork. Good to see you again. They said, oh, they're challenging your charitability, Erica. They want to play hardball tonight. So they said, if a person is arguing the wrong information, how are they not misguided?
Because I think that when it comes to being, whether you're misguided or not, rather, that was a bad way of phrasing that sentence. I think intention has to be taken into account. So even though I think Standing is wrong, I think that he makes a solid effort to figure out what's going on. And anytime someone does that, even if I do think perhaps maybe the answers they've come to are incorrect, or I guess you could call that misguided, I certainly don't think that the person themselves is, because I've certainly met a lot of, this is probably the one of the less charitable things you'll hear me say, but I've certainly met a lot of bad faith actors that I've at least interacted with, and you can usually call them on their cards decently quick into the conversation, and I don't think Standing's like that. So
gotcha. Very kind of you. I mean, I got nothing against him. He's all right. All right. Thanks for your super chat.
You'll have me back on again, James. That's sweet.
He's precious. He's I gotta give. So even though I was heavy-handed moderating tonight, I have to say I actually enjoy it more when I almost have to do that, because I don't think a debater has to be interrupting to be passionate, but it's at least a sign usually of passion, and so we do appreciate that. You got to give you credit.
Good moderating, James. I'll give you credit. You are a great moderator. You did good tonight.
That's kind of you. I appreciate that. However, someone may disagree with you. However, we may have Darth Dawkins back soon, or as he goes by now, I think the last time I saw it on Discord is Darth Mauling Atheists. Yes.
Oh my God.
Oh no.
Sassy. We love you, Darth, if you're listening. Carmel Crunk, thanks for your super chat, said natural selection, and this is a quote, natural selection and belief in God are not only non-contradictory, but they are inextricably linked and harmonious. Quote, Sygart, PhD.
Yeah, I mean, I think he's just stating one mechanism in the bigger picture, natural selection, of course. Natural selection, or better referred to as differential reproduction, keeps a species as strong as it can be. So based on our model of created genetic diversity, mechanisms such as natural selection, mutations even, genetic processes like recombination and gene conversion, these are all important according to our model, and evolution would probably say the exact same thing. Those mechanisms are important overall.
Gotcha.
Sygart's a cool guy. I would like to interject that.
Thanks for your super chat from Serious Startups, who says the chin point was a compliment. Bless your heart. Appreciate that. They said, but you've got to say beta. That was a really wild one last night. Like I said, I'm like, whew, that was something. Amazing. Okay.
Like I said,
amazing.
Amazing.
So thanks for your super chat from Dildo Baggins strikes again. I wonder.
He's at it again.
I don't know if it's a real name. Like, you think their parents call them that? I don't know. But they said standing for truth is like Saruman. Believing a lie will be your end.
Hey, all I gotta say is I like Lord of the Rings, so
We have that
Saruman is the bad guy, so. Oh, go ahead, Erica. Sorry.
No, I was going to say we have that in common. Standing and I have frequently had the discussion on which trilogy is better, Lord of the Rings or The Dark Knight. I've got my hand in on Lord of the Rings, but Standing flip flops. You flip flop sometimes.
It's a tough one. Yeah, I think it's whatever one I most recently watched.
Yeah.
But
yeah.
we'll have that debate in the future too. That'll be a good one.
Gotcha. And thanks for your super chat from last one that we've got here. This Nathan Artwork says maybe Erica should get into being a politician.
Oh no. What a giant pass I'm gonna take on that. Thank you. That's very kind of you. But
not a desired profession, eh?
No, that's not the world for me.
They meant it as a compliment though. Maybe they meant it as like the world needs more politicians like you.
Oh, listen, whether it's sweet or not, still.
You got it.
No thanks.
So thanks for that. We got to wrap up soon. I'm getting hot in this sauna. It's really warm in here. So I just thought it was funny. Somebody in the live chat, I can't remember who it was, said, "Is James in a sauna? Like a broken sauna?" So we want to say I am, and it's just terribly hot. But yes, thanks so much everybody for being here. The speakers are linked. I am going to get the link from Dapper Dino, which I think it may be in my email as well. Otherwise, I can put it in there from Standing for Truth or Erica. Thanks so much, everybody. Want to wish you a great night. One last time, I want to mention the speakers are linked in the description so you can hear more from them and keep sifting out the reasonable from the...
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.